down unnecessary shipping. Even without the use of electric power, the small workshop, because of some of the above facts, has survived all over the world, in defiance of the confident expectations of the early Victorian economists, marveling over the mechanical efficiency of the monster textile mills. With electricity, advantages of size from any point of view, except in possible special operations like the production of iron, becomes questionable. In the production of steel from scrap iron, the electric furnace may be used economically for operations on a much smaller scale than the blast furnace permits. Moreover, the weakest part mechanically of automatic production lies in the expense and hand labor involved in preparation for shipment. To the extent that a local market and a direct service does away with these operations, it removes a costly and completely uneducative form of work. Bigger no longer automatically means better. Flexibility of the power unit, closer adaptation of means to ends, nicer timing of operation, are the new marks of efficient industry. So far as concentration may remain, it is largely a phenomenon of the market, rather than of technics, promoted by astute financiers who see in the large organization an easier mechanism for their manipulations of credit, for their inflation of capital values, for their monopolistic controls. The electric power plant is not merely the driving force in the new technology, it is likewise perhaps one of the most characteristic end products, for it is in itself an exhibition of that complete automatism to which, as Mr. Fred Henderson and Mr. Walter Polakoff have ably demonstrated, our modern system of power production tends. From the movement of coal off the railroad truck or the coal barge, by means of a traveling crane, operated by a single man, to the stoking of the coal in the furnace by a mechanical feeder, power machinery takes the place of human energy. The worker, instead of being a source of work, becomes an observer and regulator of the performance of the machines, a supervisor of production rather than an active agent. Indeed, the direct control of the local worker is the same in principle as the remote control of the management itself, supervising, through reports and charts, the flow of power and goods to the entire plant. The qualities the new worker needs are alertness, responsiveness, an intelligent grasp of the operative parts. In short, he must be an all-round mechanic rather than a specialized hand. Short of complete automatism, this process is still a dangerous one for the worker, for partial automatism had been reached in the textile plants in England by the 1850s without any great release of the human spirit. But with complete automatism, freedom of movement and initiative return for that small part of the original working force now needed to operate the plant. Incidentally, it is interesting to note that one of the most important labor-saving and drudgery-saving devices, the mechanical firing of boilers, was invented at the height of the Paleotechnic period, in 1845. But it did not begin to spread rapidly in power plants until 1920, by which time coal had begun to feel competition from automatic oil burners. Another great economy invented in the same year 1845, the use of blast furnace gases for fuel, did not come in till much later. In all the neotechnic industries that produce completely standardized goods, automatism in operation is the goal toward which they tend. But, as Barnett points out, the displacing power of machines varies widely. One man on the stone planer is capable of producing as much as 8 men can produce by hand. One man on the semi-automatic bottle machine can make as many as 4 hand blowers. A linotype operator can set up as much matter as 4 hand compositors. The Owens bottle machine in its latest form is capable of an output per operative equal to that of 18 hand blowers. To which one may add that in the automatic telephone exchange the number of operators has been reduced about 80%, and in an American textile plant a single worker can look after 1,200 spindles. While the deadliest form of high-paced, piecemeal, unvaried labor still remain in many so-called advance industries, like the straight-line assemblage of Ford cars, a form of work as dehumanized and as backward as any practiced in the worst manufacturing processes of the 18th century. While this is true, in the really neotechnic industries and processes the worker has been almost eliminated. Power production and automatic machines have steadily been diminishing the worker's importance in factory production. 2 million workers were cast out between 1919 and 1929 in the United States, while production itself actually increased. Less than a tenth of the population of the United States is sufficient to produce the bulk of its manufactured goods and its mechanical services. Benjamin Franklin figured that in his day the spread of work and the elimination of the kept classes would enable all the necessary production to be accomplished with an annual toll of 5 hours per worker per day. Even with our vast increase in consumptive standards, both in intermediate machines and utilities and in final goods, a fragment of that time would probably suffice for a neotechnic industry, if it were organized efficiently on a basis of steady, full-time production. Parallel to the advances of electricity and metallurgy from 1870 onward were the advances that took place in chemistry. Indeed, the emergence of the chemical industries after 1870 is one of the definite signs of the neotechnic order, since the advance beyond the age-old empirical methods used, for example, in distilling and in the manufacture of soap naturally was limited by the pace of science itself. Chemistry not merely assumed a relatively larger share in every phase of industrial production from metallurgy to the fabrication of artificial silk, but the chemical industries themselves, by their very nature, exhibited the characteristic neotechnic features a whole generation before mechanical industry showed them. Here Maturé's figures, though they are almost a generation old, are still significant. In the advanced mechanical industries only 2.8% of the entire personnel were technicians. In the old-fashioned chemical industries, such as vinegar works and breweries, there were 2.9%, but in the more recent chemical industries, dyes, starch products, gas works, and so forth, 7.1% of the personnel were technicians. Similarly, the processes themselves tend to be automatic, and the percentage of workers employed is smaller than even in advanced machine industries, while workers who supervise them must have similar capacities to those at the remote control boards of a power station or a steamship. Here, as in neotechnic industry generally, advances in production increase the number of trained technicians in the laboratory and decrease the number of human robots in the plant. In short, one witnesses in the chemical processes apart from the ultimate packaging and boxing the general change that characterizes all genuinely neotechnic industry, the displacement of the proletariat. That these gains in automatism and power have not yet been assimilated by society is plain, and I shall revert to the problem here presented in the final chapter. 5. Neotechnic materials. Just as one associates the wind and water power of the eotechnic economy with the use of wood and glass, and the coal of the Paleotechnic period with iron, so does electricity bring into wide industrial use its own specific materials, in particular, the new alloys, the rare earths, and the lighter metals. At the same time, it creates a new series of synthetic compounds that supplement paper, glass, and wood, celluloid, vulcanite, bakelite, and the synthetic resins, with special properties of unbreakability, electrical resistance, imperviousness to acids, or elasticity. Among the metals, electricity places a premium upon those that have a high degree of conductivity, copper and aluminum. Area for area, copper is almost twice as good a conductor as aluminum, but weight for weight aluminum is superior to any other metal, even silver, while iron and nickel are practically useless except where resistance is needed, as for example in electric heating. Perhaps the most distinctively neotechnic metal is aluminum, for it was discovered in 1825 by the Dane, Ørsted, one of the fruitful early experimenters with electricity, and it remained a mere curiosity of the laboratory through the High Paleotechnic period. It was not until 1886, the decade that saw the invention of the motion picture and the discovery of the Hertzian wave, that patents for making aluminum commercially were taken out. One need not wonder at aluminum's slow development, for the commercial process of extraction is dependent upon the use of large quantities of electric energy. The principal cost of reducing the aluminum ore by the electrolytic process is the use of from 10 to 12 kilowatt-hours of energy for every pound of metal recovered. Hence the industry must naturally attach itself to a cheap source of electric power. Aluminum is the third most abundant element on the Earth's crust, following oxygen and silicon, but at present it is manufactured chiefly from its hydrated oxide, bauxite. If the extraction of aluminum from clay is not yet commercially feasible, no one can doubt that an effective means will eventually be found, hence the supply of aluminum is practically inexhaustible, all the more because its slow oxidation permits society to build up steadily a reserve of scrap metal. This entire development has taken place over a period of little more than 40 years, those same 40 years that saw the introduction of central power plants and multiple motor installations in factories, and while copper production in the last 20 years has increased a good 50%, aluminum production has increased during the same period 316%. Everything from typewriter frames to airplanes, from cooking vessels to furniture, can now be made of aluminum and its stronger alloys. With aluminum, a new standard of lightness is set, a dead weight is lifted from all forms of locomotion, and the new aluminum cars for railroads can attain a higher speed with a smaller output of power. If one of the great achievements of the Paleotechnic period was the translation of clumsy wooden machines into stronger and more accurate iron ones, one of the chief tasks of the Neotechnic period is to translate heavy iron forms into lighter aluminum ones. And just as the technique of water power and electricity had an effect in reorganizing even the coal consumption and steam production of power plants, so the lightness of aluminum is a challenge to more careful and more accurate design in such machines and utilities as still use iron and steel. The gross oversizing of standard dimensions, with an excessive factor of safety based upon a judicious allowance for ignorance, is intolerable in the finer design of airplanes, and the calculations of the airplane engineer must in the end react back upon the design of bridges, cranes, steel buildings. In fact, such a reaction is already in evidence. Instead of bigness and heaviness being a happy distinction, these qualities are now recognized as handicaps. Lightness and compactness are the emergent qualities of the Neotechnic era. The use of the rare metals and the metallic earths is another characteristic advance of this phase. Tantalum, tungsten, thorium, and cerium in lamps, iridium and platinum in mechanical contact points, the tips of fountain pens or the attachments in removable dentures, and of nickel, vanadium, tungsten, manganese, and chromium in steel. Selenium, whose electrical resistance varies inversely with the intensity of light, was another metal which sprang into wide use with electricity. Automatic counting devices and electric door openers are both possible by reason of this physical property. As a result of systematic experiment in metallurgy, a revolution took place here comparable to that which was involved in the change from the steam engine to the dynamo. For the rare metals now have a special place in industry, and their careful use tends to promote habits of thrift even in the exploitation of the commoner minerals. Thus the production of rustless steel will decrease the erosion of steel and add to the metal worth redeeming from the scrap heap. Already the supply of steel is so large and its conservation has at last become so important that over half the burden of the open hearth furnaces in the United States is scrap metal, and the open hearth process now takes care of 80% of the domestic steel production. The rare elements, most of which were undiscovered until the 19th century, cease to be curiosities or to have, like gold, chiefly a decorative or honorific value. Their importance is out of all proportion to their bulk. The significance of minute quantities, which we shall note again in physiology and medicine, is characteristic of the entire metallurgy and techniques of the new phase. One might say, for dramatic emphasis, that Paleotechnics regarded only the figures to the left of the decimal, whereas Neotechnics is preoccupied with those to the right. There is still another important consequence of this new complex. While certain products of the Neotechnic phase, like glass, copper, and aluminum, exist like iron in great quantities, there are other important materials: asbestos, mica, cobalt, radium, uranium, thorium, helium, cerium, molybdenum, tungsten, which are exceedingly rare, or which are strictly limited in their distribution. Mica, for example, has unique properties that make it indispensable in the electrical industry: its regular cleavage, great flexibility, elasticity, transparency, non-conductivity of heat and electricity, and general resistance to decomposition make it the best possible material for radio condensers, magnetos, spark plugs, and other necessary instruments, but while it has a fairly wide distribution, there are important parts of the earth that are completely without it. Manganese, one of the most important alloys for hard steel, is concentrated chiefly in India, Russia, Brazil, and the Gold Coast of Africa. With tungsten, 70% of the supply comes from South America and 9.3% from the United States. As for chromite, almost half the present supply comes from South Rhodesia, 12.6% from New Caledonia, and 10.2% from India. The rubber supply, similarly, is still limited to certain tropical or subtropical areas, notably Brazil and the Malayan archipelago. Note the importance of these facts in the scheme of world commodity flow. Both Eotechnic and Paleotechnic industry could be carried on within the framework of European society. England, Germany, France, the leading countries, had a sufficient supply of wind, wood, water, limestone, coal, iron ore, so did the United States. Under the Neotechnic regime, their independence and their self-sufficiency are gone. They must either organize and safeguard and conserve a worldwide basis of supply, or run the risk of going destitute and relapse into a lower and cruder technology. The basis of the material elements in the new industry is neither national nor continental but planetary. This is equally true, of course, of its technological and scientific heritage. A laboratory in Tokyo or Calcutta may produce a theory or an invention which will entirely alter the possibilities of life for a fishing community in Norway. Under these conditions, no country and no continent can surround itself with a wall without wrecking the essential, international basis of its technology. So if the Neotechnic economy is to survive, it has no other alternative than to organize industry and its polity on a worldwide scale. Isolation and national hostilities are forms of deliberate technological suicide. The geographical distribution of the rare earths and metals by itself almost establishes that fact. One of the greatest of Neotechnic advances is associated with the chemical utilization of coal. Coal tar, once the unfortunate refuse of the Paleotechnic type of beehive coke oven, became an important source of wealth. From each ton of coal, the byproduct oven produces approximately 1,500 pounds of coke, 111,360 cubic feet of gas, 12 gallons of tar, 25 pounds of ammonium sulfate, and 4 gallons of light oils. Through the breakdown of coal tar itself, the chemist has produced a host of new medicines, dyes, resins, and even perfumes. As with advances in mechanization, it has tended to provide greater freedom from local conditions, from the accidents of supply and the caprices of nature. Though a plague in silkworms might reduce the output of natural silk, artificial silk, which was first successfully created in the 80s, could partly take its place. But while chemistry set itself the task of imitating or reconstructing the organic, ironically its first great triumph was Wohler's production of urea in 1825. Certain organic compounds for the first time became important in industry, so that one cannot without severe qualification accept Sombert's characterization of modern industry as the supplanting of organic materials with inorganic ones. The greatest of these natural products was rubber, out of which the Indians of the Amazon had, by the 16th century, created shoes, clothes, and hot water bottles, to say nothing of balls and syringes. The development of rubber is exactly contemporary to that of electricity, even as cotton in Western Europe exactly parallels the steam engine, for it was Faraday's isolation of benzene, and the later use of naphtha, that made its manufacture possible elsewhere than at its place of origin. The manifold uses of rubber, for insulation, for phonograph records, for tires, for soles and heels of shoes, for rainproof clothing, for hygienic accessories, for the surgeon's gloves, for balls used in play give it a unique place in modern life. Its elasticity and impermeability and its insulating qualities make it a valuable substitute, on occasion, for fiber, metal, and glass, despite its low melting point. Rubber constitutes one of the great capital stocks of industry, and reclaimed rubber, according to Zimmerman, formed from 35 to 51% of the total rubber production in the United States between 1925 and 1930. The use of corn and cane stalks for composite building materials and for paper illustrates another principle, the attempt to live on current energy income, instead of on capital in the form of trees and mineral deposits. Almost all these new applications date since 1850, most of them came after 1875, while the great achievements in colloidal chemistry have come only within our own generation. We owe these materials and resources quite as much to fine instruments and laboratory apparatus as we do to power machinery. Plainly, Marx was in error when he said that machines told more about the system of production that characterized an epoch than its utensils and utilities did, for it would be impossible to describe the neotechnic phase without taking into account various triumphs in chemistry and bacteriology in which machines played but a minor part. Perhaps the most important single instrument that the later neotechnic period has created is the three-element oscillator or amplifier developed by de Forest out of the Fleming valve, a piece of apparatus in which the only moving parts are electric charges. The movement of limbs is more obvious than the process of osmosis, but they are equally important in human life, and so too the relatively static operations of chemistry are as important to our technology as the more obvious engines of speed and movement. Today our industry owes a heavy debt to chemistry, tomorrow it may incur an even heavier debt to physiology and biology, already, in fact, it begins to be apparent. 6. Power and mobility. Only second in importance to the discovery and utilization of electricity was the improvement that took place in the steam engine and the internal combustion engine. At the end of the 18th century, Dr. Erasmus Darwin, who anticipated so many of the scientific and technical discoveries of the 19th century, predicted that the internal combustion engine would be more useful than the steam engine in solving the problem of flight. Petroleum, which was known and used by the ancients, and which was exploited in America as a quack Indian medicine, was tapped by drilling wells, for the first time in the modern period, in 1859, after that it was rapidly exploited. The value of the lighter distillates as fuels was equaled only by that of the heavier oils as lubricants. From the 18th century onward the gas engine was the subject of numerous experiments, even the use of powdered explosives, on the analogy of cannon fire, was tried, and the gas engine was finally perfected by Otto in 1876. With the improvement of the internal combustion engine a vast new source of power was opened up, fully equal to the old coal beds in importance, even if doomed to be consumed at a possibly more rapid rate. But the main point about fuel oil, used by the later diesel engine, and gasoline was their relative lightness and transportability. Not merely could they be conveyed from well to market by permanent pipelines but, since they were liquids, and since the vaporizations and combustion of the fuel left little residue in comparison with coal, they could be stowed away easily, in odds and ends of space where coal could not be placed or reached. Being fed by gravity or pressure, the engine had no need for a stoker. The effect of introducing liquid fuel and of mechanical stokers for coal, in electric power plants, and on steamships, was to emancipate a race of galley slaves, the stokers, those miserable driven men whose cruel work Eugene O'Neill properly took as the symbol of proletarian oppression in his drama, The Hairy Ape. Meanwhile, the efficiency of the steam engine was raised. The invention of Par-Sun's steam turbine in 1884 increased the efficiency of the steam engine from 10 or 12 for the old reciprocating engine to a good 30% for the turbine, and the later use of mercury vapor instead of steam in turbines raised this to 41.5%. How rapid was the advance in efficiency may be gauged from the average consumption of coal in power stations. It dropped from 3.2 pounds per kilowatt-hour in 1913 to 1.34 pounds in 1928. These improvements made possible the electrification of railroads even where cheap water power could not be secured. The steam engine and the internal combustion engine raced neck and neck, in 1892, by utilizing a more scientific mode of combustion, through the compression of air alone. Diesel invented an improved type of oil engine which has been built in units as large as 15,000 brake horsepower, as in the generating plant at Hamburg. The development of the smaller internal combustion engine during the 80s and 90s was equally important for the perfection of the automobile and the airplane. Neotechnic transportation awaited this new form of power, in which all the weight should be represented by the fuel itself, instead of carrying, like the steam engine, the additional burden of water. With the new automobile, power and movement were no longer chained to the railroad line. A single vehicle could travel as fast as a train of cars. Again, the smaller unit was as efficient as the larger one. I put aside the technical question as to whether, with oil as fuel, the steam engine might not have competed effectively with the internal combustion engine, and whether it may not, in an improved and simplified form, re-enter the field. The social effects of the automobile and the airplane did not begin to show themselves on any broad scale until around 1910, the flight of Blériot across the English Channel in 1909 and the introduction of the cheap, mass-produced motor car by Henry Ford were significant turning points. But what happened here, unfortunately, is what happened in almost every department of industrial life. The new machines followed, not their own pattern, but the pattern laid down by previous economic and technical structures. Early the new motor car was called a horseless carriage. It had no other point of resemblance then. The fact that it ran on wheels, it was a high-powered locomotive, equivalent to from 5 to 100 horses in power, capable of safe speeds up to 60 miles an hour, as soon as the cord tire was invented, and having a daily cruising radius of 2 to 300 miles. This private locomotive was set to running on the old-fashioned dirt roads or macadam highways that had been designed for the horse and wagon, and though after 1910 these highways were widened and concrete took the place of lighter materials for the surface, the pattern of the transportation lines remained what it had been in the past. All the mistakes that had been made in the railroad building period were made again with this new type of locomotive. Main highways cut through the center of towns, despite the congestion, the friction, the noise, and the dangers that attended this old paleotechnic practice. Treating the motor car solely as a mechanical object, its introducers made no attempt to introduce appropriate utilities which would realize its potential benefits. Had anyone asked in cold blood, as Professor Morris Cohen has suggested, whether this new form of transportation would be worth the yearly sacrifice of 30,000 lives in the United States alone, to say nothing of the injured and the maimed, the answer would doubtless have been no. But the motor car was pumped onto the market at an accelerating rate, by businessmen and industrialists who looked for improvements only in the mechanical realm, and who had no flair for inventions on any other plane. Mr. Benton Mackay has demonstrated that fast transportation, safe transportation, and pedestrian movement, and sound community building are parts of a single process. The motor car demanded for long-distance transportation the townless highway, with stations for entrance and exit at regular intervals and with overpasses and underpasses for major cross-traffic arteries. Similarly, for local transportation, it demanded the highwayless town, in which no neighborhood community would be split apart by major arteries or invaded by the noise of through traffic. Even from the standpoint of speed by itself, the solution does not rest solely with the automotive engineer. A car capable of 50 miles an hour on a well-planned road system is a faster car than one that can do 100 miles an hour, caught in the muddle and congestion of an old-fashioned highway net, and so reduced to 20 miles per hour. The rating of a car at the factory, in terms of speed and horsepower, has very little to do with its actual efficiency. In short, the motor car is as inefficient without its appropriate utilities as the electric power plant would be if the conducting units were iron wire rather than copper. Developed by a society so preoccupied with purely mechanical problems and purely mechanical solutions themselves determined largely by speed in achieving financial rewards to the investing classes, the motor car has never attained anything like its potential efficiency except here and there in the remote rural regions. Cheapness and quantity production, combined with the extravagant rebuilding of old-fashioned highway systems, with here and there honorable exceptions, as in New Jersey, Michigan and Westchester County, New York, have only increased the inefficiency of motor cars in use. The losses from congestion, both in the crowded and hopelessly entangled metropolises, and along the roads by means of which people attempt to escape the cities on holidays, are incalculably large in countries which, like the United States and England, have taken over the motor car most heedlessly and complacently. This weakness in the development of neotechnic transportation has come out during the last generation in still another relationship, the geographic distribution of the population. Both the motor car and the airplane have a special advantage over the ordinary steam locomotives. The second can fly over areas that are impassable to any other mode of transportation, and the first can take easily grades which are prohibitive to the ordinary steam locomotive. By means of the motor car, the upland areas, where electric power can be cheaply produced, and where the railroad enters at a considerable disadvantage, can be thrown open to commerce, industry, and population. These uplands are likewise often the most salubrious seat of living, with their fine scenery, their bracing ionized air, their range of recreation, from mountain climbing and fishing to swimming and ice skating. Here is, I must emphasize, the special habitat of the neotechnic civilization, as the low coastal areas were for the eotechnic phase, and the valley bottoms and coal beds were for the paleotechnic period. Population, nevertheless, instead of being released into these new centers of living, has continued in many countries to flow into the metropolitan centers of industry and finance. The motor car served to facilitate this congestion instead of dispelling it. In addition, because of the very spread of the overgrown centers, the flying fields could be placed only at the extreme outskirts of the bigger cities, on such remaining land as had not been built upon or chopped into suburban subdivisions, so that the saving in time through the swiftness and shortcuts of airplane travel is often counterbalanced, on short flights, by the length of time it takes to reach the center of the big city from the flying fields on the outskirts. 7. The paradox of communication. Communication between human beings begins with the immediate physiological expressions of personal contact, from the bowlings and cooings and head turnings of the infant to the more abstract gestures and signs and sounds out of which language, in its fullness, develops. With hieroglyphics, painting, drawing, the written alphabet, there grew up during the historic period a series of abstract forms of expression which deepened and made more reflective and pregnant the intercourse of men. The lapse of time between expression and reception had something of the effect that the arrest of action produced in making thought itself possible. With the invention of the telegraph, a series of inventions began to bridge the gap in time between communication and response despite the handicaps of space, first the telegraph, then the telephone, then the wireless telegraph, then the wireless telephone, and finally television. As a result, communication is now on the point of returning, with the aid of mechanical devices, to that instantaneous reaction of person to person with which it began, but the possibilities of this immediate meeting, instead of being limited by space and time, will be limited only by the amount of energy available and the mechanical perfection and accessibility of the apparatus. When the radio telephone is supplemented by television, communication will differ from direct intercourse only to the extent that immediate physical contact will be impossible. The hand of sympathy will not actually grasp the recipient's hand, nor the raised fist fall upon the provoking head. What will be the outcome? Obviously, a widened range of intercourse, more numerous contacts, more numerous demands on attention and time. But unfortunately, the possibility of this type of immediate intercourse on a worldwide basis does not necessarily mean a less trivial or a less parochial personality. For over against the convenience of instantaneous communication is the fact that the great economical abstractions of writing, reading, and drawing, the media of reflective thought and deliberate action, will be weakened. Men often tend to be more socialized at a distance than they are in their immediate, limited, and local selves. Their intercourse sometimes proceeds best, like barter among savage peoples, when neither group is visible to the other. That the breadth and too frequent repetition of personal intercourse may be socially inefficient is already plain through the abuse of the telephone. A dozen 5-minute conversations can frequently be reduced in essentials to a dozen notes whose reading, writing, and answering takes less time and effort and nervous energy than the more personal calls. With the telephone, the flow of interest and attention, instead of being self-directed, is at the mercy of any strange person who seeks to divert it to his own purposes. One is faced here with a magnified form of a danger common to all inventions, a tendency to use them whether or not the occasion demands. Thus our forefathers used iron sheets for the fronts of buildings, despite the fact that iron is a notorious conductor of heat. Thus people gave up learning the violin, the guitar, and the piano when the phonograph was introduced, despite the fact that the passive listening to records is not in the slightest degree the equivalent of active performance. Thus the introduction of anesthetics increased fatalities from superfluous operations. The lifting of restrictions upon close human intercourse has been, in its first stages, as dangerous as the flow of populations into new lands. It has increased the areas of friction. Similarly, it has mobilized and hastened mass reactions, like those which occur on the eve of a war, and it has increased the dangers of international conflict. To ignore these facts would be to paint a very falsely over-optimistic picture of the present economy. Nevertheless, instantaneous personal communication over long distances is one of the outstanding marks of the neotechnic phase. It is the mechanical symbol of those worldwide cooperations of thought and feeling which must emerge, finally, if our whole civilization is not to sink into ruin. The new avenues of communication have the characteristic features and advantages of the new techniques, for they imply, among other things, the use of mechanical apparatus to duplicate and further organic operations. In the long run, they promise not to displace the human being but to refocus him and enlarge his capacities. But there is a proviso attached to this promise, namely, that the culture of the personality shall parallel in refinement the mechanical development of the machine. Perhaps the greatest social effect of radio communication, so far, has been a political one, the restoration of direct contact between the leader and the group. Plato defined the limits of the size of a city as the number of people who could hear the voice of a single orator. Today those limits do not define a city but a civilization. Wherever neotechnic instruments exist and a common language is used, there are now the elements of almost as close a political unity as that which once was possible in the tiniest cities of Attica. The possibilities for good and evil here are immense. The secondary personal contact with voice and image may increase the amount of mass regimentation, all the more because the opportunity for individual members reacting directly upon the leader himself, as in a local meeting, becomes farther and farther removed. At the present moment, as with so many other neotechnic benefits, the dangers of the radio and the talking picture seem greater than the benefits. As with all instruments of multiplication, the critical question is as to the function and quality of the object one is multiplying. There is no satisfactory answer to this on the basis of techniques alone, certainly nothing to indicate, as the earlier exponents of instantaneous communication seem pretty uniformly to have thought, that the results will automatically be favorable to the community. 8. The new permanent record. Man's culture depends for its transmission in time upon the permanent record, the building, the monument, the inscribed word. During the early neotechnic phase, vast changes were made here, as important as those brought about 500 years earlier through the invention of wood engraving, copper etching, and printing. The black and white image, the color image, the sound, and the moving image were translated into permanent records, which could be manifold, by mechanical and chemical means. In the invention of the camera, the phonograph, and the moving picture, the interplay of science and mechanical dexterity, which has already been stressed, was again manifested. While all these new forms of permanent record were first employed chiefly for amusement, and while the interest behind them was aesthetic rather than narrowly utilitarian, they had important uses in science, and they even reacted upon our conceptual world as well. The photograph, to begin with, served as an independent objective check upon observation. The value of a scientific experiment lies partly in the fact that it is repeatable and thus verifiable by independent observers, but in the case of astronomical observations, for example, the slowness and fallibility of the eye can be supplemented by the camera, and the photograph gives the effect of repetition to what was, perhaps, a unique event, never to be observed again. In the same fashion, the camera gives an almost instantaneous cross-section of history, arresting images in their flight through time. In the case of architecture, this mechanical copying on paper led to unfortunately similar artifices in actual buildings, and instead of enriching the mind left a trail of arrested images in the form of buildings all over the landscape. For history is non-repeatable, and the only thing that can be rescued from history is the note that one takes and preserves at some moment of its evolution. To divorce an object from its integral time sequence is to rob it of its complete meaning, although it makes it possible to grasp spatial relations which may otherwise defy observation. Indeed, the very value of the camera as a reproducing device is to present a memorandum, as it were, of that which cannot in any other fashion be reproduced. In a world of flux and change, the camera gave a means of combating the ordinary processes of deterioration and decay, not by restoration or reproduction but by holding in convenient form the lean image of men, places, buildings, landscapes, thus serving as an extension of the collective memory. The moving picture, carrying a succession of images through time, widened the scope of the camera and essentially altered its function, for it could telescope the slow movement of growth, or prolong the fast movement of jumping, and it could keep in steady focus events which could not otherwise be held in consciousness with the same intensity and fixity. Heretofore records had been confined to snatches of time, or, when they sought to move with time itself, they were reduced to abstractions. Now they could become continuous images of the events they represented. So the flow of time ceased to be representable by the successive mechanical ticks of the clock, its equivalent, and Bergson was quick to seize this image was the motion picture reel. One may perhaps overrate the changes in human behavior that followed the invention of these new devices, but one or two suggest themselves. Whereas in the Technic phase one conversed with the mirror and produced the biographical portrait and the introspective biography, in the Neotechnic phase one poses for the camera, or still more, one acts for the motion picture. The change is from an introspective to a behaviorist psychology, from the fulsome sorrows of Werther to the impassive public mask of an earnest Hemingway. Facing hunger and death in the midst of a wilderness, a stranded aviator writes in his notes, "I built another raft, and this time took off my clothes to try it. I must have looked good, carrying the big logs on my back in my underwear." Alone, he still thinks of himself as a public character, being watched, and to a greater or less degree everyone, from the crone in a remote hamlet to the political dictator on his carefully prepared stage, is in the same position. This constant sense of a public world would seem in part, at least, to be the result of the camera and the camera eye that developed with it. The eye be absent in reality, one improvises it wryly with a fragment of one's consciousness. The change is significant, not self-examination, but self-exposure, not tortured confession but easy open candor, not the proud soul wrapped in his cloak, pacing the lonely beach at midnight, but the matter-of-fact soul, naked, exposed to the sun on the beach at noonday, one of a crowd of naked people. Such reactions are, of course, outside the realm of proof, and even if the influence of the camera were directly demonstrable, there is little reason to think that it is final. Need I stress again that nothing produced by Technics is more final than the human needs and interests themselves that have created Technics? Whatever the cycle reactions to the camera and the moving picture and the phonograph may be, there is no doubt, I think, as to their contribution to the economic management of the social heritage. Before they appeared, sound could only be imperfectly represented in the conventions of writing. It is interesting to note that one of the best systems, Bell's visible speech, was invented by the father of the man who created the telephone. Other than written and printed documents and paintings on paper, parchment, and canvas, nothing survived of a civilization except its rubbish heaps and its monuments, buildings, sculptures, works of engineering, all bulky, all interfering more or less with the free development of a different life in the same place. By means of the new devices this vast mass of physical impedimenta could be turned into paper leaves, metallic or rubber discs, or celluloid films which could be far more completely and far more economically preserved. It is no longer necessary to keep vast middens of material in order to have contact, in the mind, with the forms and expressions of the past. These mechanical devices are thus an excellent ally to that other new piece of social apparatus which became common in the 19th century, the public museum. They gave modern civilization a direct sense of the past and a more accurate perception of its memorials than any other civilization had, in all probability, had. Not alone did they make the past more immediate, they made the present more historic by narrowing the lapse of time between the actual events themselves and their concrete record. For the first time one might come face to face with the speaking likenesses of dead people and recall in their immediacy. 1. Maudslay's original screw-cutting lathe, invented about 1800. Perhaps the most original artists of the period were the toolmakers, who translated the old wooden machines into metal, who perfected and standardized the component parts, and who solved some of the other difficult mechanical problems. Courtesy of the director, the Science Museum, London. 2. The Brooklyn Bridge. 1869 to 1883. Great mass juxtaposed to great delicacy, an adroit solution for a difficult problem. The builders, John A. and Washington Roebling, deserve to be ranked in that great succession of Paleotechnic engineers, beginning with Smeaton and Rennie, and including Telford, the Brunels, Samuel Bentham, and Eiffel. Courtesy of Catherine Bauer. 3. The machine hall at the Paris Exposition of 1889 was one of the finest engineering structures. Technically it went beyond any of the existing train sheds in refinement of design. Created by an architect, Dudert, and an engineer, Contamin, it had perhaps greater significance than the more daring Eiffel Tower done at the same time. Note that the American steel frame skyscraper was a product of the same period. 4. A modern steamship, still essentially Paleotechnic in design, but with all the cleanness and strength of the older type of engineering. Like so many other typical Paleotechnic products, it was afflicted by giantism. In its inner arrangements, with the luxury and space of the first class contrasting with the cramped quarters and poorer fare of the third class, the big ocean steamship remains a diagrammatic picture of the Paleotechnic class struggle. Photographed by Ewing Galloway. Forgotten scenes and actions. Faust bartered his soul with Mephistopheles to see Helen of Troy. On much easier terms it will be possible for our descendants to view the Helens of the 20th century. Thus a new form of immortality was effected, and a late Victorian writer, Samuel Butler, might well speculate upon how completely a man was dead when his words, his image, and his voice were still capable of being resurrected and could have a direct effect upon the spectator and listener. At first these new recording and reproducing devices have confused the mind and defied selective use. No one can pretend that we have yet employed them, in any sufficient degree, with wisdom, or even with ordered efficiency. But they suggest a new relationship between deed and record, between the movement of life and its collective enregistration. Above all, they demand a nicer sensitiveness and a higher intelligence. If these inventions have so far made monkeys of us, it is because we are still monkeys. 9. Light and life. Light shines on every part of the neotechnic world, it filters through solid objects, it penetrates fog, it glances back from the polished surfaces of mirrors and electrodes. And with light, color comes back and the shape of things, once hidden in fog and smoke, becomes sharp as crystal. The glass Technics, which had reached its first summit of mechanical perfection in the Venetian mirror, now repeats its triumphs in 100 different departments. Quartz alone is its rival. In the neotechnic phase the telescope and above all the microscope assume a new importance, for the latter had been left in practical disuse for 2 centuries, but for the extraordinary work of Leeuwenhoek and Spallanzani. To these instruments must be added the spectroscope and the X-ray tube, which also utilized light as an instrument of exploration. Clerk Maxwell's unification of electricity and light is perhaps the outstanding symbol of this new phase. The fine discrimination of color exhibited by Monet and his fellow Impressionists, working in the open air and the sunlight, was repeated in the laboratory, spectrum analysis and the production of a multitude of aniline dyes derived from coal tar conservation are specifically neotechnic achievements. Now color, hitherto relegated to an unimportant place as a secondary characteristic of matter, becomes an important factor in chemical analysis, with the discovery that each element has its characteristic spectrum. The new dyes, moreover, find their use in the bacteriologist's laboratory for staining specimens. Some of them, like gentian violet, have a place as antiseptics, and still others as medicaments in the treatment of certain diseases. The dark blind world of the machine, the miner's world, began to disappear. Heat, light, electricity, and finally matter were all manifestations of energy, and as one pursued the analysis of matter further, the old solids became more and more tenuous, until finally they were identified with electric charges, the ultimate building stones of modern physics, as the atom was of the older physical theories. The imperceptible, the ultraviolet, and the infrared series of rays became commonplace elements in the new physical world at the moment that the dark forces of the unconscious were added to the purely external and rationalized psychology of the human world. Even the unseen was, so to say, illuminated. It was no longer unknown. One might measure and use what one could not see and handle. And while the paleotechnic world had used physical blows and flame to transform matter, the neotechnic was conscious of other forces equally potent under other circumstances: electricity, sound, light, invisible rays and emanations. The mystic's belief in a human aura became as well substantiated by exact science as the alchemist's dream of transmutation was through the Curie's isolation of radium. The cult of the sun, so dear to Kepler at the beginning of these revolutionary scientific developments, emerged again. The exposure of the naked body to the sun helped, it was found, to prevent rickets and to cure tuberculosis, while direct sunlight sanitated water and reduced the number of pathogenic bacteria in the environment generally. With this new knowledge, founded upon that renewed study of the organism which Pasteur's discoveries promoted, the essentially anti-vital nature of the paleotechnic environment became plain, the darkness and dampness of its typical mines and factories and slum homes were ideal conditions for breeding bacteria, while its devitalized diet resulted in a poor bony structure, defective teeth, and weakened resistance to disease. The full effects of these conditions were amply documented in the examinations for recruits in the British Army toward the end of the century, results which came out with special clearness because of the predominant urbanization of England. But the Massachusetts mortality tables told the same story. The farmer's length of life was far greater than the industrial workers. Thanks to neotechnic inventions and discoveries, the machine became, for perhaps the first time, a direct ally of life, and in the light of this new knowledge its previous misdemeanors became more grotesque and incredible. Mathematical accuracy, physical economy, chemical purity, surgical cleanliness, these are some of the attributes of the new regime. And mark this, they do not belong to any one department of life. Mathematical accuracy is necessary in the temperature chart or the blood count, while cleanliness becomes part of the daily ritual of neotechnic society with a strictness quite as great as that enforced by the taboos of the earlier religions like the Jewish or the Mohammedan. The polished copper of the electric radiator is reflected in the immaculacy of the operating room, the wide glass windows of the sanatorium are repeated in the factory, the school, the home. During the last decade, in the finer communities that have been built with state aid in Europe, the houses themselves are positively heliotropic, they are oriented to the sun. This new technics does not stop short with mechanical inventions, it begins to call to its aid the biological and psychological sciences, and the studies of working efficiency and fatigue. For example, establish the fact that to curtail the hours of work may be to increase the volume of production per unit. The prevention of disease, the substitution of hygiene for belated repair, becomes a characteristic of neotechnic medicine, a return to nature, a new confidence in the organism as a harmonious, self-equilibrating unit. Under the leadership of Auger and his school, the physician relies upon the natural curative agents, water, diet, sun, air, recreation, massage, change of scene, in short, upon a balanced and life-enhancing environment, and upon functional readjustment, rather than upon more foreign chemical and mechanical aids without such conditions. Here again the intuition of Hahnemann as to the role of minute quantities and the natural therapeutics of his school, anticipated by over a century the new regimen as Auger himself handsomely acknowledged. The psychological treatment of functional disorders, which made its way into medicine with Freud a generation ago, almost completes this new orientation. The social element is alone still largely lacking. As a result of all these advances, one of the major problems for the new techniques becomes the removal of the blighted paleotechnic environment, and the re-education of its victims to a more vital regimen of working and living. Dirty crowded houses, the dank airless courts and alleys, the bleak pavements, the sulfurous atmosphere, the over-routinized and dehumanized factory, the drill schools, the second-hand experiences, the starvation of the senses, the remotance from nature and animal activity. Here are the enemies. The living organism demands a life-sustaining environment. So far from seeking to replace this by mechanical substitutes, the neotechnic phase seeks to establish such life-sustaining conditions within the innermost purlieus of technics itself. The paleotechnic phase was ushered in by a slaughter of the innocents, first in the cradle, and then, if they survived it, in the textile factories and the mines. Child labor remained in the cotton mills in the United States, for example, right down to 1933. As a result of greater care during pregnancy and childbirth, together with a better regimen in infancy, the mortality of children under 5 years has been enormously decreased, all the more because certain typical children's diseases are, through modern immunology, under better control. This increasing care of life has spread slowly to the occupations of maturity, marked the introduction of safety devices in dangerous industrial operations, such as masks in grinding and spraying, asbestos and mica clothing where the dangers of fire and heat are great, the effort to abolish lead glazes in pottery, to eliminate phosphorus poisoning in the preparation of matches and radium poisoning in the preparation of watch dials. These negative measures toward health are, of course, but a beginning, the positive fostering of the life-conserving occupations and the discouragement of those forms of industry which decrease the expectation of life without any compensatory intensification of it during production. All this awaits a culture more deeply concerned with life than even the neotechnic one, in which the calculus of energies still takes precedence over the calculus of life. In surgery likewise, neotechnic methods supplement the cruder mechanics of the mid-19th century. There is a large gap between the antiseptic methods of Lister, with his reliance upon that typical coal tar antiseptic, carbolic acid, and the aseptic technique of modern surgery, first introduced before Lister in operations upon the eye. The use of the X-ray and the tiny electric bulb for exploration, for example, combined with systematic checks provided by the bacteriological laboratory, have increased the possibility of intelligent diagnosis by other means than that offered by the knife. With prevention rather than cure, and health rather than disease, as the focal points of the new medicine, the psychological side of the mind-body process becomes increasingly the object of scientific investigation. The Descartesian notion of a mechanical body presided over by an independent entity called the soul is replaced, as the matter of theoretical physics becomes more attenuated, by the notion of the transformation within the organism of mind states into body states, and vice versa. The dualism of the dead mechanical body, belonging to the world of matter, and the vital transcendental soul, belonging to the spiritual realm, disappears before the increasing insight, derived from physiology on one hand and the investigation of neuroses on the other, of a dynamic interpenetration and conversion within the boundaries of organic structures and functions. Now the physical and the psychical become different aspects of the organic process, in much the same way that heat and light are both aspects of energy, differentiated only by the situation to which they refer and by the particular set of receptors upon which they act. This development lays the specialization and isolation of functions, upon which so many mechanical operations are based, open to suspicion. The integral life of the organism is not compatible with extreme isolation of functions, even mechanical efficiency is seriously affected by sexual anxiety and lack of animal health. The fact that simple repetitive operations agree with the psychological constitution of the feeble-minded constitutes a warning as to the limits of subdivided labor. Mass production under conditions which confirm these limits may exact too high a human price for its cheap products. What is not mechanical enough for a machine to perform may not be human enough for a living man. Efficiency must begin with the utilization of the whole man, and efforts to increase mechanical performance must cease when the balance of the whole man is threatened. 10. The influence of biology. In the earlier chapters, we observed that the first step toward mechanism consisted in a counter-movement to life, the substitution of mechanically measured time for duration, of mechanical prime movers for the human body, of drill and regimentation for spontaneous impulses and more cooperative modes of association. During the neotechnic phase this animus was profoundly modified. The investigation of the world of life opened up new possibilities for the machine itself, vital interests, ancient human wishes, influenced the development of new inventions. Flight, telephonic communication, the phonograph, the motion picture all arose out of the more scientific study of living organisms. The studies of the physiologist supplemented those of the physicist. The belief in mechanical flight grew directly out of the researches of the physiological laboratory. After Leonardo, the only scientific study of flight, up to the work of J. B. Pettigrew and E. J. Merry in the 1860s, was that of the physiologist, Borelli, whose De Motu Animalium was published in 1680. Pettigrew, an Edinburgh pathologist, made a detailed study of locomotion in animals, in which he demonstrated that walking, swimming, and flying are in reality only modifications of each other. The wing, he found, both when at rest and when in motion, may not inaptly be compared to the blade of an ordinary screw propeller as employed in navigation. While weight, instead of being a barrier to artificial flight, is absolutely necessary to it. From these investigations Pettigrew and independently Merry drew the conclusion that human flight was possible. In this development, flying models, utilizing the new M_arterial rubber as motive power, played an important part. Pennaud in Paris, Kress in Vienna, and later Langley in the United States utilized them, but the final touch, necessary for stable flight, came when two bicycle mechanics, Orville and Wilbur Wright, studied the flight of soaring birds, like the gull and the hawk, and discovered the function of warping the tips of the wings to achieve lateral stability. Further improvements in the design of airplanes have been associated, not merely with the mechanical perfection of the wings and the motors, but with the study of the flight of other types of bird, like the duck, and the movement of fish in water. Similarly, the moving picture was in essence a combination of elements derived from the study of living organisms. The first was the discovery of the basis for the illusion of movement, made by the physiologist Plateau in his investigation of the after-image. Out of this work the succession of paper pictures, passed rapidly before the eye, became a popular child's toy, the phenakistoscope and the zoetrope. The next step was the work of the Frenchman, Merry, in photographing the movements of four-footed animals and of man, a research which was begun in 1870 and finally projected upon a screen in 1889. Meanwhile Edward Muybridge, to decide a bet with Leland Stanford, a horse lover, undertook to photograph the successive motions of a horse and later followed this with pictures of an ox, a wild bull, a greyhound, a deer, and birds. In 1887 it occurred to Edison, who was aware of these experiments, to do for the eye what he had already done for the ear, and the invention of the motion picture machine followed, an advance which was in turn dependent upon the invention of the celluloid film in the 80s. Bell's telephone owes a similar debt to physiology and to human play. Von Kempelen had invented a talking automaton which uttered a few words in 1778. A similar machine, Euphonia, invented by Professor Faber, was exhibited in London, and the elder Bell persuaded Alexander and his brother to make a speaking automaton themselves. Imitating the tongue and the soft parts of the throat with rubber, T-Bay made a creditable attempt at a talking machine. Alexander's grandfather had devoted his life to correcting speech defects. His father, A.M. Bell, invented a system of visible speech and was interested in the culture of the voice. He himself was a scientific student of voice production and made great strides in teaching deaf mutes to talk. Out of this physiological knowledge and these humane interests aided by Helmholtz's work in physics grew the telephone, the receiver of which, upon the advice of a Boston surgeon, Dr. C. J. Blake, was directly modeled upon the bones and diaphragm of the human ear. This interest in living organisms does not stop with the specific machines that simulate eye or ear. From the organic world came an idea utterly foreign to the paleotechnic mind, the importance of shape. One can grind a diamond or a piece of quartz to powder, though it has lost its specific crystalline shape, the particles will retain all their chemical properties and most of their physical ones, they will still at least be carbon or silicon dioxide. But the organism that is crushed out of shape is no longer an organism, not merely are its specific properties of growth, renewal, reproduction absent, but the very chemical constitution of its parts undergoes a change. Not even the loosest form of organism, the classic amoeba, can be called a shapeless mass. The technical importance of shape was unappreciated throughout the paleotechnic phase, but for the great mechanical craftsmen, like Maudslay, interest in the aesthetic refinement of the machine was non-existent, or, when it came in, it entered as an intrusion, as in the addition of Doric or Gothic ornament between 1830 and 1860. Except for improvements in specifically eotechnic apparatus, like the clipper sailing ship, shape was looked upon as unimportant. As far back as 1874, for example, the streamlined locomotive was designed, but the writer in Knight's Dictionary of the Mechanical Arts who described it cited the improvement only to dismiss it. "There is nothing in it," he said with cool contempt. Against possible gains in efficiency by merely altering the shape of a machine, the paleotech put his faith in more power consumption and greater size. Only with the development of specifically neotechnic machines, such as the airplane, with the scientific studies of air resistance that followed close on their heels, did shape begin to play a new role in technics. Machines, which had assumed their own characteristic shapes in developing independent of organic forms, were now forced to recognize the superior economy of nature. On actual tests, the blunt heads of many species of fish and the long tapering tail, proved, against naive intuition, to be the most economic shape of moving through air or water, while, in gliding motion over land, the form of the turtle, developed for walking over a muddy bottom, proved suggestive to the designer. The utilization of aerodynamic curves in the design of the body of the airplane, to say nothing of the wings, increases the lifting power without the addition of a single horsepower. The same principle applied to locomotives and motor cars, eliminating all points of air resistance, lowers the amount of power needed and increases the speed. Indeed, with the knowledge drawn from living forms via the airplane, the railroad can now compete once more on even terms with its successor. In short, the integral aesthetic organization of the machine becomes, with the neotechnic economy, the final step in ensuring its efficiency. While the aesthetics of the machine is more independent of subjective factors than the aesthetics of a painting, there is a point in the background at which they both nevertheless meet, for our emotional responses and our standards of efficiency and beauty are derivable largely in both cases from our reactions to the world of life, where correct adaptations of form have so frequently survived. The eye for form, color, fitness, which the cattle breeder and horticulturist hitherto had shared with the artist, now made its way into the machine shop and the laboratory. One might judge a machine by some of the criteria one applied to a bull, a bird, an apple. In dentistry, the appreciation of the essential physiological function of natural tooth forms altered the entire technique of tooth restoration. The crude mechanics and cruder aesthetics of an earlier day fell into disrepute. This new interest in form was a direct challenge to the blind ideology of the earlier period. One might reverse Emerson's dictum and say, in the light of the new technology, that the necessary can never divorce itself from the superstructure of the beautiful. I shall return to this fact again when I discuss the assimilation of the machine. One more phenomenon must be noted, which binds together the machine and the world of life in the neotechnic phase, namely, the respect for minute quantities, unnoticed or invisible before, sometimes below the threshold of consciousness, the part played by the precious alloys in metallurgy, by tiny quantities of energy in radio reception, by the hormones in the body, by the vitamins in the diet, by ultraviolet rays in growth, by the bacteria and filtrable viruses in disease. Not merely is importance in the neotechnic phase no longer symbolized by bulk, but the attention to small quantities leads by habituation to higher standards of refinement in every department of activity. Langley's bolometer can distinguish 1/1,000,000th of a degree centigrade, against the 1/1000th possible on a mercury thermometer. The Tuckerman strain gauge can read millionths of an inch the deflection of a brick when bent by the hand, while Bose's high magnification crescograph records the rate of growth as slow as 1/100,000th of an inch per second. Subtlety, finesse, delicacy, respect for organic complexity and intricacy now characterize the entire range of scientific thought. This has grown in part out of refinements in technical methods, and in turn it has furthered them. The change is recorded in every part of man's experience, from the increased weight placed by psychology upon hitherto unnoticed traumas to the replacement of the pure calorie diet, based upon the energy content alone, by the balanced diet which includes even the infinitesimal amounts of iodine and copper that are needed for health. In a word, the quantitative and the mechanical have at last become life-sensitive. We are still, I must emphasize, probably only at the beginning of this reverse process, whereby technics, instead of benefiting by its abstraction from life, will benefit even more greatly by its integration with it. Already important developments are on the horizon. Two instances must suffice. In 1919 Harvey studied the production of heat during the luminescence of the appropriate substance derived from the crustacean, Serpoitina hilgendorfi. He found that the rise of temperature during the luminescent reaction is less than 0.001 degrees centigrade, and probably less than 0.0005 degrees. The chemical constituents from which this cold light is made are now known, luciferin and luciferase, and the possibility of synthesizing them and manufacturing them, now theoretically within our grasp, would increase the efficiency of lighting far above anything now possible in the utilization of electricity. The organic production of electricity in certain fishes may likewise furnish a clue to the invention of economic high-powered electric cells, in which case the electric motor, which neither devitalizes nor defile nor overheats the air, would have a new part to play, probably, in all forms of locomotion. Developments like these, which are plainly imminent, point to improvements in techniques which will make our present crude utilization of horsepower seem even more wasteful than the practices of paleotechnic engineering do to the designer of a modern power station. 11. From destruction to conservation. The paleotechnic period, we have noted, was marked by the reckless waste of resources. Hot in the pursuit of immediate profits, the new exploiters gave no heed to the environment around them, nor to the further consequences of their actions on the morrow. What had posterity done for them? In their haste, they overreached themselves, they threw money into the rivers, let it escape in smoke in the air, handicapped themselves with their own litter and filth, prematurely exhausted the agricultural lands upon which they depended for food and fabrics. Against all these wastes the neotechnic phase, with its richer chemical and biological knowledge, sets its face. It tends to replace the reckless mining habits of the earlier period with a thrifty and conservative use of the natural environment. Concretely, the conservation and utilization of scrap metals and scrap rubber and slag mean a tidying up of the landscape, the end of the paleotechnic middens. Electricity itself aids in this transformation. The smoke pall of paleotechnic industry begins to lift. With electricity the clear sky and the clean waters of the eotechnic phase come back again, the water that runs through the immaculate discs of the turbine, unlike the water filled with the washings of the coal seams or the refuse of the old chemical factories, is just as pure when it emerges. Hydroelectricity, moreover, gives rise to geotechnics, forest cover protection, stream control, the building of reservoirs and power dams. As early as 1866 George Perkins Marsh, in his classic book on Man and Nature, pointed out the grave dangers of forest destruction and fly soil erosion that followed it. Here was waste in its primary form, the waste of the precious skin of arable, humus-filled soil with which the more favored regions of the world are covered, a skin that is unreplaceable without centuries of waiting except by transporting new tissue from some other favored region. The skinning of the wheatlands and the cotton lands in order to provide cheap bread and textiles to the manufacturing classes was literally cutting the ground from under their feet. So strongly entrenched were these methods that even in America, no effective steps were taken to combat this wastage until a generation after Marsh's books. Indeed, with the invention of the wood pulp process for making paper, the spoliation of the forest went on more rapidly. Timber mining and soil mining proceeded hand in hand. But during the 19th century a series of disastrous experiences began to call attention to the fact that nature could not be ruthlessly invaded and the wildlife indiscriminately exterminated by man without bringing upon his head worse evils than he was eliminating. The ecological investigations of Darwin and the later biologists established the concept of the web of life, of that complex interplay of geological formation, climate, soil, plants, animals, protozoa, and bacteria which maintains a harmonious adjustment of species to habitat. To cut down a forest, or to introduce a new species of tree or insect, might be to set in motion a whole chain of remote consequences. In order to maintain the ecological balance of a region, one could no longer exploit and exterminate as recklessly as had been the wont of the pioneer colonist. The region, in short, had some of the characteristics of an individual organism. Like the organism, it had various methods of meeting maladjustment and maintaining its balance, but to turn it into a specialized machine for producing a single kind of goods, wheat, trees, coal, and to forget its many-sided potentialities as a habitat for organic life was finally to unsettle and make precarious the single economic function that seemed so important. With respect to the soil itself, the Neotechnic phase produced important conservative changes. One of them was the utilization once more of human excrement for fertilizers, in contrast with the reckless method of befouling stream and tidal water and dissipating the precious nitrogenous compounds. The sewage utilization plants of Neotechnic practice, most extensively and systematically introduced perhaps in Germany, not merely avoid the misuse of the environment, but actually enrich it and help bring it to a higher state of cultivation. The presence of such plants is one of the distinguishing characteristics of a Neotechnic environment. The second important advance was in the fixation of nitrogen. At the end of the 19th century the existence of agriculture seemed threatened by the approaching exhaustion of the chilly nitrate beds. Shortly after this various processes for fixing nitrogen were discovered. The arc process, 1903, required cheap electric power, but the synthetic ammonia process, introduced by Haber in 1910, gave a new use to the coke oven. But equally typical of the new technology was the discovering of the nitrogen-forming bacteria at the root nodules of certain plants like pea and clover and soybean. Some of these plants had been used by the Romans and Chinese for soil regeneration, but now their specific function in restoring nitrogen was definitely established. With this discovery one of the Paleotechnic nightmares, that of imminent soil exhaustion, disappeared. These alternative processes typify another Neotechnic fact, namely, that the technical solution it offers for its problems is not confined necessarily to a physical or mechanical means. Electrophysics offers one solution, chemistry another, bacteriology and plant physiology still a third. Plainly, the fixation of nitrogen was a far greater contribution to the efficiency of agriculture than any of the excellent devices that speeded up the processes of plowing, harrowing, sowing, cultivating, or harvesting. Knowledge of this sort, like the knowledge of the desirable shapes for moving bodies, is characteristic of the Neotechnic phase. While on one side Neotechnic advances perfect the automatic machine and extend its operations, on the other, they do away with the complications of machinery in provinces where they are not needed. A field of soybeans may, for certain purposes, take the place of a transcontinental railroad, a dock in San Francisco, a port, a railroad, and a mine in Chile, to say nothing of all the labor involved in bringing these machines and pieces of apparatus together. This generalization holds true for other realms than agriculture. One of the first great improvements introduced by Frederick Taylor under the head of scientific management involved only a change in the motion and routine of unskilled laborers carrying ingots. Similarly, a better routine of living and a more adequately planned environment eliminates the need for sun lamps, mechanical exercisers, constipation remedies, while a knowledge of diet has done away except as a desperate last resort with once fashionable and highly dangerous operations upon the stomach. Whereas the growth and multiplication of machines was a definite characteristic of the Paleotechnic period, one may already say pretty confidently that the refinement, the diminution, and the partial elimination of the machine is a characteristic of the emerging Neotechnic economy. The shrinkage of the machine to the provinces where its services are unique and indispensable is a necessary consequence of our better understanding of the machine itself and the world in which it functions. The conservation of the environment has still another neotechnic aspect, that is the building up in agriculture of an appropriate artificial environment. Up to the 17th century, man's most important artifact was probably the city itself, but during this century the same tactics he had used for his own domestication were applied to agriculture in the building of glass hothouses, and during the 19th century, with the increase of glass production and the expanding empirical knowledge of the soils, glass culture became important in the supply of fruits and vegetables. No longer content with taking nature as it comes, the neotechnic agriculturist seeks to determine the exact conditions of soil, temperature, moisture, insolation that are needed for the specific crop he would grow. Within his cold frames and his hothouses he brings these conditions into existence. This deliberate and systematic agriculture is seen at its best today. Perhaps, in Holland and Belgium, and in dairy farming as carried on in Denmark and Wisconsin. Parallel then with the spread of modern industry throughout the world, there is a similar equalization in agriculture. Aided by the cheap production of glass and metal frames, to say nothing of synthetic substitutes for glass which will permit the ultraviolet rays to pass through, there is the prospect of turning part of agriculture into an all-year occupation, thus diminishing the amount of transportation necessary for fresh fruits and vegetables, and even cultivating, under possibly more humane conditions, the tropical fruits and vegetables. In this new phase, the amount of soil available is not nearly of such critical importance as its quality and its manner of use. The closer interplanning of rural and urban occupations necessarily follows from the partial industrialization of agriculture. Even without the use of hothouses, the widespread distribution of population through the open country is a consequence of neotechnic industry that is actually in the process of realization. This brings with it the possibility of adjusting industrial production to seasonal changes of work enforced by nature in agriculture. And as agriculture becomes more industrialized, not merely will the extreme rustic and the extreme cockney human types tend to diminish, but the rhythms of the two occupations will approach each other and modify each other. If agriculture, freed from the uncertainty of the weather and of insect pests, will become more regular, the organic timing of life processes may modify the beat of industrial organization. A spring rush in mechanical industry, when the fields are beckoning, may be treated not merely as a mark of inefficient planning but as an essential sacrilege. The human gain from this marriage of town and country, of industry and agriculture, was constantly present in the best minds of the 19th century, although the state itself seemed an astronomical distance away from them. On this policy the communist Marx, the social Tory Ruskin, and the anarchist Kropotkin were one. It is now one of the obvious objectives of a rationally planned economy. 12. The planning of population. Central to the orderly use of resources, the systematic integration of industry, and the planning and development of human regions, is perhaps the most important of all neotechnic innovations, the planning of the growth and distribution of the population. Early births have been controlled from the earliest times by one empirical device or another, from asceticism to abortion, from coitus interruptus to the Athenian method of exposing the newborn infant. The first great improvement in Western Europe came by the 16th century via the Arabs. Philoppius, the discoverer of the fallopian tubes, described the use of both the pessary and the sheath. Like the gardens and palaces of the period, the discovery remained apparently the property of the upper classes in France and Italy. It was only in the early 19th century that Francis Place and his disciples attempted to spread the knowledge among the harassed cotton operatives of England. but the rational practice of contraception and the improvement in contraceptive devices awaited not merely the discovery of the exact nature of the germ cell and the process of fertilization, it also awaited improvements in the technological means. Effective general contraception, in other words, postdates Goodyear and Lister. The first large fall of the English birth rate took place in the decade 1870 to 1880, the decade we have already marked as that which saw the perfection of the gas engine, the dynamo, the telephone, and the electric filament lamp. The taboos on sex were so long operative in Christian society that its scientific investigation was delayed long beyond any other function of the body. There are even today textbooks on physiology that skip over the sexual functions with the most hasty allusions. Hence a subject of critical importance to the care and nurture of the race is still not altogether out of the hands of empirics and superstition-ridden people, to say nothing of quacks. But the technique of temporary sterilization, so-called birth control, was perhaps the most important to the human race of all the scientific and technical advances that were carried to completion during the 19th century. It was the neotechnic answer to that vast, irresponsible spawning of Western mankind that took place during the Paleotechnic phase, partly in response perhaps to the introduction of new staple foods and the extension of new food areas, stimulated and abetted by the fact that copulation was the one art and the one form of recreation which could not be denied to the factory population, however it or they might be brutalized. The effects of contraception were manifold. As far as the personal life went, it tended to bring about a divorce between the preliminary sexual functions and the parental ones, since sexual intercourse, prudently conducted, no longer brought with it the imminent likelihood of offspring. This tended to prolong the period of romantic love among the newly married. It gave an opportunity for sexual courtship and accomplishment to develop, instead of being reduced and quickly eliminated by early and repeated pregnancies. Contraception likewise naturally gave the opportunity for the exercise of sexual relations before accepting the legal responsibilities of marriage and parenthood. This resulted in a devaluation of mere virginity, while it permitted the erotic life to follow a natural sequence in growth and efflorescence without respect to economic or professional expediency. It therefore lessened to some extent the dangers of arrested sexual and emotional development, with the strains and anxieties that so often attend this arrest, by giving opportunities for sexual intercourse without complete social irresponsibility. Moreover, by permitting intimate sexual knowledge before marriage, it offered a means for avoiding a more or less permanent relationship in the case of two people to whose happy union there might be grave physiological or temperamental obstacles. While contraception, by doing away with the element of finality, perhaps lowered the weight of tragic choices, it tended to stabilize the institution of marriage, by the very fact that it dissociated the social and affectional relation of parenthood from the more capricious incidents of sexual passion. But important as contraception was to be in sexual life, particularly in the fact that it restored sex with compensatory vigor to a more central role in the personality, its wider social effects were equally important. Whatever the limits of population growth on the planet may be, no one doubts that there are limits. The area of the planet itself is one limit, and the amount of arable soil and fishable water is another. In crowded countries like China and India, the population has in fact pressed close upon the food supply, and security has alternated with famine, despite the immense superiority of Chinese agriculture over most European and American agriculture in the yield it obtains per acre. With the rising pressure of population in European countries from the end of the 18th century onward, and with the rate of increase offsetting wars, a high death rate from diseases, and emigration, there was a tidal movement of peoples from the eastern hemisphere to the western, from Russia into Siberia, and from China and Japan into Manchuria. Each sparsely populated area served as a meteorological center of low pressure to attract the cyclonic movement of peoples from areas of high pressure. Had all the population of all countries continued automatically to rise, this movement must in the end have resulted in frantic conflicts such as that which began in 1932 between China and Japan, with death through starvation and plague as the only alternative to drastic agricultural improvement. Under the stress of blind competition and equally blind fecundity, there could be no end to these movements and these mass wars. With the widespread practice of birth control, however, a vital equilibrium was approached at an early date by France, and is now on the point of being achieved in England and in the United States. This equilibrium reduces the number of variables that must be taken account of in planning, and the size of the population in any area can now theoretically be related to the permanent resources for supporting life that it provides, whilst the waste and wear and dissipation of an uncontrolled birth rate and a high death rate is overcome by the lowering of both sides of the ratio at the same time. As yet, birth control has come too tardily into practice to have begun to exercise any measurable control over the affairs of the planet as a whole. Forces which were set in motion in the past may for 2 or 3 generations stand in the way of the rational ordering of births, except in the most civilized countries, and the rational redistribution of the population of the earth into the most desirable habitats awaits the general ebbing of the human tide from the point to which it was whipped up in the 19th century. But the technical means of this change are now for the first time at hand. So strongly do personal and social interests coincide here that it is doubtful if the taboos of religion can withstand them. The very attempts that Catholic physicians have made to discover safe periods when conception is unlikely is an earnest of the demand to find a measure which will escape the Church's somewhat capricious ban on artificial methods. Even the religion of nationalism, though stimulated by sadistic exploits, paranoiac delusions of grandeur, and maniacal desires to impose the national will upon other populations, even this religion is not immune to the technological achievement of birth control, so long as it retains the major elements of modern technology. Here, then, is another instance of that change from quantitative to qualitative standards that marks the transition from the Paleotechnic economy. The first period was marked by an orgy of uncontrolled production and equally uncontrolled reproduction, machine fodder and cannon fodder, surplus values and surplus populations. In the Neotechnic phase the whole emphasis begins to change, not more births but better births, with greater prospects of survival, with better opportunities for healthy living and healthy parenthood, untainted by ill health, preventable diseases, and poverty, not spoiled by industrial competitions and national wars. These are the new demands. What rational mind questions their legitimacy? What humane mind would retard their operation? 13. The present pseudomorph. So far, in treating the Neotechnic phase, I have concerned myself more with description and actuality rather than with prophecy and potentiality. But he who says A in Neotechnics has already said B, and it is with the social implications and consequences of the Neotechnic economy, rather than with its typical technical instruments, that I purpose to devote the 2 final chapters of this book. There is, however, another difficulty in dealing with this phase, namely, we are still in the midst of the transition. The scientific knowledge, the machines and the utilities, the technological methods, the habits of life and the human ends that belong to this economy are far from being dominant in our present civilization. The fact is that in the great industrial areas of Western Europe and America and in the exploitable territories that are under the control of these centers, the Paleotechnic phase is still intact and all its essential characteristics are uppermost, even though many of the machines it uses are Neotechnic ones or have been made over, as in the electrification of railroad systems, by Neotechnic methods. In this persistence of Paleotechnic practices the original anti-vital bias of the machine is evident: bellicose, money-centered, life-curbing. We continue to worship the twin deities, Mammon and Moloch, to say nothing of more abysmally savage tribal gods. Even in the midst of the worldwide economic collapse that began in 1929, the value of what has collapsed was not at first questioned, though the more faint-hearted advocates of the old order have no hope now of reconstituting it. And in the one country, Soviet Russia, that has magnificently attempted to demolish pecuniary standards and interests, even in Soviet Russia, the elements of the Neotechnic phase are not clear. For despite Lenin's authentic intuition that electrification plus socialism equals communism, the worship of size and crude mechanical power, and the introduction of a militarist technique in both government and industry go hand in hand with sane Neotechnic achievements in hygiene and education. On one hand the scientific planning of industry, on the other, the mechanistically conceived bonanza farming, in the fashion of America in the 70s, here the great centers of electric power, with a potential decentralization into garden cities, there the introduction of heavy industries into the already congested and obsolete metropolis of Moscow, and the further waste of energy in the building of costly subways to intensify that congestion. On different lines from non-communist countries, one nevertheless observes in Soviet Russia some of the same confusion and cross-purposes, some of the same baneful survivals, that prevail elsewhere. What is responsible for this miscarriage of the machine? The answer involves something more complex than a cultural lag or retardation. It is best explained, I think, by a concept put forward by Oswald Spengler in the second volume of The Decline of the West, the concept of the cultural pseudomorph. Spengler points to the common fact in geology that a rock may retain its structure after certain elements have been leached out of it and been replaced by an entirely different kind of material. Since the apparent structure of the old rock remains, the new product is termed a pseudomorph. A similar metamorphosis is possible in culture. New forces, activities, institutions, instead of crystallizing independently into their own appropriate forms, may creep into the structure of an existing civilization. This perhaps is the essential fact of our present situation. As a civilization, we have not yet entered the neotechnic phase, and should a future historian use present terminology, he would undoubtedly have to characterize the current transition as a mesotechnic period. We are still living, in Matthew Arnold's words, between two worlds, one dead, the other powerless to be bombed. For what has been the total result of all these great scientific discoveries and inventions, these more organic interests, these refinements and delicacies of technique? We have merely used our new machines and energies to further processes which were begun under the auspices of capitalist and military enterprise. We have not yet utilized them to conquer these forms of enterprise and subdue them to more vital and humane purposes. The examples of pseudomorphic forms can be drawn from every department. In city growth, for instance, we have utilized electric and gasoline transportation to increase the congestion which was the original result of the capitalistic concentrations of coal and steam power. The new means have been used to extend the area and population of these obsolete and inefficient and humanly defective metropolitan centers. Similarly, the steel frame construction in architecture, which permits the fullest use of glass and the most complete utilization of sunlight, has been used in America to increase the overcrowding of buildings and the obliteration of sunlight. The psychological study of human behavior is used to condition people to accept the goods offered by the canny advertisers, despite the fact that science, as applied in the National Bureau of Standards at Washington, gives measurable and ratable levels of performance for commodities whose worth is now putatively established by purely subjective methods. The planning and coordination of productive enterprise, in the hands of private bankers rather than public servants, becomes a method of preserving monopoly control for privileged financial groups or privileged countries. Labor-saving devices, instead of spreading the total amount of leisure, become means of keeping at a depauperate level an increasing part of the population. The airplane, instead of merely increasing the amount of travel and intercourse between countries, has increased their fear of each other, as an instrument of war. In combination with the latest chemical achievements in poison gas, it promises a ruthlessness of extermination that man has heretofore not been able to apply to either bugs or rats. The neotechnic refinement of the machine, without a coordinate development of higher social purposes, has only magnified the possibilities of depravity and barbarism. Not alone have the older forms of technics served to constrain the development of the neotechnic economy, but the new inventions and devices have been frequently used to maintain, renew, and stabilize the structure of the old order. There is a political and financial vested interest in obsolete technical equipment. That underlying conflict between business interests and industrial interests, which Veblen analyzed with great acuteness in the theory of business enterprise, is accentuated by the fact that vast amounts of capital are sunk in antiquated machines and burdensome utilities. Financial acquisitiveness, which had originally speeded invention, now furthers technical inertia. Hence the tardiness in introducing the automatic telephone, hence the continued design of automobiles in terms of superficial fashions, rather than with any readiness to take advantage of aerodynamic principles in building for comfort and speed and economy, hence the continued purchase of patent rights for improvements which are then quietly extirpated by the monopoly holding them. And this reluctance, this resistance, this inertia have good reason. The old has every cause to fear the superiority of the new. The planned and integrated industry of neotechnic design promises so much greater efficiency than the old that not a single institution appropriate to an economy of parsimony will remain unaltered in an economy of surplus, particularly the institutions limiting ownership and dividends to a small fragment of the population, who thus absorb the purchasing power by excessive reinvestment in industrial enterprise and add to its overexpansion. These institutions, indeed, are incompatible with the planned production and distribution of the necessaries of life, for financial values and real goods cannot be equated to the advantage of the whole community on terms that will benefit chiefly the private capitalists by and for whom the original structure of capitalism was created. One need not wonder that those who affect to control the destinies of industrial society, the bankers, the businessmen, and the politicians, have steadily put the brakes upon the transition and have sought to limit the neotechnic developments and avoid the drastic changes that must be effected throughout the entire social milieu. The present pseudomorph is, socially and technically, third-rate. It has only a fraction of the efficiency that the neotechnic civilization as a whole may possess, provided it finally produces its own institutional forms and controls and directions and patterns. At present, instead of finding these forms, we have applied our skill and invention in such a manner as to give a fresh lease of life to many of the obsolete capitalist and militarist institutions of the older period. Paleotechnic purposes with neotechnic means, that is the most obvious characteristic of the present order. And that is why a good part of the machines and institutions that boast of being new or advanced or progressive are often so only in the way that a modern battleship is new and advanced. They may in fact be reactionary, and they may stand in the way of the fresh integration of work and art and life that we must seek and create. Chapter 6. Compensations and Reverions. 1. Summary of social reactions. Each of the three phases of machine civilization has left its deposits in society. Each has changed the landscape, altered the physical layout of cities, used certain resources and spurned others, favored certain types of commodity and certain paths of activity, and modified the common technical heritage. It is the sum total of these phases, confused, jumbled, contradictory, cancelling out as well as adding to their forces that constitutes our present mechanical civilization. Some aspects of this civilization are in complete decay, some are alive but neglected in thought, still others are at the earliest stages of development. To call this complicated inheritance the power age or the machine age is to conceal more facts about it than one reveals. If the machine appears to dominate life today, it is only because society is even more disrupted than it was in the 17th century. But along with the positive transformations of the environment by means of the machine have come the reactions of society against the machine. Despite the long period of cultural preparation, the machine encountered inertia and resistance. In general, the Catholic countries were slower to accept it than were the Protestant countries, and the agricultural regions assimilated it far less completely than the mining districts. Modes of life essentially hostile to the machine have remained in existence. The institutional life of the churches, filially often subservient to capitalism, has remained foreign to the naturalistic and mechanistic interests which help develop the machine. Hence the machine itself has been deflected or metamorphosed to a certain degree by the human reactions which it has set up, or to which, in one manner or another, it has been forced to adapt itself. Many social adjustments have resulted from the machine which were far from the minds of the original philosophers of industrialism. They expected the old social institutions of feudalism to be dissolved by the new order, they did not anticipate that they might be recrystallized. It is only in economic textbooks, moreover, that the economic man and the machine age have ever maintained the purity of their ideal images. Before the Paleotechnic period was well underway their images were already tarnished, Free competition was curbed from the start by the trade agreements and anti-union collaborations of the very industrialists who shouted most loudly for it. And the retreat from the machine, headed by philosophers and poets and artists, appeared at the very moment that the forces of utilitarianism seemed most coherent and confident. The successes of mechanism only increased the awareness of values not included in a mechanistic ideology, values derived, not from the machine, but from other provinces of life. Any just appreciation of the machine's contribution to civilization must reckon with these resistances and compensations. 2. The mechanical routine. Let the reader examine for himself the part played by mechanical routine and mechanical apparatus in his day, from the alarm clock that wakes him to the radio program that puts him to sleep. Instead of adding to his burden by recapitulating it, I purpose to summarize the results of his investigations, and analyze the consequences. The first characteristic of modern machine civilization is its temporal regularity. From the moment of waking, the rhythm of the day is punctuated by the clock. Irrespective of strain or fatigue, despite reluctance or apathy, the household rises close to its set hour. Tardiness in rising is penalized by extra haste in eating breakfast or in walking to catch the train. In the long run, it may even mean the loss of a job or of advancement in business. Breakfast, lunch, dinner, occur at regular hours and are of definitely limited duration. A million people perform these functions within a very narrow band of time, and only minor provisions are made for those who would have food outside this regular schedule. As the scale of industrial organization grows, the punctuality and regularity of the mealumical regime tend to increase with it. The time clock enters automatically to regulate the entrance and exit of the worker, while an irregular worker tempted by the trout in spring streams or ducks on salt meadows finds that these impulses are as unfavorably treated as habitual drunkenness. If he would retain them, he must remain attached to the less routinized provinces of agriculture. The refractory tempers of work people accustomed to irregular paroxysms of diligence, of which Ure wrote a century ago with such pious horror, have indeed been tamed. Under capitalism, timekeeping is not merely a means of coordinating and interrelating complicated functions, it is also, like money, an independent commodity with a value of its own. The school teacher, the lawyer, even the doctor with his schedule of operations conform their functions to a timetable almost as rigorous as that of the locomotive engineer. In the case of childbirth, patience rather than instrumentation is one of the chief requirements for a successful normal delivery and one of the major safeguards against infection in a difficult one. Here the mechanical interference of the obstetrician, eager to resume his rounds, has apparently been largely responsible for the current discreditable record of American physicians, utilizing the most sanitary hospital equipment, in comparison with midwives who do not attempt brusquely to hasten the processes of nature. While regularity in certain physical functions, like eating and eliminating, may in fact assist in maintaining health, in other matters, like play, sexual intercourse, and other forms of recreation, the strength of the impulse itself is pulsating rather than evenly recurrent. Here habits fostered by the clock or the calendar may lead to dullness and decay. Hence the existence of a machine civilization, completely timed and scheduled and regulated, does not necessarily guarantee maximum efficiency in any sense. Timekeeping establishes a useful point of reference, and is invaluable for coordinating diverse groups and functions which lack any other common frame of activity. In the practice of an individual's vocation, such regularity may greatly assist concentration and economize effort. But to make it arbitrarily rule over human functions is to reduce existence itself to mere time serving and to spread the shades of the prison house over too large an area of human conduct. The regularity that produces apathy and atrophy, that acedia which was the bane of monastic existence, as it is likewise of the army, is as wasteful as the irregularity that produces disorder and confusion. To utilize the accidental, the unpredictable, the fitful is as necessary, even in terms of economy, as to utilize the regular. Activities which exclude the operations of chance impulses forfeit some of the advantages of regularity. In short, mechanical time is not an absolute. and a population trained to keep to a mechanical time routine at whatever sacrifice to health, convenience, and organic felicity may well suffer from the strain of that discipline and find life impossible without the most strenuous compensations. The fact that sexual intercourse in a modern city is limited, for workers in all grades and departments, to the fatigued hours of the day may add to the efficiency of the working life only by a too heavy sacrifice in personal and organic relations. Not the least of the blessings promised by the shortening of working hours is the opportunity to carry into bodily play the vigor that has hitherto been exhausted in the service of machines. Next to mechanical regularity, one notes the fact that a good part of the mechanical elements in the day are attempts to counteract the effects of lengthening time and space distances. The refrigeration of eggs, for example, is an effort to space their distribution more uniformly than the hen herself is capable of doing. The pasteurization of milk is an attempt to counteract the effect of the time consumed in completing the chain between the cow and the remote consumer. The accompanying pieces of mechanical apparatus do nothing to improve the product itself. Refrigeration merely halts the process of decomposition, while pasteurization actually robs the milk of some of its value as nutriment. Where it is possible to distribute the population closer to the rural centers where milk and butter and green vegetables are grown, the elaborate mechanical apparatus for counteracting time and space distances may to a large degree be diminished. One might multiply such examples from many departments. They point to a fact about the machine that has not been generally recognized by those quaint apologists for machine capitalism who look upon every extra expenditure of horsepower and every fresh piece of mechanical apparatus as an automatic net gain in efficiency. In the instinct of workmanship, Veblen has indeed wondered whether the typewriter, the telephone, and the automobile, though creditable technological achievements, have not wasted more effort and substance than they have saved, whether they are not to be credited with an appreciable economic loss, because they have increased the pace and the volume of correspondence and communication and travel out of all proportion to the real need. And Mr. Bertrand Russell has noted that each improvement in locomotion has increased the area over which people are compelled to move, so that a person who would have had to spend half an hour to walk to work a century ago must still spend half an hour to reach his destination, because the contrivance that would have enabled him to save time had he remained in his original situation now by driving him to a more distant residential area effectually cancels out the gain. One further effect of our closer time coordination and our instantaneous communication must be noted here: broken time and broken attention. The difficulties of transport and communication before 1850 automatically acted as a selective screen, which permitted no more stimuli to reach a person than he could handle. A certain urgency was necessary before one received a call from a long distance or was compelled to make a journey oneself. This condition of slow physical locomotion kept intercourse down to a human scale, and under definite control. Nowadays the screen has vanished, the remote is as close as the near, the ephemeral is as emphatic as the durable. While the tempo of the day has been quickened by instantaneous communication, the rhythm of the day has been broken. The radio, the telephone, the daily newspaper clamor for attention, and amid the host of stimuli to which people are subjected, it becomes more and more difficult to absorb and cope with any one part of the environment, to say nothing of dealing with it as a whole. The common man is as subject to these interruptions as the scholar or the man of affairs, and even the weekly period of cessation from familiar tasks and contemplative reverie, which was one of the great contributions of Western religion to the discipline of the personal life, has become an ever remoter possibility. These mechanical aids to efficiency and cooperation and intelligence have been mercilessly exploited, through commercial and political pressure, but so far since unregulated and undisciplined they have been obstacles to the very ends they affect to further. We have multiplied the mechanical demands without multiplying in any degree our human capacities for registering and reacting intelligently to them. With the successive demands of the outside world so frequent and so imperative, without any respect to their real importance, the inner world becomes progressively meager and formless. Instead of active selection there is passive absorption, ending in the state happily described by Victor Branford as adult subjectivity. 3. Purposeless materialism, superfluous power. Growing out of its preoccupation with quantity production is the machine's tendency to center effort exclusively upon the production of material goods. There is a disproportionate emphasis on the physical means of living. People sacrifice time and present enjoyments in order that they acquire a greater abundance of physical means, for there is supposed to be a close relation between well-being and the number of bathtubs, motor cars, and similar machine-made products that one may possess. This tendency, not to satisfy the physical needs of life, but to expand toward an indefinite limit the amount of physical equipment that is applied to living, is not exclusively characteristic of the machine, because it has existed as a natural accompaniment of other phases of capitalism in other civilizations. What is typical of the machine is the fact that these ideals, instead of being confined to a class, have been vulgarized and spread at least as an ideal in every section of society. One may define this aspect of the machine as purposeless materialism. Its particular defect is that it casts a shadow of reproach upon all the non-material interests and occupations of mankind. In particular, it condemns liberal aesthetic and intellectual interests because they serve no useful purpose. One of the blessings of invention, among the naive advocates of the machine, is that it does away with the need for the imagination. Instead of holding a conversation with one's distant friend in reverie, one may pick up a telephone and substitute his voice for one's fantasy. If stirred by an emotion, instead of singing a song or writing a poem, one may turn on a phonograph record. It is no disparagement of either the phonograph or the telephone to suggest that their special functions do not take the place of a dynamic imaginative life, nor does an extra bathroom, however admirably instrumental, take the place of a picture or a flower garden. The brute fact of the matter is that our civilization is now weighted in favor of the use of mechanical instruments, because the opportunities for commercial production and for the exercise of power lie there, while all the direct human reactions or the personal arts which require a minimum of mechanical paraphernalia are treated as negligible. The habit of producing goods whether they are needed or not, of utilizing inventions whether they are useful or not, of applying power whether it is effective or not, pervades almost every department of our present civilization. The result is that whole areas of the personality have been slighted. The telic, rather than the merely adaptive, spheres of conduct exist on sufferance. This pervasive instrumentalism places a handicap upon vital reactions which cannot be closely tied to the machine, and it magnifies the importance of physical goods as symbols of intelligence and ability and farsightedness, even as it tends to characterize their absence as a sign of stupidity and failure. And to the extent that this materialism is purposeless, it becomes final. The means are presently converted into an end. If material goods need any other justification, they have it in the fact that the effort to consume them keeps the machines running. These space-contracting, time-saving, goods-enhancing devices are likewise manifestations of modern power production, and the same paradox holds of power and power machinery. Its economies have been partly cancelled out by increasing the opportunity, indeed the very necessity, for consumption. The situation was put very neatly a long time ago by Babbage, the English mathematician. He relates an experiment performed by a Frenchman, M. Ridelet, in which a block of squared stone was taken as the subject for measuring the effort required to move it. It weighed 1,080 pounds. In order to drag the stone, roughly chiseled, along the floor of the quarry, it required a force equal to 758 pounds. The same stone dragged over a floor of planks required 652 pounds, on a platform of wood, drawn over a floor of planks, it required 606 pounds. After soaping the two surfaces of wood which slid over each other, it required 182 pounds. The same stone was now placed upon rollers 3 inches in diameter, when it required to put it in motion along the floor of the quarry only 34 pounds, while to drag it by these rollers over a wooden floor it needed but 22 pounds. This is a simple illustration of the two ways open in applying power to modern production. One is to increase the expenditure of power, the other is to economize in the application of it. Many of our so-called gains in efficiency have consisted, in effect, of using power machines to apply 758 pounds to work which could be just as efficiently accomplished by careful planning and preparation with an expenditure of 22 pounds, our illusion of superiority is based on the fact that we have had 736 pounds to waste. This fact explains some of the grotesque miscalculations and misappraisals that have been made in comparing the working efficiency of past ages with the present. Some of our technologists have committed the blunder of confusing the increased load of equipment and the increased expenditure of energy with the quantity of effective work done. But the billions of horsepower available in modern production must be balanced off against losses which are even greater than those for which Stuart Chase has made a tangible estimate in his excellent study of the tragedy of waste. While a net gain can probably be shown for modern civilization, it is not nearly so great as we have imagined through our habit of looking only at one side of the balance sheet. The fact is that an elaborate mechanical organization is often a temporary and expensive substitute for an effective social organization or for a sound biological adaptation. The secret of analyzing motions, of harnessing energies, of designing machines was discovered before we began an orderly analysis of modern society and attempted to control the unconscious drift of technic and economic forces. Just as the ingenious mechanical restorations of teeth begun in the 19th century anticipated our advance in physiology and nutrition, which will reduce the need for mechanical repair, so many of our other mechanical triumphs are merely stopgaps, to serve society whilst it learns to direct its social institutions, its biological conditions, and its personal aims more effectively. In other words, much of our mechanical apparatus is useful in the same way that a crutch is useful when a leg is injured. Inferior to the normal functioning leg, the crutch assists its user to walk about whilst bone and tissue are being repaired. The common mistake is that of fancying that a society in which everyone is equipped with crutches is thereby more efficient than one in which the majority of people walk on two legs. We have with considerable cleverness devised mechanical apparatus to counteract the effect of lengthening time and space distances, to increase the amount of power available for performing unnecessary work, and to increase the waste of time attendant upon irrelevant and superficial intercourse. But our success in doing these things has blinded us to the fact that such devices are not by themselves marks of efficiency or of intelligent social effort. Canning and refrigeration as a means of distributing a limited food supply over the year, or of making it available in areas distant from the place originally grown, represent a real gain. The use of canned goods, on the other hand, in country districts when fresh fruits and vegetables are available comes to a vital and social loss. The very fact that mechanization lends itself to large-scale industrial and financial organization, and marches in step with the whole distributing mechanism of capitalist society frequently gives an advantage to such indirect and ultimately more inefficient methods. There is, however, no virtue whatever in eating foods that are years old or that have been transported thousands of miles, when equally good foods are available without going out of the locality. It is a lack of rational distribution that permits this process to go on in our society. Power machines have given a sort of license to social inefficiency. This license was tolerated all the more easily because what the community as a whole. Ex Neotechnic automatism. 1. Modern colon spinning. During the Paleotechnic period the textile industries were the pattern for advanced production, and the term factory was at first applied solely to textile factories. Today the worker has a smaller part than ever to play in them, he lingers on as a machine herd. Photograph by Ewing Galloway. 2. The automatic bottle-making machine not merely a saver of labor but of life, for glass-blowing lays a heavy toll upon its workers. On the other hand, cheap bottles mean greater wastage through carelessness, and the increased demand often tends to cancel out some of the gains of cheap automatic production. See bottles on plate 15. Photograph by Ewing Galloway. Automatic machine for making screw caps in the Krauswerke in Saxony. This factory, which has remained in a single family for a century, illustrates the change from the handicraft methods of the old-fashioned smith to the advanced machine methods of the modern engineer. Courtesy of Friedrich Emil Krauss. Like the streamlined railroad train, The automatic stoker was invented more than 50 years before it came into general use. The type shown here has done away with the servile form of labor and has led to increased efficiency in fuel utilization. Note the single attendant. Courtesy of the Consolidated Gas Company. 11 airplane shapes. 1. Modern airplane, designed to decrease wind resistance and raise lifting power, on lines suggested by study of birds and fish. Since 1920 the development of scientific knowledge and technical design have gone on steadily here, and through the use of new alloys like duralium in both lightness and strength have been achieved. The airplane has set the pace for refined and exact engineering. Photograph by Ewing Galloway. 2. Perhaps the most radical impulse to correct motor car design came from Glenn Curtiss, the airplane designer, when he ran an Ord. Larry Loosed car backward and bettered its performance. The best design so far seems to be that of the Dymaction car, by Buckminster Fuller and Starling Burgess, which has greatly improved speed and comfort without extra horsepower. Photograph by F.S. Lincoln. 3. The streamlined train, designed but rejected as early as 1874, now is realized in 1934, thanks to the competition and the lesson of the airplane. Courtesy of the Union Pacific System. 4. So-called rail Zeppelin. Experimental and possibly somewhat romantic attempt to adapt to surface transportation the advantages of airplane and dirigible. A still more radical approach to the problem of fast land transportation is that now under experiment in Soviet Russia, the Spherotrain invented by a young Soviet engineer, M.I. Yarmalchuk. The latter runs on large motorized ball bearings. The airplane has freed the inventor from the stereotypes of wheel locomotion. Lost through these misapplied energies, enterprising individuals gained in profits. The point is that efficiency is currently confused with adaptability to large-scale factory production and marketing, that is to say, with fitness for the present methods of commercial exploitation. But in terms of social life, many of the most extravagant advances of the machine have proved to rest on the invention of intricate means of doing things which can be performed at a minor cost by very simple ones. Those complicated pieces of apparatus, first devised by American cartoonists, and later carried onto the stage by comedians like Mr. Joe Cook, in which a whole series of mechanisms and involved motions are created in order to burst a paper bag or lick a postage stamp, are not wild products of the American imagination. They are merely transpositions into the realm of the comic of processes which can be witnessed at 100 different points in actual life. Elaborate antiseptics are offered in expensive mechanically wrapped packages, made tempting by lithographs and printed advertisements, to take the place which common scientific knowledge indicates is amply filled by one of the most common minerals, sodium chloride. Vacuum pumps driven by electric motors are forced into American households for the purpose of cleaning an obsolete form of floor covering, the carpet or the rug, whose appropriateness for use in interiors, if it did not disappear with the caravans where it originated, certainly passed out of existence with rubber heels and steam-heated houses. To count such pathetic examples of waste to the credit of the machine is like counting the rise in the number of constipation remedies a proof of the benefits of leisure. The third important characteristic of the machine process and machine environment is uniformity, standardization, replaceability. Whereas handicraft, by the very nature of human work, exhibits constant variations and adaptations, and boasts of the fact that no two products are alike, machine work has just the opposite characteristic. It prides itself on the fact that the millionth motor car built to a specific pattern is exactly like the first. Speaking generally, the machine has replaced an unlimited series of variables with a limited number of constants, if the range of possibility is lessened. The area of prediction and control is increased. And while the uniformity of performance in human beings, pushed beyond a certain point, deadens initiative and lowers the whole tone of the organism, uniformity of performance in machines and standardization of the product works in the opposite direction. The dangers of standardized products have in fact been overrated by people who have applied the same criterion to machines as they would to the behavior of living beings. This danger has been further overstressed by those who look upon uniformity as in itself bad, and upon variation as in itself good, whereas monotony, uniformity, and variety are in reality polar characteristics, neither of which can or should be eliminated in the conduct of life. Standardization and repetition have in fact the part in our social economy that habit has in the human organism. By pushing below the level of consciousness certain recurrent elements in our experience, they free attention for the non-mechanical, the unexpected, the personal. I shall deal with the social and aesthetic importance of this fact when I discuss the assimilation of our machine culture. 4. Cooperation versus slavery. One of the byproducts of the development of mechanical devices and mechanical standards has been the nullification of skill. What has taken place here within the factory has also taken place in the final utilization of its products. The safety razor, for example, has changed the operation of shaving from a hazardous one, best left to a trained barber, to a rapid commonplace of the day which even the most inept males can perform. The automobile has transformed engine driving from the specialized task of the locomotive engineer to the occupation of millions of amateurs. The camera has in part transformed the artful reproductions of the wood engraver to a relatively simple photochemical process in which anyone can acquire at least the rudiments. As in manufacture, the human function first becomes specialized, then mechanized, and finally automatic or at least semi-automatic. When the last stage is reached, the function again takes on some of its original non-specialized character. Photography helps recultivate the eye, the telephone the voice, the radio the ear, just as the motor car has restored some of the manual and operative skills that the machine was banishing from other departments of existence at the same time that it has given to the driver a sense of power and autonomous direction, a feeling of firm command in the midst of potentially constant danger that had been taken away from him in other departments of life by the machine. So, too, mechanization, by lessening the need for domestic service, has increased the amount of personal autonomy and personal participation in the household. In short, mechanization creates new occasions for human effort, and on the whole the effects are more educative than were the semi-automatic services of slaves and menials in the older civilizations. For the mechanical nullification of skill can take place only up to a certain point. It is only when one has completely lost the power of discrimination that a standardized canned soup can, without further preparation, take the place of a home-cooked one, or when one has lost prudence completely that a four-wheel brake can serve instead of a good driver. Inventions like these increase the province and multiply the interests of the amateur. When automatism becomes general and the benefits of mechanization are socialized, men will be back once more in the Eden-like state in which they have existed in regions of natural increment, like the South Seas. The ritual of leisure will replace the ritual of work, and work itself will become a kind of game. That is, in fact, the ideal goal of a completely mechanized and automatized system of power production, the elimination of work, the universal achievement of leisure. In his discussion of slavery, Aristotle said that when the shuttle wove by itself and the plectrum played by itself, chief workmen would not need helpers nor masters' slaves. At the time he wrote, he believed that he was establishing the eternal validity of slavery, but for us today he was in reality justifying the existence of the machine. Work, it is true, is the constant form of man's interaction with his environment. If by work one means the sum total of exertions necessary to maintain life, and lack of work usually means an impairment of function and a breakdown in organic relationship that leads to substitute forms of work, such as invalidism and neurosis. But work in the form of unwilling drudgery or of that sedentary routine which, as Mr. Alfred Zimmern reminds us, the Athenians so properly despised, work in these degrading forms is the true province of machines. Instead of reducing human beings to work mechanisms, we can now transfer the main part of burden to automatic machines. This potentiality, still so far from effective achievement for mankind at large, is perhaps the largest justification of the mechanical developments of the last 1,000 years. From the social standpoint, one final characterization of the machine, perhaps the most important of all, must be noted: the machine imposes the necessity for collective effort and widens its range. To the extent that men have escaped the control of nature, they must submit to the control of society. As in a serial operation, every part must function smoothly and be geared to the right speed in order to ensure the effective working of the process as a whole, so in society at large there must be a close articulation between all its elements. Individual self-sufficiency is another way of saying technological crudeness. As our techniques becomes more refined, it becomes impossible to work the machine without large-scale collective cooperation, and in the long run a high techniques is possible only on a basis of worldwide trade and intellectual intercourse. The machine has broken down the relative isolation never complete even in the most primitive societies of the handicraft period. It has intensified the need for collective effort and collective order. The efforts to achieve collective participation have been fumbling and empirical, so for the most part, people are conscious of the necessity in the form of limitations upon personal freedom and initiative, limitations like the automatic traffic signals of a congested center, or like the red tape in a large commercial organization. The collective nature of the machine process demands a special enlargement of the imagination and a special education in order to keep the collective demand itself from becoming an act of external regimentation. To the extent that the collective discipline becomes effective and the various groups in society are worked into a nicely interlocking organization, special provisions must be made for isolated and anarchic elements that are not included in such a wide-reaching collectivism, elements that cannot without danger be ignored or repressed. But to abandon the social collectivism imposed by modern techniques means to return to nature and be at the mercy of natural forces. The regularization of time, the increase in mechanical power, the multiplication of goods, the contraction of time and space, the standardization of performance and product, the transfer of skill to automata, and the increase of collective interdependence, these, then, are the chief characteristics of our machine civilization. They are the basis of the particular forms of life and modes of expression that distinguish Western civilization, at least in degree, from the various earlier civilizations that preceded it. In the translation of technical improvements into social processes, however, the machine has undergone a perversion. Instead of being utilized as an instrument of life, it has tended to become an absolute. Power and social control, once exercised chiefly by military groups who had conquered and seized the land, have gone since the 17th century to those who have organized and controlled and owned the machine. The machine has been valued because it increased the employment of machines. And such employment was the source of profits, power, and wealth to the new ruling classes, benefits which had hitherto gone to traders or to those who monopolized the land. Jungles and tropical islands were invaded during the 19th century for the purpose of making new converts to the machine. Explorers like Stanley endured incredible tortures and hardships in order to bring the benefits of the machine to inaccessible regions tapped by the Congo. Insulated countries like Japan were entered forcibly at the point of the gun in order to make way for the trader. Natives in Africa and the Americas were saddled with false debts or malicious taxes in order to give them an incentive to work and to consume in the machine fashion, and thus to supply an outlet for the goods of America and Europe, or to ensure the regular gathering of rubber and lac. The injunction to use machines was so imperative, from the standpoint of those who owned them and whose means and place in society depended upon them, that it placed upon the worker a special burden, the duty to consume machine products, while it placed upon the manufacturer and the engineer the duty of inventing products weak enough and shoddy enough, like the safety razor blade or the common run of American woolens, to lend themselves to rapid replacement. The great heresy to the machine was to believe in an institution or a habit of action or a system of ideas that would lessen this service to the machines, for under capitalist direction the aim of mechanism is not to save labor but to eliminate all labor except that which can be channeled at a profit through the factory. At the beginning, the machine was an attempt to substitute quantity for value in the calculus of life. Between the conception of the machine and its utilization, as Cranhalls points out, a necessary psychological and social process was skipped, the stage of evaluation. Thus a steam turbine may contribute thousands of horsepower, and a speedboat may achieve speed, but these facts, which perhaps satisfy the engineer, do not necessarily integrate them in society. Railroads may be quicker than canal boats, and a gas lamp may be brighter than a candle, but it is only in terms of human purpose and in relation to a human and social scheme of values that speed or brightness have any meaning. If one wishes to absorb the scenery, the slow motion of a canal boat may be preferable to the fast motion of a motor car, and if one wishes to appreciate the mysterious darkness and the strange forms of a natural cave, it is better to penetrate it with uncertain steps, with the aid of a torch or a lantern, than to descend into it by means of an elevator, as in the famous caves of Virginia, and to have the mystery entirely erased by a grand display of electric lights, a commercialized perversion. That puts the whole spectacle upon the low dramatic level of a Cockney amusement park. Because the process of social evaluation was largely absent among the people who developed the machine in the 18th and 19th centuries, the machine raced like an engine without a governor, tending to overheat its own bearings and lower its efficiency without any compensatory gain. This left the process of evaluation to groups who remained outside the machine milieu, and who unfortunately often lacked the knowledge and the understanding that would have made their criticisms more pertinent. The important thing to bear in mind is that the failure to evaluate the machine and to integrate it in society as a whole was not due simply to defects in distributing income, to errors of management, to the greed and narrow-mindedness of the industrial leaders. It was also due to a weakness of the entire philosophy upon which the new techniques and inventions were grounded. The leaders and enterprisers of the period believed that they had avoided the necessity for introducing values, except those which were automatically recorded in profits and prices. They believed that the problem of justly distributing goods could be sidetracked by creating an abundance of them, that the problem of applying one's energies wisely could be cancelled out simply by multiplying them, in short, that most of the difficulties that had hitherto vexed mankind had a mathematical or mechanical carrot that is a quantitative solution. The belief that values could be dispensed with constituted the new system of values. Values, divorced from the current processes of life, remained the concern of those who reacted against the machine. Meanwhile, the current processes justified themselves solely in terms of quantity production and cash results. When the machine as a whole overspeeded and purchasing power failed to keep pace with dishonest overcapitalization and exorbitant profits, then the whole machine went suddenly into reverse, stripped its gears, and came to a standstill, a humiliating failure, a dire social loss. One is confronted, then, by the fact that the machine is ambivalent. It is both an instrument of liberation and one of repression. It has economized human energy and it has misdirected it. It has created a wide framework of order and it has produced muddle and chaos. It has nobly served human purposes and it has distorted and denied them. Before I attempt to discuss in greater detail those aspects of the machine that have been effectively assimilated and that have worked well, I purpose to discuss the resistances and compensations created by the machine. For neither this new type of civilization nor its ideal has gone unchallenged. The human spirit has not bowed to the machine in complete submission. In every phase of existence the machine has stirred up antipathies, dissents, reactions, some weak, hysterical, unjustified, others that are in their nature so inevitable, so sound, that one cannot touch the future of the machine without taking them into account. Similarly, the compensations that have arisen to overcome or mitigate the effects of the new routine of life and work call attention to dangers in the partial integration that now exists. 5. Direct attack on the machine. The conquest of Western civilization by the machine was not accomplished without stubborn resistance on the part of institutions and habits and impulses which did not lend themselves to mechanical organization. From the very beginning the machine provoked compensatory or hostile reactions. In the world of ideas, Romanticism and utilitarianism go side by side. Shakespeare with his cult of the individual hero and his emphasis of nationalism appeared at the same time as the pragmatic Bacon, and the emotional fervor of Wesley's Methodism spread like fire in dry grass through the very depressed classes that were subject to the new factory regime. The direct reaction of the machine was to make people materialistic and rational. Its indirect action was often to make them hyper-emotional and irrational. The tendency to ignore the second set of reactions because they did not logically coincide with the claims of the machine has unfortunately been common in many critics of the new industrial order. Even Veblen was not free from it. Resistance to mechanical improvements took a wide variety of forms. The most direct and simple form was to smash the offending machine itself or to murder its inventor. The destruction of machines and the prohibition of invention, which so beneficently transformed the society of Butler's Iruhan, might have been accomplished by the working classes of Europe but for two facts. First, the direct war against the machine was an unevenly matched struggle, for the financial and military powers were on the side of the classes that were bent on exploiting the machine, and in a pinch the soldiery, armed with their new machines, could demolish the resistance of the hand workers with a volley of musketry. As long as invention took place sporadically, the introduction of a single machine could well be retarded by direct attack. Once it operated on a wide and united front, no mere local rebellion could more than temporarily hold up its advance. A successful challenge would have needed a degree of organization which in the very nature of the case fly working classes did not have, indeed lack even today. The second point was equally important. Life and energy and adventure were at first on the side of the machine. Handicraft was associated with the fixed, the sessile, the superannuated, the dying. It manifestly shrank away from the new movements in thought and from the ordeal of the new reality. The machine meant fresh revelations, new possibilities of action. It brought with it a revolutionary élan. Youth was on its side. Seeking only the persistence of old ways, the enemies of the machine were fighting a rearguard retreat, and they were on the side of the dead even when they espoused the organic against the mechanical. As soon as the machine came to predominate in actual life, the only place where it could be successfully attacked or resisted was in the attitudes and interests of those who worked it. The extent to which unmechanical ideologies and programs have flourished since the 17th century, despite the persistent habituation of the Maclean, is in part a measure of the amount of resistance that the machine has, directly or indirectly, occasioned. 6. Romantic and utilitarian. The broadest general split in ideas occasioned by the machine was that between the romantic and the utilitarian. Carried along by the industrial and commercial ideals of his age, the utilitarian was at one with its purposes. He believed in science and inventions, in profits and power, in machinery and progress, in money and comfort, and he believed in spreading these ideals to other societies by means of free trade, and in allowing some of the benefits to filter down from the possessing classes to the exploited, or as they are now euphemistically called, the underprivileged, provided that this was done prudently enough to keep the lower classes diligently at work in a state of somnolent and respectful submission. The newness of the mechanical products was, from the utilitarian standpoint, a guarantee of their worth. The utilitarian wished to put as much distance as possible between his own society of unfettered money-making individuals and the ideals of a feudal and corporate life. These ideals, with their traditions, loyalties, sentiments, constituted a brake upon the introduction of changes and mechanical improvements. The sentiments that clustered around an old house might stand in the way of opening a mine that ran underneath it, even as the affection that often entered into the relation of master and servant under the more patriarchal older regime might stand in the way of that enlightened self-interest which would lead to the dismissal of the worker as soon as the market was slack. What most obviously prevented a clean victory of capitalistic and mechanical ideals was the tissue of ancient institutions and habits of thought, the belief that honor might be more important than money, or that friendly affection and comradeship might be as powerful a motive in life as profit-making, or that present animal health might be more precious than future material acquisitions. In short, that the whole man might be worth preserving at the expense of the utmost success and power of the economic man. Indeed, some of the sharpest criticism of the new mechanical creed came from the Tory aristocrats in England, France, and in the southern states of the United States. Romanticism in all its manifestations, from Shakespeare to William Morris, from Goethe and the Brothers Grimm to Nietzsche, from Rousseau and Chateaubriand to Hugo, was an attempt to restore the essential activities of human life to a central place in the new scheme, instead of accepting the machine as a center, and holding all its values to be final and absolute. In its animus, Romanticism was right, for it represented those vital and historic and organic attributes that had been deliberately eliminated from the concepts of science and from the methods of the earlier technics, and it provided necessary channels of compensation. Vital organs of life, which have been amputated through historic accident, must be restored at least in fantasy, as preliminary to their actual rebuilding. In fact, a psychosis is sometimes the only possible alternative to complete disruption and death. Unfortunately, in its comprehension of the forces that were at work in society, the Romantic movement was weak, overcome by the callous destruction that attended the introduction of the machine. It did not distinguish between the forces that were hostile to life and those that served it, but tended to lump them all in the same compartment, and to turn its back upon them. In its effort to find remedies for the dire weakness and perversions of industrial society, Romanticism avoided the very energies by which alone it could hope to create a more sufficient pattern of existence, namely, the energies that were focused in science and technics and in the mass of new machine workers themselves. The Romantic movement was retrospective, walled in, sentimental, in a word, regressive. It lessened the shock of the new order, but it was, for the greater part, a movement of escape. But to confess this is not to say that the Romantic movement was unimportant or unjustified. On the contrary, one cannot comprehend the typical dilemmas of the new civilization unless one understands the reason and the rationale of the Romantic reaction against it, and sees how necessary it is to import the positive elements in the Romantic attitude into the new social synthesis. Romanticism as an alternative to the machine is dead. Indeed, it never was alive, but the forces and ideas once archaically represented by Romanticism are necessary ingredients in the new civilization, and the need today is to translate them into direct social modes of expression, instead of continuing them in the old form of an unconscious or deliberate regression into a past that can be retrieved only in fantasy. The Romantic reaction took many forms, and I shall consider only the three dominant ones: the cult of history and nationalism, the cult of nature, and the cult of the primitive. The same period saw likewise the cult of the isolated individual, and the revival of old theologies and theosophies and supernaturalisms, which owed their existence and much of their strength no doubt to the same denials and emptinesses that prompted the more specially Romantic revivals, but it is next to impossible to distinguish clearly between the continued interests of religion and their modern revivals, so I shall confine this analysis to the Romantic reaction proper, for this plainly accompanied and probably grew out of the new situation. 7. The cult of the past. The cult of the past did not immediately develop in response to the machine. It was, in Italy, an attempt to resume the ideas and forms of classic civilization, and during the Renaissance the cult was, in fact, a sort of secret ally to the machine. Did it not, like the machine, challenge the validity of the existing traditions in both philosophy and daily life? Did it not give more authority to the manuscripts of ancient authors, to Hero of Alexandria in physics, to Vitruvius in architecture, to Columella in farming, than it did to the existing body of tradition and the practices of contemporary masters? Did it not, by breaking with the immediate past, encourage the future to break with the present? The recovery of the classic past during the Renaissance caused a break in the historic continuity of Western Europe, and this gap, which opened in education and the formal arts, made a breach of which the machine promptly took advantage. By the 18th century the Renaissance culture itself was sterilized, pedanticized, formalized. It gave itself over to the recovery and reproduction of dead forms, and though a Poussin or a Piranesi could revitalize these forms with a little of the hair and confidence that the men of the late 15th century had felt, the neoclassic and the mechanical played into each other's hands. In the sense of being divorced from life, the first was even more mechanical than mechanism itself. It is not perhaps altogether an accident that at a distance the palaces of Versailles and St. Petersburg have the aspect of modern factory buildings. When the cult of the past revived again, it was directed against both the arid humanism of the 18th century and the equally arid dehumanism of the mechanical age. William Blake, with his usual true instinct for fundamental differences, attacked with equal vehemence Sir Joshua Reynolds and Sir Isaac Newton. In the 18th century a cultured man was one who knew his Greek and Latin classics, an enlightened man was one who regarded any part of the globe as suitable for human habitation, provided that its laws were just and their administration impartial. A man of taste was one who knew that standards of proportion and beauty in architecture and sculpture and painting had been fixed forever by classic precedent. The living tissue of customs and traditions, the vernacular architecture, the folkways and the folk tales, the vulgar languages and dialects that were spoken outside Paris and London, all these things were looked upon by the 18th century gentleman as a mass of follies and barbarisms. Enlightenment and progress meant the spreading of London, Paris, Vienna, Berlin, Madrid, and St. Petersburg over wider and wider areas. Thanks to the dominance of the machine, to books and bayonets, to printed calicos and missionary pocket handkerchiefs, to brummagem jewelry and cutlery and beads, a layer of the civilization began to spread like a film of oil over the planet at large. Machine textiles supplanted hand-woven ones, aniline dyes eventually took the place of vegetable dyes locally made, and even in distant Polynesia calico dresses and stovepipe hats and shame covered up the proud bodies of the natives, while syphilis and rum, introduced at the same time as the Bible, added a special physical horror to their degradation. Wherever this film of oil spread, the living fish were poisoned and their bloated bodies rose to the surface of the water, adding their own decay to the stench of the oil itself. The new mechanical civilization respected neither place nor past. In the reaction that it provoked, place and past were the two aspects of existence that W-re overstressed. This reaction appeared definitely in the 18th century, just at the moment that the Paleotechnic revolution was getting underway. It began as an attempt to take up the old threads of life at the point where the Renaissance had dropped them. It was thus a return to the Middle Ages and a rereading of their significance, absurdly by Walpole, coldly by Robert Adam, graphically by Scott, faithfully by von Scheffel, aesthetically by Goethe and Blake, piously by Pugin and the members of the Oxford movement, moralistically by Carlyle and Ruskin, imaginatively by Victor Hugo. These poets and architects and critics disclosed once more the wealth and interest of the old local life in Europe. They showed how much engineering had lost by deserting Gothic forms for dry simpler post and lintel construction of classic architecture, and how much literature had forfeited by its extravagant interest in classic forms and themes and its snobbish parade of classic allusions, while the most poignant emotions were embodied in the local ballads that still lingered on in the countryside. By this Gothic revival a slight check was placed upon the centralizing, exploitative, and regionalizing processes of the machine civilization. Local folklore and local fairy tales were collected by scholars like the Brothers Grimm and historically minded novelists like Scott. Local monuments of archaeology were preserved, and the glorious stained glass and wall paintings of the medieval and early Renaissance churches were saved here and there from the glazier and plasterer, still erasing these remnants of Gothic barbarity in the name of progress and good taste. Local legends were collected. Indeed, one of the most remarkable poems of the Romantic movement, Tam O'Shanter, was written merely to serve as letterpress for a picture of Alloway's Auld Haunted Kirk. Most potent of all, local languages and dialects were pounced upon, in the very act of dying, and restored to life by turning them to literary uses. The nationalist movement took advantage of these new cultural interests and attempted to use them for the purpose of fortifying the political power of the unified nationalist state, that mighty engine for preserving the economic status quo and for carrying out imperialistic policies of aggression among the weaker races. In this manner, amorphous entities like Germany and Italy became self-conscious and realized a certain degree of political self-sufficiency. But the new interests and revivals struck much deeper than political nationalism, and were more concentrated in their sphere of action. Moreover, they touched aspects of life to which a mere power politics was as indifferent as was a power economics. The creation of nationalist states was essentially a movement of protest against alien political powers, wielded without the consent and participation of the governed, a protest against the largely arbitrary political groupings of the dynastic period. But the nations, once they achieved independent nationality, speedily began with the introduction of coal industrialism to go through the same process of deregionalization as those that had had no separate national existence, and it was only with the growth of a more intensive and self-conscious regionalism that the process began to work in the opposite direction. The revival of place interests and language interests, focused in the new appreciation of regional history, is one of the definite characteristics of 19th century culture. Because it was in direct conflict with the cosmopolitan free trade imperialism of the leading economic thought of the period, and political economy had a hallowed status among the social sciences during this period, because of its useful mythological character, this new regionalism was never carefully appraised or sufficiently appreciated in the early days of its existence. Even now it is still often looked upon as a queer aberration, for plainly it does not fit in altogether with the doctrines of industrial world conquest or with those of progress. The movement did not in fact crystallize, despite the valuable preliminary work of the Romantics, until the middle of the 19th century, and instead of disappearing with the more universal triumph of the machine, it went on after that with accelerating speed and intensity. First France, then Denmark, now every part of the world has felt at least a tremor of the countering shock of regionalism, sometimes a definite upheaval. At the beginning, the main impulse came from the historic regions whose existence was threatened by the mechanical and political unifications of the 19th century. The movement had indeed a definite beginning in time, namely 1854, in that year occurred the first meeting of the Félibrigistes, who gathered together for the purpose of restoring the language and the autonomous cultural life of Provence. The Provençal language had all but been destroyed by the Albigensian Crusades. Provence had been, so to say, a conquered province of the Church, which had decimated it by a strenuous use of the secular arm, and although an attempt had been made by the 7 poets of Toulouse, in 1324, to revive the language, the movement had not succeeded. The speech of Ronsard and Racine had finally prevailed. In their consciousness of the part played by language as a means of establishing and helping to build up their identity with their region, a group of literary men, headed by Frédéric Mistral, started to institute the regionalist movement. This movement has gone through a similar set of stages in every country where it lies taken place, in Denmark, in Norway, in Ireland, in Catalonia, in Brittany, in Wales, in Scotland, in Palestine, and similar signs are already visible in various regions in North America. There is, as M. Jordan has put it, at first a poetic cycle. This leads to the recovery of the language and literature of the folk, and the attempt to use it as a vehicle for contemporary expression on the basis of largely traditional forms. The second is the cycle of prose, in which the interest in the language leads to an interest in the totality of a community's life and history, and so brings the movement directly onto the contemporary stage. And finally there is the cycle of action, in which regionalism forms for itself fresh objectives, political, economic, civic, cultural, on the basis, not of a servile restoration of the past, but of a growing integration of the new forces that have attached themselves to the main trunk of tradition. The only places where regionalism has not been militantly self-conscious are places like the cities and provinces of Germany, in which until the recent centralization of power by the totalitarian state an autonomous and effective local life had never entirely disappeared. The besetting weakness of regionalism lies in the fact that it is in part a blind reaction against outward circumstances and disruptions, an attempt to find refuge within an old shell against the turbulent invasions of the outside world, armed with its new engines, in short, an aversion from what is, rather than an impulse toward what may be. For the merely sentimental regionalist, the past was an absolute. His impulse was to fix some definite moment in the past, and to keep on living it over and over again, holding the original regional costumes, which were in fact merely the fashion of a certain century, maintaining the regional forms of architecture, which were merely the most convenient and comely constructions at a certain moment of cultural and technical development, and he sought, more or less, to keep these original customs and habits and interests fixed forever in the same mold, a neurotic retreat. In that sense regionalism, it seems plain, was anti-historical and anti-organic, for it denied both the fact of change and the possibility that anything of value could come out of it. /nihil It would be dishonest to gloss over this weakness. One must understand it in terms of the circumstances that conspired to produce it. It was a flat reaction against the equally exaggerated neglect of the traditions and historic monuments of a community's life, fostered by the abstractly progressive minds of the 19th century. For the new industrialist, history was bunk. Is it any wonder that the new regionalist overcompensated for that contempt and ignorance by holding that even the dustiest relics of the past were sacred? Uliat was mistaken, was not the interest but the tactics. Vis-a-vis the machine, the regionalist was in the position of a swimmer facing a strong incoming tide. If he attempts to stand up against the high waves, he is knocked down. If he seeks safety by retreating unaided to the shore, he is caught in the undertow of the receding wave and can neither reach land nor keep his footing. His welfare depends upon his confidence in meeting the wave and plunging along with it at the moment it is about to break, thus utilizing the energy of the very force he is attempting to escape. These were the tactics of Bishop Grundtvig of Denmark, who not merely revived the old ballads but founded the cooperative agricultural movement. They are the basis of a dynamic regionalism. The fact is, at all events, that the development of local languages and regional cultures, though springing immediately perhaps out of a reactionary impulse, was not limited to negations, neither was it hopelessly remote from those currents of modern life which strengthen the bonds between regions and universalize the common benefits of Western civilization. It was rather complementary to them. A world that is united physically by the airplane, the radio, the cable, must eventually, if cooperation is to increase, devise a common language to take care of all its practical matters, its news dispatches, its business communications, its international broadcasts, and the relatively simple needs and curiosities of travelers. Precisely as the boundaries of mechanical intercourse widen and become worldwide, a universal language must supplant the tongue of even the most influential national aggregation. From this point of view, one of the worst blows to internationalism was that struck by the pedants of the Renaissance when in their worship of the classics they abandoned scholastic Latin, the universal language of the learned classes. But along with this pragmatic development of a common tongue, a more intimate language is needed for the deeper sort of cooperation and communication. Languages equipped for this special cultural purpose have been spontaneously growing up or reviving all over the Western world from the middle of the 19th century onwards. Welsh, Gaelic, Hebrew, Catalan, Flemish, Czech, Norwegian, Landsmal, Afrikaans are some of the languages that are either new, or have been renovated and popularized recently for combined vernacular and literary use. Ultimately, the growth of travel and communication will doubtless lead to a consolidation of dialects, reducing, say, the 300-odd languages of India to a handful of major languages. It is already being counteracted by the opposite process of redifferentiation. The gap between English and American is much wider now than it was when Noah Webster codified the slightly more archaic American forms and pronunciations. There is no reason to think that any single national language can now dominate the world, as the French and the English people have by turns dreamed, for unless an international language can be made relatively fixed and lifeless, it will go through a Babel-like differentiation in precisely the same fashion as Latin did. It is much more likely that bilingualism will become universal, that is, an arranged and purely artificial world language for pragmatic and scientific uses, and a cultural language for local communication. The revival of these cultural languages and literatures and the stimulation of local life that has resulted from their use, must be counted as one of the most effective measures society has taken for protection against the automatic processes of machine civilization. Against the dream of universal and complete standardization, the dream of the universal Cockney, and of one long street, called the Tottenham Court Road or Broadway threading over the globe, and of one language spoken everywhere and on all occasions, against this now archaic dream one must place the fact of cultural re-individuation. While the reaction has often been blind and arbitrary, it has been no more so than the equally forward-looking movements it was attempting to halt. Behind it lies the human need to control the machine, if not at the point of origin, then at the point of application. 8. The return to nature. The historical revival of regionalism was reinforced by another movement, the return to nature. The cultivation of nature for its own sake, and the pursuit of rural modes of living and the appreciation of the rural environment became in the 18th century one of the chief means of escaping the counting house and the machine. So long as the country was uppermost, the cult of nature could have no meaning. Being a part of life, there was no need to make it a special object of thought. It was only when the townsman found himself closed in by his methodical urban routine and deprived in his new urban environment of the sight of sky and grass and trees, that the value of the country manifested itself clearly to him. Before this, an occasional rare adventurer would seek the solitude of the mountains to cultivate his soul, but in the 18th century Jean-Jacques Rousseau, preaching the wisdom of the peasant and the sanity of the simple rural occupations, led a whole succession of generations outside the gates of their cities. They botanized, they climbed mountains, they sang peasant songs, they swam in the moonlight, they helped in the harvest field, and those who could afford to built themselves rural retreats. This impulse to recapture nature had a powerful influence upon the cultivation of the environment as a whole and upon the development of cities, but I reserve this for discussion in another book. The important thing is to realize that at the very moment life was becoming more constricted and routinized, a great safety valve for the aboriginal human impulses had been found: the raw, unexplored, and relatively uncultivated regions of America and Africa, and even the less formidable islands of the South Seas. Above all, the most steadfast of primitive environments, the ocean, had been thrown open to the discontented and the adventurous. Failing to accept the destiny that the inventors and the industrialists were creating, failing to welcome the comforts and the conveniences of civilized existence and accept the high value placed upon them by the reigning bourgeoisie, those who possessed hardier virtues and a quicker sense of values could escape from the machine. In the forests and grasslands of the new worlds they could wring a living from the soil, and on the sea they could face the elemental forces of wind and water. Here, likewise, those too weak to face the machine could find temporary refuge. This solution was perhaps almost a too perfect one, for the new settlers and pioneers not merely satisfied their own spiritual needs by colonizing the less inhabited areas of the globe, but in the act of so doing they provided raw materials for the new industries, they likewise afforded a market for their manufactured goods, and they paved the way for the eventual introduction of the machine. Rarely have the inner impulses of different parts of society balanced so neatly with the outer conditions of its success. Rarely has there been a social situation which was satisfactory to so many different types of personality and so many varieties of human effort. For a brief 100 years, roughly from 1790 to 1890 in North America, and perhaps a little earlier and a little later for South America and Africa, the land pioneer and the industrial pioneer were in close partnership. The thrifty, aggressive, routinized men eduiled their factories and regimented their workers. The tough, sanguine, spirited, non-mechanical men fought the aborigines, cleared the land, scoured the forests for game and clove the virgin soils with their plows. If the new agricultural opportunities were still too tame and respectable, even though old customs and solidarities were disregarded and old precedents flouted, there were horses to be roped on the pampas, petroleum to be tapped in Pennsylvania, gold was to be found in California and Australia, rubber and tea to be planted in the east, and virgin lands in the steaming heart of Africa or in the coldest north could be trodden for the first time by white men seeking food or knowledge or adventure, or cycle remoteness from their own kind. Not until the new lands were completely occupied and exploited did the machine come in, to claim its special form of dominion over those who had shown neither courage nor luck nor cunning in exploit. In nature, for millions of men and women, the new lands staved off the moment of submission. By accepting the shackles of nature they could evade for a brief while the complicated interdependence of the machine civilization. The more humane or fanatic types, in the company of their fellows, could even make an equally brief effort to realize their dream of the perfect society or the heavenly city. From the Shaker colonies in New England to the Mormons of Utah there stretched a weak faint line of perfectionists, seeking to circumvent both the aimless brutality of nature and the more purposeful brutality of man. Movements as vast and complex as the migration of peoples from the 17th to the 20th century cannot of course be accounted for by a single cause or a single set of circumstances. The pressure of population growth by itself is not sufficient to explain it, for not merely did the movement precede the growth, but the fact is that this pressure was considerably eased in Europe by the introduction of the potato, the improvement of the winter cattle fodder crops and the overthrow of the three-field system, at the very moment that the exodus to the New World was greatly accelerated. Nor can it be explained on purely political terms as an attempt to escape obsolete ecclesiastical and political institutions, or a result of the desire to breathe the free unpolluted air of republican institutions. Nor again was it merely a practical working out of the desire to return to nature, although Rousseau had plainly influenced people who talked Rousseau and acted Rousseau without ever perhaps having heard his name. But all these motives were in existence: the desire to be free from social compulsion, the desire for economic security, the desire to return to nature, and they played into each other's hands. They provided both the excuse and the motive power for escaping from the new mechanical civilization that was closing in upon the Western world. To shoot, to trap, to chop trees, to hold a plow, to prospect, to face a seam, all these primitive occupations, out of which technics had originally sprung, all these occupations that had been closed and stabilized by the very advances of technics, were now open to the pioneer. He might be hunter, fisher, miner, woodman, and farmer by turn, and by engaging in these occupations people could restore their plain animal vigor as men and women, temporarily freed from the duties of a more orderly and servile existence. Within a short century this savage idyll practically came to an end. The industrial pioneer caught up with the land pioneer, and the latter could only rehearse in play what his forefathers had done out of sheer necessity. But as long as the opportunities were open in the unsettled countries, people took advantage of them in numbers that would be astounding if the blessings of an orderly, acquisitive, mechanized civilization were as great as the advocates of progress believed and preached. Millions of people chose a lifetime of danger, heroic toil, deprivation, and hardships, battling with the forces of nature, rather than accept life on the terms that it was offered alike to the victorious and the vanquished in the new hives of industry. The movement was in part the reverse of that great organizing effort of the 11th and 12th centuries which cleared the forests and marshes and erected cities from one end of Europe to the other. It was rather a tendency to disperse, to escape from a close, systematic, cultivated life into an open and relatively barbarous existence. With the occupation of the remaining open lands, this modern movement of population tapered off, and our mechanical civilization lost one of its main safety valves. The most simple human reaction that fear of the machine could provoke, running away from it, had ceased to be possible without undermining the basis of livelihood. So complete has the victory of the machine been during the last generation that in the periodic exodus from the machine which takes place on holidays in America, the would-be exiles escape in motor cars and carry into the wilderness a phonograph or a radio set. And ultimately, then, the reaction of the pioneer was far less effective, though it so soon found practical channels, than the romanticism of the poets and architects and painters who merely created in the mind the ideal image of a more humane life. Yet the lure of more primitive conditions of life, as an alternative to the machine, remains. Some of those who shrink from the degree of social control necessary to operate the machine rationally, are now busy with plans for scrapping the machine and returning to a bare subsistence level in little island utopias devoted to sub-agriculture and sub-manufacture. The advocates of these measures for returning to the primitive forget only one fact: what they are proposing is not an adventure but a bedraggled retreat, not a release but a confession of complete failure. They propose to return to the physical conditions of pioneer existence without the positive spiritual impulse that made the original conditions tolerable and the original efforts possible. If such defeatism becomes widespread, it would mean something more than the collapse of the machine. It would mean the end of the present cycle of Western civilization. 9. Organic and mechanical polarities. During the century and a half that followed Rousseau, the cult of the primitive took many forms. Joining up with historical romanticism, which had other roots, it expressed itself on the imaginative level as an interest in the folk arts and in the products of primitive people, no longer dismissed as crude and barbarous, but valued precisely for these qualities, which were often conspicuously lacking in more highly developed communities. Not by accident was the interest in the art of the African Negroes, one of the manifestations of this cult in our century, the product of the same group of Parisian painters who accepted with utmost heartiness the new forms of the machine. Congo maintained the balance against the motor works and the subway. But on the wider platform of personal behavior, the primitive disclosed itself during the 20th century in the insurgence of sex. The erotic dances of the Polynesians, the erotic music of the African Negro tribes, these captured the imagination and presided over the recreation of the mechanically disciplined urban masses of Western civilization, reaching their swiftest development in the United States, the country that had most insistently fostered mechanical gadgets and mechanical routines. To the once dominantly masculine relaxation of drunkenness was added the heterosexual relaxation of the dance and the erotic embrace, two phases of the sexual act that were now performed in public. The reaction grew in proportion to the external restraint imposed by the day's grind, but instead of enriching TG erotic life and providing deep organic satisfactions, these compensatory measures tended to keep sex at a constant pitch of stimulation and ultimately of irritation, for the ritual of sexual excitation pervaded not merely recreation but business. It appeared in the office and the advertisement, to remind and to tantalize without providing sufficient occasions for active release. The distinction between sexual expression as one of the modes of life and sex as a compensating element in a monotonous and restricted existence must not be lost, even though it be difficult to define. For sex, I need hardly say, manifested itself in both forms during this period, and with the positive side of this development and its many fruitful and far-reaching consequences, I purpose to deal at length in another place. But in its extreme forms, the compensatory element could easily be detected, for it was marked by an abstractness and a remoteness, derived from the very environment that the populace was desperately trying to escape. The weakness of these primitive compensations disclosed itself in the usually synthetic obscenities of the popular joke, the remote glamour of the embraces of moving picture stars, the voluptuous contortions of dancers on the stage and of experiences taken in at second or third hand through the body mimicry of the popular song or, a little closer to reality, snatched hastily and furtively at the end of an automobile ride or a fatiguing day in the office or the factory. Those who escaped the anxiety and frustration of such embraces did so only by deadening their higher nerve centers by means of alcohol or by the chemistry of some form of psychal anesthesia which took the outward form of coarseness and debasement. In brief, most of the sexual compensations were little above the level of abject fantasy, whereas when sex is accepted as an important mode of life, lovers reject these weak and secondary substitutes for it, and devote their minds and energies to courtship and expression themselves, necessary steps to those enlargements and enrichments and sublimations of sex that alike maintain the species and energize the entire cultural heritage. It was a miner's son, D.H. Lawrence, who distinguished most sharply between the degradation of sex which occurs when it is merely a means of getting away from the sordid environment and oppressive dullness of a low-grade industrial town, and the exhilaration that arises when sex is genuinely respected and celebrated in its own right. The weakness of the sexual relapse into the primitive was not indeed unlike that which overtook the more general cultivation of the body through sport. The impulse that excited it was genuine and justified, but the form it took did not lead to a transformation of the original condition, rather, it became the mechanism by means of which the original condition was remedied sufficiently to continue in existence. Sex had a larger part of life to claim than it filched for itself in the instinctive reaction against the machine. As the machine tended toward the pole of regularity and complete automatism, it became severed, finally, from the umbilical cord that bound it to the bodies of men and women. It became an absolute. That was the danger Samuel Butler jestingly prophesied in Eruhan, the danger that the human being might become a means whereby the machine perpetuated itself and extended its dominion. The recoil from the absolute of mechanism was into an equally sterile absolute of the organic, the raw primitive. The organic processes, reduced to shadows by the machine, made a violent effort to retrieve their position. The machine, which acerbically denied the flesh, was offset by the flesh, which denied the rational, the intelligent, the orderly processes of behavior that have entered into all man's cultural developments, even those developments that most closely derive from the organic. The spurious notion that mechanism had naught to learn from life was supplanted by the equally false notion that life had nothing to learn from mechanism. On one side is the gigantic printing press, a miracle of fine articulation, which turns out the tabloid newspaper. On the other side are the contents of the tabloid itself, symbolically recording the most crude and elementary states of emotion, feeling, barely vestigial thought. Here the impersonal and the cooperative and the objective, over against it the limited, the subjective, the recalcitrant, violent ego, full of hatreds, fears, blind frenzies, crude impulses toward destruction. Mechanical instruments, potentially a vehicle of rational human purposes, are scarcely a blessing when they enable the gossip of the village idiot and the DJ of the thug to be broadcast to 1 million people each day. The effect of this return to the absolute primitive, like so many other neurotic adaptations that temporarily bridge the chasm, develops stresses of its own which tend to push the two sides of existence still further apart. That hiatus limits the efficiency of the compensatory reaction. Ultimately it spells ruin for the civilization that seeks to maintain the raw mechanical by weighting it with the raw primitive. For in its broadest reaches, including all those cultural interests and sentiments and admirations which sustain the work of the scientist, the technician, the artist, the philosopher, even when they do not appear directly in the particular work itself, in its broadest reaches the civilization cannot be run by barbarians. A hairy ape in the stokehold is a grave danger signal. A hairy ape on the bridge means speedy shipwreck. The appearance of such apes, in the forms of those political dictators who attempt to accomplish by calculated brutality and aggression what they lack the intelligence and magnanimity to consummate by more humane direction, indicates on what an infirm and treacherous foundation the machine at present rests. For, more disastrous than any mere physical destruction of machines by the barbarian is his threat to turn off or divert the human motive power, discouraging the cooperative processes of thought and the disinterested research which are responsible for our major technical achievements. Toward the end of his life Herbert Spencer viewed with proper alarm the regression into imperialism, militarism, servility that he saw all around him at the beginning of the present century, and in truth he had every reason for his forebodings. But the point is that these forces were not merely archaic survivals that had failed to be extirpated by the machine. They were rather underlying human elements awakened into stertorous activity by the very victory of the machine as an absolute and non-conditioned force in human life. The machine, by failing as yet despite neotechnic advances to allow sufficient play in social existence to the organic, has opened the way for its return in the narrow and inimical form of the primitive. Western society is relapsing at critical points into pre-civilized modes of thought, feeling, and action because it has acquiesced too easily in the dehumanization of society through capitalist exploitation and military conquest. The retreat into the primitive is, in sum, a maudlin effort to avoid the more basic and infinitely more difficult transformation which our thinkers and leaders and doers have lacked the candor to face, the intelligence to contrive, and the will to effect the transition beyond the historic forms of capitalism and the equally limited original forms of the machine to a life-centered economy. 10. Sport and the bitch goddess. The Romantic movements were important as a corrective to the machine because they called attention to essential elements in life that were left out of the mechanical world picture. They themselves prepared some of the materials for a richer synthesis. But there is within modern civilization a whole series of compensatory functions that, so far from making better integration possible, only serve to stabilize the existing state, and finally they themselves become part of the very regimentation they exist to combat. The chief of these institutions is perhaps mass sports. One may define these sports as those forms of organized play in which the spectator is more important than the player, and in which a good part of the meaning is lost when the game is played for itself. Mass sport is primarily a spectacle. Unlike play, mass sport usually requires an element of mortal chance or hazard as one of its main ingredients, but instead of the chances occurring spontaneously, as in mountain climbing, it must take place in accordance with the rules of the game and must be increased when the spectacle begins to bore the spectators. Play in one form or another is found in every human society and among a great many animal species, but sport in the sense of a mass spectacle, with death to add to the underlying excitement, comes into existence when a population has been drilled and regimented and depressed to such an extent that it needs at least a vicarious participation in difficult feats of strength or skill or heroism in order to sustain its waning life sense. The demand for circuses, and when the milder spectacles are still insufficiently life-arousing, the demand for sadistic exploits and finally for blood is characteristic of civilizations that are losing their grip, Rome under the Caesars, Mexico at the time of Montezuma, Germany under the Nazis. These forms of surrogate manliness and bravado are the surest signs of a collective impotence and a pervasive death wish. The dangerous symptoms of that ultimate decay one finds everywhere today in machine civilization under the guise of mass sport. The invention of new forms of sport and the conversion of play into sport were two of the distinctive marks of the last century. Baseball is an example of the first, and the transformation of tennis and golf into tournament spectacles, within our own day, is an example of the second. Unlike play, sport has an existence in our mechanical civilization even in its most abstract possible manifestation. The crowd that does not witness the ball game will huddle around the scoreboard in the metropolis to watch the change of counters. If it does not see the aviator finish a record flight around the world, it will listen over the radio to the report of his landing and hear the frantic shouts of the mob on the field. Should the hero attempt to avoid a public reception and parade, he would be regarded as cheating. At times, as in horse racing, the elements may be reduced to names and betting odds. Participation need go no further than the newspaper and the betting booth, provided that the element of chance be there. Since the principal aim of our mechanical routine in industry is to reduce the domain of chance, it is in the glorification of chance and the unexpected, which sport provides, that the element extruded by the machine returns, with an accumulated emotional charge, to life in general. In the latest forms of mass sport, like air races and motor races, the thrill of the spectacle is intensified by the promise of immediate death or fatal injury. The cry of horror that escapes from the crowd when the motor car overturns or the airplane crashes is not one of surprise but of fulfilled expectation. Is it not fundamentally for the sake of exciting just such bloodlust that the competition itself is held and widely attended? By means of the talking picture, that spectacle and that thrill are repeated in 1,000 theaters throughout the world as a mere incident in the presentation of the week's news, so that a steady habituation to bloodletting and exhibitionistic murder and suicide accompanies the spread of the machine and, becoming stale by repetition in its milder forms, encourages the demand for more massive and desperate exhibitions of brutality. Sport presents three main elements: the spectacle, the competition, and the personalities of the gladiators. The spectacle itself introduces the aesthetic element, so often lacking in the paleotechnic industrial environment itself. The race is run or the game is played within a frame of spectators, tightly massed. The movements of this mass, their cries, their songs, their cheers, are a constant accompaniment of the spectacle. They play, in effect, the part of the Greek chorus in the new machine drama, announcing what is about to occur and underlining the events of the contest. Through his place in the chorus, the spectator finds his special release, usually cut off from close physical associations by his impersonal routine. He is now at one with a primitive undifferentiated group. His muscles contract or relax with the progress of the game, his breath comes quick or slow, his shouts heighten the excitement of the moment and increase his internal sense of the drama. In moments of frenzy he pounds his neighbor's back or embraces him. The spectator feels himself contributing by his presence to the victory of his side, and sometimes, more by hostility to the enemy than encouragement to the friend, he does perhaps exercise a visible effect on the contest. It is a relief from the passive role of taking orders and automatically filling them, of conforming by means of a reduced I to a magnified it, for in the sports arena the spectator has the illusion of being completely mobilized and utilized. Moreover, the spectacle itself is one of the richest satisfactions for the aesthetic sense that the machine civilization offers to those that have no key to any other form of culture. The spectator knows the style of his favorite contestants in the way that the painter knows the characteristic line or palette of his master, and he reacts to the bowler, the pitcher, the punter, the server, the air ace, with a view, not only to his success in scoring, but to the aesthetic spectacle itself. This point has been stressed in bullfighting, but of course it applies to every form of sport. There remains, nevertheless, a conflict between the desire for a skilled exhibition and the desire for a brutal outcome, the maceration or death of one or more of the contestants. Now in the competition two elements are in conflict, chance and record making. Chance is the sauce that stimulates the excitement of the spectator and increases his zest for gambling. Whippet racing and horse racing are as effective in this relation as games where a greater degree of human skill is involved. But the habits of the mechanical regime are as difficult to combat in sport as in the realm of sexual behavior, hence one of the most significant elements in modern sport is the fact that an abstract interest in record-making has become one of its main preoccupations. To cut the fifth of a second off the time of running a race, to swim the English Channel 20 minutes faster than another swimmer, to stay up in the air an hour longer than one's rival did, these interests come into the competition and turn it from a purely human contest to one in which the real opponent is the previous record. Time takes the place of a visible rival. Sometimes, as in dance marathons or flagpole squattings, the record goes to feats of inane endurance, the blankest and dreariest of subhuman spectacles. With the increase in professionalized skill that accompanies this change, the element of chance is further reduced. The sport, which was originally a drama, becomes an exhibition. As soon as specialism reaches this point, the whole performance is arranged as far as possible for the end of making possible the victory of the popular favorite. The other contestants are, so to say, thrown to the lions. Instead of fair play, the rule now becomes success at any price. Finally, in addition to the spectacle and the competition, there comes onto the stage, further to differentiate sport from play, a new type of popular hero, the professional player or sportsman. He is as specialized for the vocation as a soldier or an opera singer. He represents virility, courage, gameness, those talents in exercising and commanding the body which have so small a part in the new mechanical regimen itself. If the hero is a girl, her qualities must be Amazonian in character. The sports hero represents the masculine virtues, the Mars complex, as the popular motion picture actress or the bathing beauty contestant represents Venus. He exhibits that complete skill to which the amateur vainly aspires. Instead of being looked upon as a servile and ignoble being, because of the very perfection of his physical efforts, as the Athenians in Socrates' time looked upon the professional athletes and dancers, this new hero represents the summit of the amateur's effort, not at pleasure but at efficiency. The hero is handsomely paid for his efforts, as well as being rewarded by praise and publicity, and he thus further restores to sport its connection with the very commercialized existence from which it is supposed to provide relief, restores it and thereby sanctifies it. The few heroes who resist this vulgarization, notably Lindbergh, fall into popular or at least into journalistic disfavor, for they are only playing the less important part of the game. The really successful sports hero, to satisfy the mass demand, must be midway between a pander and a prostitute. Sport, then, in this mechanized society, is no longer a mere game empty of any reward other than the playing. It is a profitable business. Millions are invested in arenas, equipment, and players, and the maintenance of sport becomes as important as the maintenance of any other form of profit-making mechanism. And the technique of mass sport infects other activities. Scientific expeditions and geographic explorations are conducted in the manner of a speed stunt or a prize fight, and for the same reason. Business or recreation or mass spectacle, sport is always a means, even when it is reduced to athletic and military exercises held with great pomp within the sports arenas. The aim is to gather a record-breaking crowd of performers and spectators, and thus testify to the success or importance of the movement that is represented. Thus sport, which began originally, perhaps, as a spontaneous reaction against the machine, has become one of the mass duties of the machine age. It is a part of that universal regimentation of life for the sake of private profits or nationalistic exploit from which its excitement provides a temporary and only a superficial release. Sport has turned out, in short, to be one of the least effective reactions against the machine. There is only one other reaction less effective in its final result, the most ambitious as well as the most disastrous. I mean war. 11. The cult of death. Conflict, of which war is a specialized institutional drama, is a recurrent fact in human societies. It is indeed inevitable when society has reached any degree of differentiation, because the absence of conflict would presume a unanimity that exists only in placentals between embryos and their female parents. The desire to achieve that kind of unity is one of the most patently regressive characteristics of totalitarian states and other similar attempts at tyranny in smaller groups. But war is that special form of conflict in which the aim is not to resolve the points of difference but to annihilate physically the defenders of opposing points or reduce them by force to submission. And whereas conflict is an inevitable incident in any active system of cooperation, to be welcomed just because of the salutary variations and modifications it introduces, war is plainly a specialized perversion of conflict, bequeathed perhaps by the more predatory hunting groups, and it is no more an eternal and necessary phenomenon in group life than is cannibalism or infanticide. War differs in scale, in intention, in deadliness, and in frequency with the type of society. It ranges all the way from the predominantly ritualistic warfare of many primitive societies to the ferocious slaughters instituted from time to time by barbarian conquerors like Genghis Khan and the systematic combats between entire nations that now occupy so much of the time and energy and attention of advanced and peaceful industrial countries. The impulses toward destruction have plainly not decreased with progress in the means. Indeed, there is some reason to think that our original collecting and food-gathering ancestors, before they had invented weapons to aid them in hunting, were more peaceful in habit than their more civilized descendants. As war has increased in destructiveness, the sporting element has grown smaller. Legend tells of an ancient conqueror who spurned to capture a town by surprise at night because it would be too easy and would take away the glory. Today a well-organized army attempts to exterminate the enemy by artillery fire before it advances to capture the position. In almost all its manifestations, however, war indicates a throwback to an infantile cycle pattern on the part of people who can no longer stand the exacting strain of life in groups, with all the necessities for compromise, give and take, live and let live, understanding and sympathy that such life demands, and with all the complexities of adjustment involved. They seek by the knife and the gun to unravel the social knot. But whereas national wars today are essentially collective competitions in which the battlefield takes the place of the market, the ability of war to command the loyalty and interests of the entire underlying population rests partly upon its peculiar psychological reactions. It provides an outlet and an emotional release. Art degraded, imagination denied, as Blake says, war governed the nations. For war is the supreme drama of a completely mechanized society, and it has an element of advantage that puts it high above all the other preparatory forms of mass sport in which the attitudes of war are mimicked. War is real, while in all the other mass sports there is an element of make-believe. Apart from the excitements of the game and the gains or losses from gambling, it does not really matter who is victorious. In war, there is no doubt as to the reality. Success may bring the reward of death just as surely as failure, and it may bring it to the remotest spectator as well as to the gladiators in the center of the vast arena of the nations. But war, for those actually engaged in combat, likewise brings a release from the sordid motives of profit-making and self-seeking that govern the prevailing forms of business enterprise, including sport. The action has the significance of high drama. And while warfare is one of the principal sources of mechanism, and its drill and regimentation are the very pattern of old-style industrial effort, it provides, far more than the sport field, the necessary compensations to this routine. The preparation of the soldier, the parade, the smartness and polish of the equipment and uniform, the precise movement of large bodies of men, the blare of bugles, the punctuation of drums, the rhythm of the march, and then, in actual battle itself, the final explosion of effort in the bombardment and the charge, lend an aesthetic and moral grandeur to the whole performance. The death or maiming of the body gives the drama the element of a tragic sacrifice, like that which underlies so many primitive religious rituals, the effort is sanctified and intensified by the scale of the Holocaust. For peoples that have lost the values of culture and can no longer respond with interest or understanding to the symbols of culture, the abandonment of the whole process and the reversion to crude faiths and non-rational dogmas, is powerfully abetted by the processes of war. If no enemy really existed, it would be necessary to create him, in order to further this development. Thus war breaks the tedium of a mechanized society and relieves it from the pettiness and prudence of its daily efforts, by concentrating to their last degree both the mechanization of the means of production and the countering vigor of desperate vital outbursts. War sanctions the utmost exhibition of the primitive at the same time that it deifies the mechanical. In modern war, the raw primitive and the clockwork mechanical are one. In view of its end products, the dead, the crippled, the insane, the devastated regions, the shattered resources, the moral corruption, the antisocial hates and hoodlumisms, war is the most disastrous outlet for the repressed impulses of society that has been devised. The evil consequences have increased in magnitude and in human distress in proportion as the actual elements of fighting have become more mechanized. The threat of chemical warfare against the civilian population as well as the military arm places in the hands of the armies of the world instruments of ruthlessness of which only the most savage conquerors in the past would have taken advantage. The difference between the Athenians with their swords and shields fighting on the fields of Marathon, and the soldiers who faced each other with tanks, guns, flamethrowers, poison gases, and hand grenades on the Western Front, is the difference between the ritual of the dance and the routine of the slaughterhouse. One is an exhibition of skill and courage with the chance of death present, the other is an exhibition of the arts of death, with the almost accidental byproduct of skill and courage. But it is in death that these repressed and regimented populations have their first glimpse of effective life, and the cult of death is a sign of their throwback to the corrupt primitive. As a backfire against mechanism, war, even more than mass sport, has increased the area of the conflagration without stemming its advance. Still, as long as the machine remains an absolute, war will represent for this society the sum of its values and compensations, for war brings people back to the earth, makes them face the battle with the elements, unleashes the brute forces of their own nature, releases the normal restraints of social life, and sanctions a return to the primitive in thought and feeling, even as it further sanctions infantility in the blind personal obedience it exacts, like that of the archetypal father with the archetypal son, which divests the latter of the need of behaving like a responsible and autonomous personality. Savagery, which we have associated with the not yet civilized, is equally a reversionary mode that arises with the mechanically over-civilized. Sometimes the mechanism against which reaction takes place is a compulsive morality or social regimentation. In the case of Western peoples it is the too closely regimented environment we associate with the machine. War, like a neurosis, is the destructive solution of an unbearable tension and conflict between organic impulses and the code and circumstances that keep one from satisfying them. This destructive union of the mechanized and the savage primitive is the alternative to a mature, humanized culture capable of directing the machine to the enhancement of communal and personal life. If our life were an organic whole, this split and this perversion would not be possible, for the order we have embodied in machines would be more completely exemplified in our personal life, and the primitive impulses, which we have diverted or repressed by excessive preoccupation with mechanical devices, would have natural outlets in their appropriate cultural forms. Until we begin to achieve this culture, however, war will probably remain the constant shadow of the machine, the wars of national armies, the wars of gangs, the wars of classes, beneath all, incessant preparation by drill and propaganda towards these wars. A society that has lost its life values will tend to make a religion of death and build up a cult around its worship, a religion not less grateful because it satisfies the mounting number of paranoiacs and sadists such a disrupted society necessarily produces. 12. The minor shock absorbers. From all the forms of resistance and compensation we have been examining, it is plain that the introduction of the machine was not smooth, nor were its characteristic habits of life undisputed. The Reactions would probably have been more numerous and more disastrous had it not been for the fact that old habits of neglect and old ways of life continued in existence. This bridged the gap between the old and the new, and kept the machine from dominating life as a whole as much as it controlled the routine of industrial activity. In part, these existing institutions, while they stabilized society, prevented it from absorbing and reacting upon the cultural elements derived from the machine, so that they lessened the valuable offices of the machine in the act of mitigating its defects. In addition to the stabilizing inertia of society as a whole, and to the many-sided attempts to combat the machine by the force of ideas and institutional contrivances, there were still other reactions that served, as it were, as cushions and shock absorbers. So far from stopping the machine or undermining the purely mechanical program, they perhaps decreased the tensions that the machine produced. Thus the tendency to destroy the memorials of older cultures, exhibited by the utilitarians in their first vigor of self-confidence and creative effort, was met in part among the very classes that were most active in this attack, by the cult of antiquarianism. This cult lacked the passionate conviction that one period or another of the past was of supreme value. It merely held that almost anything old was ipso facto valuable or beautiful, whether it was a fragment of Roman statuary, a wooden image of a 15th-century saint, or an iron door knocker. The exponents of this cult attempted to create private environments from which every hint of the machine was absent. They burned wooden logs in the open fireplaces of imitation Norman manor houses, which were in reality heated by steam, designed with the help of a camera and measured drawings, and supported, where the architect was a little uncertain of his skill or materials, with concealed steel beams. When handicraft articles could not be filched from the decayed buildings of the past, they were copied with vast effort by belated hand workers. When the demand for such copies filtered down through the middle classes, they were then reproduced by means of power machinery in a fashion capable of deceiving only the blind and ignorant, a double prevarication. Oppressed by a mechanical environment they had neither mastered nor humanized nor succeeded aesthetically in appreciating, the ruling classes and their imitators among the lesser bourgeoisie retreated from the factory or the office into a fake non-mechanical environment, in which the past was modified by the addition of physical comforts, such as tropical temperature in the winter and springs and padding on sofas, lounges, beds. Each successful individual produced his own special antiquarian environment, a private world. This private world, as lived in suburbia or in the more palatial country houses, is not to be differentiated by any objective standard from the world in which the lunatic attempts to live out the drama in which he appears to himself to be Lorenzo the Magnificent or Louis XIV. In each case the difficulty of maintaining an equilibrium in relation to a difficult or hostile external world is solved by withdrawal, permanent or temporary, into a private retreat, untainted by most of the conditions that public life and effort lay down. These antiquarian stage settings, which characterized for the most part the domestic equipment of the more successful members of the bourgeoisie from the 18th century onward with a minor interlude of self-confident ugliness during the high Paleotechnic period, these stage settings were, on a strict psychological interpretation, cells. Indeed, the addition of comforts made them padded cells. Those who lived in them were stable, normal, adjusted people. In relation to the entire environment in which they worked and thought and lived, they merely behaved as if they were in a state of neurotic collapse, as if there were a deep conflict between their inner drive and the mechanical environment they had helped to create, as if they had been unable to resolve their divided activities into a single consistent pattern. The other side of this conservatism of taste and this refusal to recognize natural change was the tendency to take refuge in change for its own sake, and to hasten the very process that was introduced by the machine. Changing the style of an object, altering its superficial shape or color, without effecting any real improvement, became part of the routine of modern society just because the natural variations and breaks in life were absent. The answer to excessive regimentation came in through an equally heightened and overstimulated demand for novelties. In the long run, unceasing change is as monotonous as unceasing sameness. Real refreshment implies both uncertainty and choice, and to have to abandon choice merely because for external reasons a style has changed is to forfeit what real gain has been made. Here again change and novelty are no more sacred, no more inimical, than stability and monotony, but the purposeless materialism and imbecile regimentation of production resulted in the aimless change and the absence of real stimuli and effective adjustments in consumption, and so far from resolving the difficulty the resistance only increased it. The itch for change, the itch for movement, the itch for novelty infected the entire system of production and consumption and severed them from the real standards and norms which it was highly important to devise. When people's work and days were varied they were content to remain in the same place. When their lives were ironed out into a blank routine they found it necessary to move, and the more rapidly they moved the more standardized became the environment in which they moved. There was no getting away from it. So it went in every department of life. Where the physical means of withdrawal were inadequate, pure fantasy flourished without any other external means than the word or the picture. But these external means were put upon a mechanized collective basis during the 19th century, as a result of the cheapened processes of production made possible by the rotary press, the camera, photo engraving, and the motion picture. With the spread of literacy, literature of all grades and levels formed a semi-public world into which the unsatisfied individual might withdraw, to live a life of adventure following the travelers and explorers in their memoirs, to live a life of dangerous action and keen observation by participating in the crimes and investigations of a Dupin or a Sherlock Holmes, or to live a life of romantic fulfillment in the love stories and erotic romances that became everyone's property from the 18th century onward. Most of these varieties of daydream and private fantasy had of course existed in the past, now they became part of a gigantic collective apparatus of escape. So important was the function of popular literature as escape that many modern psychologists have treated literature as a whole as a mere vehicle of withdrawal from the harsh realities of existence, forgetful of the fact that literature of the first order, so far from being a mere pleasure device, is a supreme attempt to face and encompass reality, an attempt beside which a busy working life involves a shrinkage and represents a partial retreat. During the 19th century vulgar literature to a large extent replaced the mythological constructions of religion, the austere cosmical sweep and the careful moral codes of the more sacred religions were, alas, a little too much akin to the machine itself, from which people were trying to escape. This withdrawal into fantasy was immensely reinforced from 1910 on, by the motion picture, which came into existence just when the pressure from the machine was beginning to bear down more and more inexorably. Public daydreams of wealth, magnificence, adventure, irregularity and spontaneous action, identification with the criminal defying the forces of order, identification with the courtesan practicing openly the allurements of sex. These scarcely adolescent fantasies, created and projected with the aid of the machine, made the machine ritual tolerable to the vast urban or urbanized populations of the world. But these dreams were no longer private, and what is more, they were no longer spontaneous and free. They were promptly capitalized on a vast scale as the amusement business, and established as a vested interest. To create a more liberal life that might do without such anodynes was to threaten the safety of investments, built on the certainty of continued dullness, boredom, and defeat. Too dull to think, people might read; too tired to read, they might look at the moving pictures; unable to visit the picture theater they might turn on the radio; in any case, they might avoid the call to action. Surrogate lovers, surrogate heroes and heroines, surrogate wealth filled their debilitated and impoverished lives and carried the perfume of unreality into their dwellings. And as the machine itself became, as it were, more active and human, reproducing the organic properties of eye and ear, the human beings who employed the machine as a mode of escape have tended to become more passive and mechanical. Unsure of their own voices, unable to hold a tune. They carry a phonograph or a radio set with them even on a picnic, afraid to be alone with their own thoughts, afraid to confront the blankness and inertia of their own minds. They turn on the radio and eat and talk and sleep to the accompaniment of a continuous stimulus from the outside world, now a band, now a bit of propaganda, now a piece of public gossip called news. Even such autonomy as the poorest drudge once had, left like Cinderella to her dreams of Prince Charming when her sisters went off to the ball, is gone in this mechanical environment. Whatever compensations her present-day counterpart may have, it must come through the machine. Using the machine alone to escape from the machine, our mechanized populations have jumped from a hot frying pan into a hotter fire. The shock absorbers are of the same order as the environment itself. The moving picture deliberately glorifies the cold brutality and homicidal lusts of gangsterdom. The newsreel prepares for battles to come by exhibiting each week the latest devices of armed combat, accompanied by a few persuasive bars from the national anthem. In the act of relieving psychological strain, these various devices only increase the final tension and support more disastrous forms of release. After one has lived through 1,000 callous deaths on the screen, one is ready for a rape, a lynching, a murder, or a war in actual life. When the surrogate excitements of the film and the radio begin to pall, a taste of real blood becomes necessary. In short, the shock absorber prepares one for a fresh shock. 13. Resistance and adjustment. In all these efforts to attack, to resist, or to retreat from the machine, the observer may be tempted to see nothing more than the phenomenon that Professor W. F. Ogburn has described as the cultural lag. The failure of adjustment may be looked upon as a failure of art and morals and religion to change with the same degree of rapidity as the machine and to change in the same direction. This seems to me an essentially superficial interpretation. For one thing, change in a direction opposite to the machine may be as important in ensuring adjustment as change in the same direction, when it happens that the machine is taking a course that would, unless compensated, lead to human deterioration and collapse. For another thing, this interpretation regards the machine as an independent structure, and it holds the direction and rate of change assumed by the machine as a norm, to which all the other aspects of human life must conform. Intrudely, interactions between organisms and their environments take place in both directions, and it is just as correct to regard the machinery of warfare as retarded in relation to the morality of Confucius as to take the opposite position. In his The Instinct of Workmanship, Thorstein Veblen carefully avoided the one-sided notion of adjustment, but later economists and sociologists have not always been so unparochial, and they have treated the machine as if it were final and as if it were something other than the projection of one particular side of the human personality. All the arts and institutions of man derive their authority from the nature of human life as such. This applies as fully to technics as to painting. A particular economic or technical regime may deny this nature, as some particular social custom, like that of binding the feet of women or enforcing virginity, may deny the patent facts of physiology and anatomy, but such erroneous views and usages do not eliminate the fact they deny. At all events, the mere bulk of technology, its mere power and ubiquitousness, give no proof whatever of its relative human value or its place in the economy of an intelligent human society. The very fact that one encounters resistances, reversions, archaicisms at the moment of the greatest technical achievement even among those classes who have, from the standpoint of wealth and power, benefited most by the victory of the machine makes one doubt both the effectiveness and the sufficiency of the whole scheme of life the machine has so far brought into existence. And who is so innocent today as to think that maladjustment to the machine can be solved by the simple process of introducing greater quantities of machinery? Plainly, if human life consisted solely in adjustment to the dominant physical and social environment, man would have left the world as he found it, as most of his biological companions have done. The machine itself would not have been invented. Man's singular ability consists in the fact that he creates standards and ends of his own, not given directly in the external scheme of things, and in fulfilling his own nature in cooperation with the environment, he creates a third realm, the realm of the arts, in which the two are harmonized and ordered and made significant. Man is that part of nature in which causality may, under appropriate circumstances, give place to finality, in which the ends condition the means. Sometimes man's standards are grotesque and arbitrary, untempered by positive knowledge and a just sense of his limitations. Man is capable of deforming the human anatomy in pursuit of a barbarous dream of beauty, or, to objectify his fears and his tortured desires, he may resort to horrible human sacrifices. But even in these perversions there is an acknowledgement that man himself in part creates the conditions under which he lives, and is not merely the impotent prisoner of circumstances. If this has been man's attitude toward nature, why should he assume a more craven posture in confronting the machine, whose physical laws he discovered, whose body he created, whose rhythms he anticipated by external feats of regimentation in his own life? It is absurd to hold that we must continue to accept the bourgeoisie's overwhelming concern for power, practical success, above all for comfort, or that we must passively absorb, without discrimination and selection, which implies, where necessary, rejection all the new products of the machine. It is equally foolish to believe that we must conform our living and thinking to the antiquated ideological system which helped create the numerous brilliant shortcuts that attended the early development of the machine. The real question before us lies here: do these instruments further life and enhance its values, or not? Some of the results, as I shall show in the next chapter, are admirable, far more admirable even than the inventor and the industrialist and the utilitarian permitted himself to imagine. Other aspects of the machine are on the contrary trifling, and still others, like modern mechanized warfare, are deliberately antagonistic to every ideal of humanity, even to the old-fashioned ideal of the soldier who once risked his life in equal combat. In these latter cases, our problem is to eliminate or subjugate the machine, unless we ourselves wish to be eliminated. For it is not automatism and standardization and order that are dangerous. What is dangerous is the restriction of life that has so often attended their untutored acceptance. By what inept logic must we bow to our creation if it be a machine, and spurn it as unreal if it happens to be a painting or a poem? The machine is just as much a creature of thought as the poem is as much a fact of reality as the machine. Those who use the machine when they need to react to life directly or employ the humane arts, are as completely lacking in efficiency as if they studied metaphysics in order to learn how to bake bread. The question in each case is, what is the appropriate life reaction? How far does this or that instrument further the biological purposes or the ideal ends of life? Every form of life, as Patrick Geddes has expressed it, is marked not merely by adjustment to the environment, but by insurgence against the environment. It is both creature and creator, both the victim of fate and the master of destiny. It lives no less by domination than by acceptance. In man this insurgence reaches its apex, and manifests itself most completely, perhaps, in the arts, where dream and actuality, the imagination and its limiting conditions, the ideal and the means, are fused together in the dynamic act of expression and in the resultant body that is expressed. As a being with a social heritage, man belongs to a world that includes the past and the future, in which he can by his selective efforts create passages and ends not derived from the immediate situation, and alter the blind direction of the senseless forces that surround him. To recognize these facts is perhaps the first step toward dealing rationally with the machine. We must abandon our futile and lamentable dodges for resisting the machine by stultifying relapses into savagery, by recourse to anesthetics and shock absorbers. Though they temporarily may relieve the strain, in the end they do more harm than they avoid. On the other hand, the most objective advocates of the machine must recognize the underlying human validity of the romantic protest against the machine. The elements originally embodied in literature and art in the Romantic movement are essential parts of the human heritage that cannot be neglected or flouted. They point to a synthesis more comprehensive than that developed through the organs of the machine itself. Failing to create the synthesis, failing to incorporate it in our personal and communal life, the machine will be able to continue only with the aid of shock absorbers which confirm its worst characteristics, or with the compensatory adjustment of vicious and barbaric elements which will, in all probability, ruin the entire structure of our civilization. Chapter 7. Assimilation of the machine. 1. New cultural values. The tools and utensils used during the greater part of man's history were, in the main, extensions of his own organism. They did not have what is more important, they did not seem to have an independent existence. But though they were an intimate part of the worker, they reacted upon his capacities, sharpening his eye, refining his skill, teaching him to respect the nature of the material with which he was dealing. The tool brought man into closer harmony with his environment, not merely because it enabled him to reshape it, but because it made him recognize the limits of his capacities. In dream, he was all-powerful. In reality he had to recognize the weight of stone and cut stones no bigger than he could transport. In the Book of Wisdom the carpenter, the smith, the potter, the peasant wrote, if they did not sign, their several pages. And in this sense, Technics has been, in every age, a constant instrument of discipline and education. A surviving primitive might, here and there, vent his anger on a cart that got stuck in the mud by breaking up its wheels, in the same fashion that he would beat a donkey that refused to move, but the mass of mankind learned, at least during the period of the written record, that certain parts of the environment can neither be intimidated nor cajoled. To control them, one must learn the laws of their behavior, instead of petulantly imposing one's own wishes. Thus the lore and tradition of Technics, however empirical, tended to create the picture of an objective reality. Something of this fact remained in the Victorian definition of science as organized common sense. Because of their independent source of power, and their semi-automatic operation even in their cruder forms, machines have seemed to live a reality and an independent existence apart from the user. Ulteriorly, the educational values of handicraft were mainly in the process, those of the machine were largely in the preparatory design, hence the process itself was understood only by the machinists and technicians responsible for the design and operation of the actual machinery. As production became more mechanized and the discipline of the factory became more impersonal and the work itself became less rewarding, apart from such slight opportunities for social intercourse as it furthered, attention was centered more and more upon the product. People valued the machine for its external achievements, for the number of yards of cloth it wove, for the number of miles it carried them. The machine thus appeared purely as an external instrument for the conquest of the environment, the actual forms of the products, the actual collaboration and intelligence manifested in creating them, the educational possibilities of this impersonal cooperation itself, all these elements were neglected. We assimilated the objects rather than the spirit that produced them, and so far from respecting that spirit, we again and again attempted to make the objects themselves seem to be something other than a product of the machine. We did not expect beauty through the machine any more than we expected a higher standard of morality from the laboratory, yet the fact remains that if we seek an authentic sample of a new aesthetic or a higher ethic during the 19th century, it is in technics and science that we will perhaps most easily find them. The practical men themselves were the very persons who stood in the way of our recognizing that the significance of the machine was not limited to its practical achievements. For, on the terms that the inventors and industrialists considered the machine, it did not carry over from the factory and the marketplace into any other department of human life, except as a means. The possibility that Technics had become a creative force, carried on by its own momentum, that it was rapidly ordering a new kind of environment and was producing a third estate midway between nature and the humane arts, that it was not merely a quicker way of achieving old ends but an effective way of expressing new ends. The possibility, in short, that the machine furthered a new mode of living was far from the minds of those who actively promoted it. The industrialists and engineers themselves did not believe in the qualitative and cultural aspects of the machine. In their indifference to these aspects, they were just as far from appreciating the nature of the machine as were the Romantics, only what the Romantics, judging the machine from the standpoint of life, regarded as a defect the utilitarian boasted of as a virtue. For the latter the absence of art was an assurance of practicality. If the machine had really lacked cultural values, the Romantics would have been right, and their desire to seek these values, if need be, in a dead past would have been justified by the very desperateness of the case. But the interests in the factual and the practical, which the industrialist made the sole key to intelligence, were only two in a whole series of new values that had been called into existence by the development of the new techniques. Matters of fact and practice had usually in previous civilizations been treated with snobbish contempt by the leisured classes, as if the logical ordering of propositions were any nobler a technical feat than the articulation of machines. The interest in the practical was symptomatic of that wider and more intelligible world in which people had begun to live, a world in which the taboos of class and caste could no longer be considered as definitive in dealing with events and experiences. Capitalism and technics had both acted as a solvent of these clots of prejudice and intellectual confusion, and they were thus at first important liberators of life. From the beginning, indeed, the most durable conquests of the machine lay not in the instruments themselves, which quickly became outmoded, nor in the goods produced, which quickly were consumed, but in the modes of life made possible via the machine. And in the machine, the cranky mechanical slave was also a pedagogue. While the machine increased the servitude of servile personalities, it also promised the further liberation of released personalities. It challenged thought and effort as no previous system of techniques had done. No part of the environment, no social conventions, could be taken for granted, once the machine had shown how far order and system and intelligence might prevail over the raw nature of things. What remains as the permanent contribution of the machine, carried over from one generation to another, is the technique of cooperative thought and action it has fostered, the aesthetic excellence of the machine forms, the delicate logic of materials and forces, which has added a new canon, the machine canon, to the arts, above all, perhaps, the more objective personality that has come into existence through a more sensitive and understanding intercourse with these new social instruments and through their deliberate cultural assimilation. In projecting one side of the human personality into the concrete forms of the machine, we have created an independent environment. TJMT has reacted upon every other side of the personality. In the past, the irrational and demonic aspects of life had invaded spheres where they did not belong. It was a step in advance to discover that bacteria, not brownies, were responsible for curdling milk, and that an air-cooled motor was more effective than a witch's broomstick for rapid long-distance transportation. This triumph of order was pervasive. It gave a confidence to human purposes akin to that which a well-drilled regiment has when it marches in step. Creating the illusion of invincibility, the machine actually added to the amount of power man can exercise. Science and techniques stiffened our morale. By their very austerities and abnegations they enhanced the value of the human personality that submitted to their discipline. They cast contempt on childish fears, childish guesses, equally childish assertions. By means of the machine, man gave a concrete and external and impersonal form to his desire for order, and in a subtle way he thus set a new standard for his personal life and his more organic attitudes. Unless he was better than the machine, he would only find himself reduced to its level, dumb, servile, abject, a creature of immediate reflexes and passive unselective responses. While many of the boasted achievements of industrialism are merely rubbish, and while many of the goods produced by the machine are fraudulent and evanescent, its aesthetic, its logic, and its factual technique remain a durable contribution. They are among man's supreme conquests. The practical results may be admirable or dubious, but the method that underlies them has a permanent importance to the race, apart from its immediate consequences. For the machine has added a whole series of arts to those produced by simple tools and handicraft methods, and it has added a new realm to the environment in which the cultured man works and feels and thinks. Similarly, it has extended the power and range of human organs and has disclosed new aesthetic spectacles, new worlds. The exact arts produced with the aid of the machine have their proper standards and give their own peculiar satisfactions to the human spirit. Differing in technique from the arts of the past, they spring nevertheless from the same source, for the machine itself, I must stress for the 10th time, is a human product, and its very abstractions make it more definitely human in one sense than those humane arts which on occasion realistically counterfeit nature. Here, beyond what appears at the moment of realization, is the vital contribution of the machine. What matters the fact that the ordinary workman has the equivalent of 240 slaves to help him, if the master himself remains an imbecile, devouring the spurious news, the false suggestions, the intellectual prejudices that play upon him in the press and the school, giving vent in turn to tribal assertions and primitive lusts under the impression that he is the final token of progress and civilization. One does not make a child powerful by placing a stick of dynamite in his hands, one only adds to the dangers of his irresponsibility. Were mankind to remain children, they would exercise more effective power by being reduced to using a lump of clay and an old-fashioned modeling tool. But if the machine is one of the aids man has created toward achieving further intellectual growth and attaining maturity, if he treats this powerful automaton of his as a challenge to his own development, if the exact arts fostered by the machine have their own contribution to make to the mind, and are aids in the orderly crystallization of experience, then these contributions are vital ones indeed. The machine, which reached such overwhelming dimensions in Western civilization partly because it sprang out of a disrupted and one-sided culture, nevertheless may help in enlarging the provinces of culture itself and thereby in building a greater synthesis. In that case, it will carry an antidote to its own poison. So let us consider the machine more closely as an instrument of culture and examine the ways in which we have begun, during the last century, to assimilate it. 2. The neutrality of order. Before the machine pervaded life, order was the boast of the gods and absolute monarchs. Both the deity and his representatives on earth had, however, the misfortune to be inscrutable in their judgment and frequently capricious and cruel in their assertion of mastery. On the human level, their order was represented by slavery, complete determination from above, complete subservience without question or understanding below. Behind the gods and the absolute monarchs stood brute nature itself, filled with demons, jinns, trolls, giants, contesting the reign of the gods. Chance and the accidental malice of the universe cut across the purposes of men and the observable regularities of nature. Even as a symbol, the absolute monarch was weak as an exponent of order. His troops might obey with absolute precision, but he might be undone, as Hans Andersen pointed out in one of his fairy tales, by the small torture of a gnat. With the development of the sciences and with the articulation of the machine in practical life, the realm of order was transferred from the absolute rulers, exercising a personal control, to the universe of impersonal nature and to the particular group of artifacts and customs we call the machine. The royal formula of purpose I will was translated into the causal terms of science it must. By partly supplanting the crude desire for personal dominion by an impersonal curiosity and by the desire to understand, science prepared the way for a more effective conquest of the external environment and ultimately for a more effective control of the agent, man, himself. That a part of the order of the universe was a contribution by man himself, that the limitations imposed upon scientific research by human instruments and interests tend to produce an orderly and mathematically analyzable result, does not lessen the wonder and the beauty of the system, it rather gives to the conception of the universe itself some of the character of a work of art. To acknowledge the limitations imposed by science, to subordinate the wish to the fact, and to look for order as an emergent in observed relations, rather than as an extraneous scheme imposed upon these relations, these were the great contributions of the new outlook on life. Expressing regularities and recurrent series, science widened the area of certainty, prediction, and control. By deliberately cutting off certain phases of man's personality, the warm life of private sensation and private feelings and private perceptions, the sciences assisted in building up a more public world which gained in accessibility what it lost in depth. To measure a weight, a distance, a charge of electricity, by reference to pointer readings established within a mechanical system, deliberately constructed for this purpose, was to limit the possibility of errors of interpretation, and cancel out the differences of individual experience and private history. And the greater the degree of abstraction and limitation, the greater was the accuracy of reference. By isolating simple systems and simple causal sequences, the sciences created confidence in the possibility of finding a similar type of order in every aspect of experience. It was, indeed, by the success of science in the realm of the inorganic that we have acquired whatever belief we may legitimately entertain in the possibility of achieving similar understanding and control in the vastly more complex domain of life. The first steps in the physical sciences did not go very far. Compared to organic behavior, in which any one of a given set of stimuli may create the same reaction, or in which a single stimulus may under different conditions create a number of different reactions, in which the organism as a whole responds and changes at the same time as the isolated part one seeks to investigate. Compared to behavior within this frame, the most complicated physical reaction is gratifyingly simple. But the point is that by means of the analyses and instruments developed in the physical sciences and embodied in technics, some of the necessary preliminary instruments for biological and social exploration have been created. All measurement involves the reference of certain parts of a complex phenomenon to a simpler one whose characteristics are relatively independent and fixed and determinable. The whole personality was a useless instrument for investigating limited mechanical phenomena. In its uncritical state, it was likewise useless for investigating organic systems, whether they were animal organisms or social groups. By a process of dismemberment, science created a more useful type of order, an order external to the self. In the long run, that special limitation fortified the ego as perhaps no other achievement in thought had done. Although the most intense applications of the scientific method were in technology, the interests that it satisfied and re-excited, the desire for order that it expressed, translated themselves in other spheres. More and more factual research, the document, the exact calculation became a preliminary to expression. Indeed, the respect for quantities became a new condition of what had hitherto been crude qualitative judgments. Good and bad, beauty and ugliness, are determined, not merely by their respective natures but by the quantity one may assign to them in any particular situation. To think closely with respect to quantities is to think more accurately about the essential nature and the actual functions of things. Arsenic is a tonic in grains and a poison in ounces. The quantity, the local composition, and the environmental relation of a quality are as important, so to say, as its original sign as quality. It is for this reason that a whole series of ethical distinctions, based upon the notion of pure and absolute qualities without relation to their amounts, has been instinctively discarded by a considerable part of mankind, while Samuel Butler's dictum, that every virtue should be mixed with a little of its opposite, implying as it does that qualities are altered by trier quantitative relations, seems much closer to the heart of the matter. This respect for quantity has been grossly caricatured by dull pedantic minds who have sought by mathematical means to eliminate the qualitative aspects of complicated social and aesthetic situations, but one need not be led by their mistake into failing to recognize the peculiar contribution that our quantitative technique has made in departments apparently remote from the machine. One must distinguish between the cult of nature as a standard and a criterion of human expression and the general influence of the scientific spirit. As for the first, one may say that though Ruskin, an aesthetic disciple of science, rejected the Greek fret in decoration because it had no counterpart among flowers, minerals, or animals. For us today nature is no longer an absolute, or rather, we no longer regard nature as if man himself were not implicated in her, and as if his modifications of nature were not themselves a part of the natural order to which he is born. Even when emphasizing the impersonality of the machine, one must not forget the busy humanizing that goes on before man even half completes his picture of an objective and indifferent nature. All the tools man uses, his eyes with their limited field of vision and their insensitiveness to ultraviolet and infrared rays, his hands which can hold and manipulate only a limited number of objects at one time, his mind which tends to create categories of twos and threes because, without intensive training, to hold as many ideas together as a musician can hold notes of the piano puts an excessive strain upon his intelligence, still more his microscopes and balances, all bear the imprint of his own character as well as the general characteristics imposed by the physical environment. It has only been by a process of reasoning and inference itself not free from the taint of his origin that man has established the neutral realm of nature. Man may arbitrarily define nature as that part of his experience which is neutral to his desires and interests, but he with his desires and interests, to say nothing of his chemical constitution, has been formed by nature and inescapably is part of the system of nature. Once he has picked and chosen from this realm, as he does in science, the result is a work of art. His art, certainly it is no longer in a state of nature. In so far as the cult of nature has made men draw upon a wider experience, to discover themselves in hitherto unexplored environments, and to contrive new isolations in the laboratory which will enable them to make further discoveries, it has been a good influence. Man should be at home among the stars as well as at his own fireside. But although the new canon of order has a deep aesthetic as well as an intellectual status, external nature has no finally independent authority. It exists, as a result of man's collective experience, and as a subject for his further improvisations by means of science, technics, and the humane arts. The merit of the new order was to give man by projection an outer world which helped him to make over the hot spontaneous world of desire he carried within. But the new order, the new impersonality, was but a fragment transplanted from the personality as a whole. It had existed as part of man before he cut it off and gave it an independent milieu and an independent root system. The comprehension and transformation of this impersonal external world of technics was one of the great revelations of the painters and artists and poets of the last 3 centuries. Art is the reenactment of a reality purified, freed from constraints and irrelevant accidents, unfettered to the material circumstances that confuse the essence. The passage of the machine into art was in itself a signal of release, a sign that the hard necessities of practice, the preoccupation with the immediate battle was over, a sign that the mind was free once more to see, to contemplate, and so to enlarge and deepen all the practical benefits of the machine. Science had something other to contribute to the arts than the notion that the machine was an absolute. It contributed, through its effects upon invention and mechanization, a new type of order to the environment, an order in which power, economy, objectivity, the collective will play a more decisive part than they had played before, even in such absolute forms of dominion as in the royal priesthood and engineers of Egypt or Babylon. The sensitive apprehension of this new environment, its translation into terms which involve human affections and feelings, and that bring into play once more the full personality, became part of the mission of the artist, and the great spirits of the 19th century, who first fully greeted this altered environment, were not indifferent to it. Turner and Tennyson, Emily Dickinson and Thoreau, Tiedemann and Emerson, all saluted with admiration the locomotive, that symbol of the new order in Western society. They were conscious of the fact that new instruments were changing the dimensions and to some extent therefore the very qualities of experience. These facts were just as clear to Thoreau as to Samuel Smiles, to Kipling as to H.G. Wells. The telegraph wire, the locomotive, the ocean steamship, the very shafts and pistons and switches that conveyed and canalized or controlled the new power, could awaken emotion as well as the harp. And the war horse, the hand at the throttle or the switch, was no less regal than the hand that had once held a scepter. The second contribution of the scientific attitude was a limiting one. It tended to destroy the lingering mythologies of Greek goddesses and Christian heroes and saints, or rather, it prevented a naive and repetitious use of these symbols. But at the same time, it disclosed new universal symbols, and widened the very domain of the symbol itself. This process took place in all the arts. It affected poetry as well as architecture. The pursuit of science, however, suggested new myths. The transformation of the medieval folk legend of Dr. Faustus from Marlowe to Goethe, with Faust ending up as a builder of canals and a drainer of swamps and finding the meaning of life in sheer activity, the transformation of the Prometheus myth in Melville's Moby Dick, testify not to the destruction of myths by positive knowledge but to their more pregnant application. I can only repeat here what I have said in another place. What the scientific spirit has actually done has been to exercise the imagination in finer ways than the autistic wish, the wish of the infant possessed of the illusions of power and domination, was able to express. Faraday's ability to conceive the lines of force in a magnetic field was quite as great a triumph as the ability to conceive of fairies dancing in a ring, and, Mr. A. N. Whitehead has shown, the poets who sympathized with this new sort of imagination, poets like Shelley, Wordsworth, Whitman, Melville, did not feel themselves robbed of their specific powers, but rather found them enlarged and refreshed. One of the finest love poems in the 19th century. Whitman's Out of the Cradle endlessly rocking, is expressed in such an image as Darwin or Audubon might have used, were the scientist as capable of expressing his inner feelings as of noting external events, the poet haunting the seashore and observing the mating of the birds, day after day following their life, could scarcely have existed before the 19th century. In the early 17th century such a poet would have remained in the garden and written about a literary ghost, Philomel, and not about an actual pair of birds. In Pope's time the poet would have remained in the library and written about the birds on a lady's fan. Almost all the important works of the 19th century were cast in this mode and express the new imaginative range. They respect the fact, they are replete with observation, they project an ideal realm in and through, not transcendentally over, the landscape of actuality. Notre Dame might have been written by an historian, War and Peace by a sociologist, The Idiot might have been created by a psychiatrist, and Salammbô might have been the work of an archaeologist. I do not say that these books were scientific by intention, or that they might be replaced by a work of science without grave loss, far from it. I merely point out that they were conceived in the same spirit, that they belong to a similar plane of consciousness. Once the symbol was focused, the task of the practical arts became more purposive. Science gave the artist and the technician new objectives. It demanded that he respond to the nature of the machine's functions and refrain from seeking to express his personality by irrelevant and surreptitious means upon the objective material. The woodiness of wood, the glassiness of glass, the metallic quality of steel, the movement of motion, these attributes had been analyzed out by chemical and physical means, and to respect them was to understand and work with the new environment. Ornament, conceived apart from function, was as barbarous as the tattooing of the human body. The naked object, whatever it was, had its own beauty, whose revealment made it more human, and more close to the new personality than could any amount of artful decoration. While the Dutch gardeners of the 17th century had often, for example, turned the privet and the box into the shapes of animals and arbitrary figures, a new type of gardening appeared in the 20th century which respected the natural ecological partnerships, and which not merely permitted plants to grow in their natural shapes but sought simply to clarify their natural relationships. Scientific knowledge was one of the facts that indirectly contributed to the aesthetic pleasure. That change symbolizes what has been steadily happening, sometimes slowly, sometimes rapidly, in all the arts. For finally, if nature itself is not an absolute, and if the facts of external nature are not the artist's sole materials, nor its literal imitation his guarantee of aesthetic success, science nevertheless gives him the assurance of a partly independent realm which defines the limits of his own working powers. In creating his union of the inner world and the outer, of his passions and affections with the thing that exists, the artist need not remain the passive victim of his neurotic caprices and hallucinations. Hence even when he departs from some external objective form or some tried convention, he still has a common measure of the extent of his deviation. While the determinism of the object, if one may coin a phrase, is more emphatic in the mechanical arts than in the humane ones, a binding thread runs through bodily realms. Coordinate with the intellectual assimilation of the machine by the technician and the artist, which came partly through habit, partly through workaday experience, and partly through the extension of systematic training in science, came the aesthetic and emotional apprehension of the new environment. Let us consider this in detail. 3. The aesthetic experience of the machine. The developed environment of the machine in the 20th century has its kinship with primitive approximations to this order in the castles and fortifications and bridges from the 11th to the 13th centuries, and even later, the bridge at Tournai or the brickwork and vaults of the Marienkirche at Liebeek. These earliest touches of the practical have the same fine characteristics that the latest grain elevators or steel cranes have. But the new characteristics now touch almost every department of experience. Observe the derricks, the ropes, the stanchions and ladders of a modern steamship, close at hand in the night, when the hard shadows mingle obliquely with the hard white shapes. Here is a new fact of aesthetic experience, and it must be transposed in the same hard way. To look for gradation and atmosphere here is to miss a fresh quality that has emerged through the use of mechanical forms and mechanical modes of lighting. Or stand on a deserted subway platform and contemplate the low cavity becoming a black disk into which, as the train rumbles toward the station, two green circles appear as pinpoints widening into plates. Or follow the spidery repetition of boundary lines, defining unoccupied cubes, which make the skeleton of a modern skyscraper, an effect not given even in wood before machine-sawed beams were possible. Or pass along the waterfront in Hamburg, say, and review the line of gigantic steel birds with spread legs that preside over the filling and emptying of the vessels in the basin, that span of legs, that long neck, the play of movement in this vast mechanism, the peculiar pleasure derived from the apparent lightness combined with enormous strength in its working, never existed on this scale in any other environment. Compared to these cranes, the pyramids of Egypt belong to the order of mud pies. Or put your eye at the eyepiece of a microscope, and focus the high-powered lens on a thread, a hair, a section of leaf, a drop of blood. Here is a world with forms and colors as varied and mysterious as those one finds in the depths of the sea. Or stand in a warehouse and observe a row of bathtubs, a row of siphons, a row of bottles, each of identical size, shape, color, stretching away for a quarter of a mile. The special visual effect of a repeating pattern, exhibited once in great temples or massed armies, is now a commonplace of the mechanical environment. There is an aesthetic of units and series, as well as an aesthetic of the unique and the non-repeatable. Absent from such experiences, for the most part, is the play of surfaces, the dance of subtle lights and shadows, the nuances of color, tones, atmosphere, the intricate harmonies that human bodies and specifically organic settings display, all the qualities that belong to the traditional levels of experience and to the unadhered world of nature. But face to face with these new machines and instruments, with their hard surfaces, their rigid volumes, their stark shapes, a fresh kind of perception and pleasure emerges. To interpret this order becomes one of the new tasks of the arts. While these new qualities existed as facts of mechanical industry, they were not generally recognized as values until they were interpreted by the painter and the sculptor, and so they existed in an indifferent anonymity for more than a century. The new forms were sometimes appreciated, perhaps, as symbols of progress, but art, as such, is valued for what it is, not for what it indicates, and the sort of attention needed for the appreciation of art was largely lacking in the industrial environment of the 19th century, and except for the work of an occasional engineer of great talent, like Eiffel, was looked upon with deep suspicion. At the very moment when the praise of industrialism was loudest and most confident, the environment of the machine was regarded as inherently ugly, so ugly that it mattered not how much additional ugliness was created by litter, refuse, slag piles, scrap metal, or removable dirt. Just as Watt's contemporaries demanded more noise in the steam engine, as a proclamation of power, so did the Paleotechnic mind glory, for the most part, in the anti-aesthetic quality of the machine. The Cubists were perhaps the first school to overcome this association of the ugly and the mechanical. They not merely held that beauty could be produced through the machine, they even pointed to the fact that it had been produced. The first expression of Cubism indeed dates back to the 17th century. Jean-Baptiste Braquel, in 1624, did a series of bizarre rise which depicted mechanical men, thoroughly Cubist in conception. This anticipated in art, as Glanville did in science, our later interests and inventions. What did the modern Cubists do? They extracted from the organic environment just those elements that could be stated in abstract geometrical symbols. They transposed and readjusted the contents of vision as freely as the inventor readjusted organic functions. They even created on canvas or in metal mechanical equivalents of organic objects, ledger-painted human figures that looked as if they had been turned in a lathe, and Duchanvillon modeled a horse as if it were a machine. This whole process of rational experiment in abstract mechanical forms was pushed further by the constructivists. Artists like Grabo and Moholy-Nagy put together pieces of abstract sculpture, composed of glass, metal plates, spiral springs, wood, which were the non-utilitarian equivalents of the apparatus that the physical scientist was using in his laboratory. They created in form the semblance of the mathematical equations and physical formulae that had produced our new environment, seeking in this new sculpture to observe the physical laws of equipoise or to evolve dynamic equivalents for the solid sculpture of the past by rotating a part of the object through space. The ultimate worth of such efforts did not perhaps lie in the art itself, for the original machines and instruments were often just as stimulating as their equivalents, and the new pieces of sculpture were just as limited as the machines. No, the worth of these efforts lay in the increased sensitiveness to the mechanical environment that was produced in those who understood and appreciated this art. The aesthetic experiment occupied a place comparable to the scientific experiment. It was an attempt to use a certain kind of physical apparatus for the purpose of isolating a phenomenon in experience and for determining the values of certain relations. The experiment was a guide to thought and an approach to action. Like the abstract paintings of Braque, Picasso, Leger, Kandinsky, these constructivist experiments sharpened the response to the machine as an aesthetic object. By analyzing, with the aid of simple constructions, the effects produced, they showed what to look for and what values to expect. Calculation, invention, mathematical organization played a special role in the new visual effects produced by the machine, while the constant lighting of the sculpture and the canvas, made possible by electricity, profoundly altered the visual relationship. By a process of abstraction, the new paintings finally, in some of the painters like Mondrian, approached a purely geometrical formula, with a mere residue of visual content. Perhaps the most complete as well as the most brilliant interpretations of the capacities of the machine was in the sculpture of Brancusi, for he exhibited both form, method, and symbol. In Brancusi's work one notes first of all the importance of the material, with its specific weight, shape, texture, color, finish. When he models in wood he still endeavors to keep the organic shape of the tree, emphasizing rather than reducing the part given by nature, whereas when he models in marble he brings out to the full the smooth satiny texture, in the smoothest and most egg-like of forms. The respect for material extends further into the conception of the subject treated. The individual is submerged, as in science, into the class. Instead of representing in marble the counterfeit head of a mother and child, he lays two blocks of marble side by side with only the faintest depression of surface to indicate the features of the face. It is by relations of volume that he presents the generic idea of mother and child, the idea in its most tenuous form. Again, in his famous bird, he treats the object itself, in the brass model, as if it were the piston of an engine. The tapering is as delicate, the polish is as high, as if it were to be fitted into the most intricate piece of machinery, in which so much as a few specks of dust would interfere with its perfect action. Looking at the bird, one thinks of the shell of a torpedo. As for the bird itself, it is no longer any particular bird, but a generic bird in its most bird-like aspect, the function of flight. So, too, with his metallic or marble fish, looking like experimental forms developed in an aviation laboratory, floating on the flawless surface of a mirror. Here is the equivalent in art of the mechanical world that lies about us on every hand, with this further perfection of the symbol, that in the highly polished metallic forms the world as a whole and the spectator himself, are likewise mirrored, so that the old separation between subject and object is now figuratively closed. The obtuse United States Customs officer who wished to classify Brancusi's sculpture as machinery or plumbing was in fact paying it a compliment. In Brancusi's sculpture the idea of the machine is objectified and assimilated in equivalent works of art. In this perception of the machine as a source of art, the new painters and sculptors clarified the whole issue and delivered art from the romantic prejudice against the machine as necessarily hostile to the world of feeling. At the same time, they began to interpret intuitively the new conceptions of time and space that distinguish the present age from the Renaissance. The course of this development can perhaps be followed best in the photograph and the motion picture, the specific arts of the machine. 4. Photography as means and symbol. The history of the camera, and of its product, the photograph, illustrates the typical dilemmas that have arisen in the development of the machine process and its application to objects of aesthetic value. Both the special feats of the machine and its possible perversions are equally manifest. At first, the limitations of the camera were a safeguard to its intelligent use. The photographer, still occupied with difficult photochemical and optical problems, did not attempt to extract from the photograph any other values than those rendered immediately by the technique itself, and as a result, the grave portraiture of some of the early photographers, particularly that of David Octavius Hill of Edinburgh, reached a high pitch of excellence. Indeed, it has not often been surpassed by any of the later work. As the technical problems were solved one by one, through the use of better lenses, more sensitive emulsions, new textures of paper to replace the shiny surface of the daguerreotype, the photographer became more conscious of the aesthetic arrangements of the subjects before him. Instead of carrying the aesthetic of the light picture further, he returned timidly to the canons of painting, and endeavored to make his pictures fit certain preconceptions of beauty as achieved by the classical painters. Far from glorying in minute and tangled representation of life, as the mechanical eye confronts it, the photographer from the 80s onward sought by means of soft lenses a foggy impressionism, or by care of arrangement and theatrical lighting he attempted to imitate the postures and sometimes the costumes of Holbein and Gainsborough. Some experimenters even went so far as to imitate in the photographic print the smudgy effect of charcoal or the crisp lines of the etching. This relapse from clean mechanical processes to an artful imitativeness worked ruin in photography for a full generation. It was like that relapse in the technique of furniture making which used modern machinery to imitate the dead forms of antique handicraft. In back of it was the failure to understand the intrinsic aesthetic importance of the new mechanical device in terms of its own peculiar possibilities. Every photograph, no matter how painstaking the observation of the photographer or how long the actual exposure, is essentially a snapshot. It is an attempt to penetrate and capture the unique aesthetic moment that singles itself out of the thousand of chance compositions, uncrystallized and insignificant, that occur in the course of a day. The photographer cannot rearrange his material on his own terms. He must take the world as he finds it. At most his rearrangement is limited to a change in position or an alteration of the direction and intensity of the light or in the length of the focus. He must respect and understand sunlight, atmosphere, the time of day, the season of the year, the capabilities of the machine, the processes of chemical development, for the mechanical device does not function automatically, and the results depend upon the exact correlation of the aesthetic moment itself with the appropriate physical means. But whereas an underlying technique conditions both painting and photography for the painter, too, must respect the chemical composition of his colors and the physical conditions which will give them permanence and visibility, photography differs from the other graphic arts in that the process is determined at every state by the external conditions that present themselves. His inner impulse, instead of spreading itself in subjective fantasy, must always be in key with outer circumstances. As for the various kinds of montage photography, they are in reality not photography at all but a kind of painting, in which the photograph is used as patches of textiles are used in crazy quilts to form a mosaic. Whatever value the montage may have derives from the painting rather than the camera. Rare though painting of the first order is, photography of the first rank is perhaps even rarer. The gamut of emotion and significance represented in photography by the work of Alfred Stieglitz in America is one that the photographer rarely spans. Half the merit of Stieglitz's work is due to his rigorous respect for the limitations of the machine and to the subtlety with which he effects the combination of image and paper. He plays no tricks, he has no affectations, not even the affectation of being hard-boiled, for life and the object have their soft moments and their tender aspects. The mission of the photograph is to clarify the object. This objectification, this clarification, are important developments in the mind itself. It is perhaps the prime psychological fact that emerges with our rational assimilation of the machine. To see as they are, as if for the first time, a boatload of immigrants, a tree in Madison Square Park, a woman's breast, a cloud lowering over a black mountain that requires patience and understanding. Ordinarily we skip over and schematize these objects, relate them to some practical need, or subordinate them to some immediate wish. Photography gives us the ability to recognize them in the independent form created by light and shade and shadow. Good photography, then, is one of the best educations toward a rounded sense of reality. Restoring to the eye, otherwise so preoccupied with the abstractions of print, the stimulus of things roundly seen as things, shapes, colors, textures, demanding for its enjoyment a previous experience of light and shade, this machine process in itself counteracts some of the worst defects of our mechanical environment. It is the hopeful antithesis to an emasculated and segregated aesthetic sensibility, the cult of pure form, which endeavors to hide away from the world that ultimately gives shape and significance to its remotest symbols. If photography has become popular again in our own day, after its first great but somewhat sentimental outburst in the 80s, it is perhaps because, like an invalid returning to health, we are finding a new delight in being, seeing, touching, feeling, because in a rural or a neotechnic environment the sunlight and pure air that make it possible are present, because, too, we have at least learned Whitman's lesson and behold with a new respect the miracle of our finger joints or the reality of a blade of grass. Photography is not least effective when it is dealing with such ultimate simplicities. To disdain photography because it cannot achieve what El Greco or Rembrandt or Tintoretto achieved is like dismissing science because its view of the world is not comparable to the visions of Plotinus or the mythologies of Hinduism. Its virtue lies precisely in the fact that it has conquered another and quite different department of reality. For photography, finally, gives the effect of permanence to the transient and the ephemeral. Photography and perhaps photography alone is capable of coping with and adequately presenting the complicated, interrelated aspects of our modern environment. As histories of the human comedy of our times, the photographs of it Get in Paris and of Stieglitz in New York are unique both as drama and as document. Not merely do they convey to us the very shape and touch of this environment, but by the angle of vision and the moment of observation throw an oblique light upon our inner lives, our hopes, our values, our humors. And this art, of all our arts, is perhaps the most widely used and the most fully. 12. Nature and the Machine. 1. Röntgen photograph of Nautilus by J.B. Pollock. 2. Section of modern hydroturbine, spiral form Nature's use of the spiral in construction. The X-ray, Tate by mechanical necessity. Geometrical forms, like the microscope, reveals a new aesthetic world. Simple and complex, are orchestrated in machine eye courtesy of Wendingen, design. 3. Grandstand of new stadium in Florence, Pier 4, R. du Chanvillon's interpretation of the organic Luigi Nervi, architect. Engineering in which imago form of a horse in terms of the machine, nation, and necessity are harmoniously composed. Courtesy of Walter Pack. 13. Aesthetic assimilation. 1. Sculpture by Constantine Brancusi. Abstraction, respect for materials, importance of fine measurements and delicate modulations, impersonality. See Plate 15, Number 2. Courtesy of Marcel Duchamp. 3. Modern grain elevator. Aesthetic effect derived from simplicity, essentiality, repetition of elementary forms, heightened by colossal scale. See worrying or suggestive essay on Egypt and America. Courtesy of Eric Mendelsohn. 2. The Steel Workers, mural by Thomas H. Benton. Realization of the dramatic element in modern industry, and the daily heroism which often outvies that of the battlefield. Courtesy of the New School for Social Research. 4. Breakfast Table by Ferdinand Ledger. Transposition of the organic and the living into terms of the mechanical, dismemberment of natural forms and graphic reinvention. Private collection, courtesy of the Museum of Modern Art. Enjoyed, the amateur, the specialist, the news photographer, and the common man have all participated in this eye-opening experience, and in this discovery of that aesthetic moment which is the common property of all experience, at all its various levels from ungoverned dream to brute action and rational idea. What has been said of the photograph applies even more, perhaps, to the motion picture. In its first exploitation the motion picture emphasized its unique quality, the possibility of abstracting and reproducing objects in motion, the simple races and chases of the early pictures pointed the art in the right direction. But in its subsequent commercial development it was degraded a little by the attempt to make it the vehicle of a short story or a novel or a drama, a mere imitation in vision of entirely different arts. So one must distinguish between the motion picture as an indifferent reproductive device, less satisfactory in most ways than direct production on the stage, and the motion picture as an art in its own right. The great achievements of the motion picture have been in the presentation of history or natural history, the sequences of actuality, or in their interpretation of the inner realm of fantasy, as in the pure comedies of Charlie Chaplin and René Clair and Walt Disney. Unlike the photograph, the extremes of subjectivism and of factualism meet in the motion picture. Nanook of the North, Chang, the SS. Potemkin. These pictures got their dramatic effect through their interpretation of an immediate experience and through a heightened delight in actuality. Their exoticism was entirely accidental. An equally good eye would abstract the same order of significant events from the day's routine of a subway guard or a factory hand. Indeed, the most consistently interesting pictures have been those of the newsreel despite the insufferable banality of the announcers who too often accompany them. Not plot in the old dramatic sense, but historic and geographic sequences is the key to the arrangement of these new kinetic compositions, the passage of objects, organisms, dream images through time and space. It is an unfortunate social accident, as has happened in so many departments of technics, that this art should have been grossly diverted from its proper function by the commercial necessity for creating sentimental shows for an emotionally empty metropolitanized population, living vicariously on the kisses and cocktails and crimes and orgies and murders of their shadow idols. For the motion picture symbolizes and expresses, better than do any of the traditional arts, our modern world picture and the essential conceptions of time and space which are already part of the unformulated experience of millions of people, to whom Einstein or Bohr or Bergson or Alexander are scarcely even names. In Gothic painting one may recall time and space were successive and unrelated, the immediate and eternal, the near and the far, were confused. The faithful time ordering of the medieval chroniclers is marred by the jumble of events presented and by the impossibility of distinguishing hearsay from observation and fact from conjecture. In the Renaissance space and time were coordinated within a single system, but the axis of these events remained fixed, so to say, within a single frame established at a set distance from the observer, whose existence with reference to the system was innocently taken for granted. Today, in the motion picture, which symbolizes our actual perceptions and feelings, time and space are not merely coordinated on their own axis, but in relation to an observer who himself, by his position, partly determines the picture, and who is no longer fixed but is likewise capable of motion. The moving picture, with its close-ups and its synoptic views, with its shifting events and its ever-present camera eye, with its spatial forms always shown through time, with its capacity for representing objects that interpenetrate, and for placing distant environments in immediate juxtaposition as happens in instantaneous communication, with its ability, finally, to represent subjective elements, distortions, hallucinations, it is today the only art that can represent with any degree of concreteness the emergent worldview that differentiates our culture from every preceding one. Even with weak and trivial subjects, the art focuses interests and captures values that the traditional arts leave untouched. Music alone heretofore has represented movement through time, but the motion picture synthesizes movement through both time and space, and in the very fact that it can coordinate visual images with sound and release both of these elements from the boundaries of apparent space and a fixed location, it contributes something to our picture of the world not given completely in direct experience. Utilizing our daily experience of motion in the railroad train and the motor car, the motion picture recreates in symbolic form a world that is otherwise beyond our direct perception or grasp. Without any conscious notion of its destination, the motion picture presents us with a world of interpenetrating, counter-influencing organisms, and it enables us to think about that world with a greater degree of concreteness. This is no small triumph in cultural assimilation. Though it has been so stupidly misused, the motion picture nevertheless announces itself as a major art of the neotechnic phase. Through the machine, we have new possibilities of understanding the world we have helped to create. But in the arts, it is plain that the machine is an instrument with manifold and conflicting possibilities. It may be used as a passive substitute for experience, it may be used to counterfeit older forms of art, it may also be used, in its own right, to concentrate and intensify and express new forms of experience. As substitutes for primary experience, the machine is worthless, indeed it is actually debilitating. Just as the microscope is useless unless the eye itself is keen, so all our mechanical apparatus in the arts depends for its success upon the due cultivation of the organic, physiological, and spiritual aptitudes that lie behind its use. The machine cannot be used as a shortcut to escape the necessity for organic experience. Mr. Waldo Frank has put the matter well. Art, he says, cannot become a language, hence an experience, unless it is practiced. To the man who plays, a mechanical reproduction of music may mean much, since he already has the experience to assimilate. But where reproduction becomes the norm, the few music makers will grow more isolate and sterile, and the ability to experience music will disappear. The same is true with the cinema, dance, and even sport. Whereas in industry the machine may properly replace the human being when he has been reduced to an automaton, in the arts the machine can only extend and deepen man's original functions and intuitions. In so far as the phonograph and the radio do away with the impulse to sing, in so far as the camera does away with the impulse to see, in so far as the automobile does away with the impulse to walk, the machine leads to a lapse of function which is but one step away from paralysis. But in the application of mechanical instruments to the arts it is not the machine itself that we must fear. The chief danger lies in the failure to integrate the arts themselves with the totality of our life experience. The perverse triumph of the machine follows automatically from the abdication of the spirit. Consciously to assimilate the machine is one means of reducing its omnipotence. We cannot, as Karl Buescher wisely said, give up the hope that it will be possible to unite technics and art in a higher rhythmical unity, which will restore to the spirit the fortunate serenity and to the body the harmonious cultivation that manifest themselves at their best among primitive peoples. The machine has not destroyed that promise. On the contrary, through the more conscious cultivation of the machine arts and through greater selectivity in their use, one sees the pledge of its wider fulfillment throughout civilization. For at the bottom of that cultivation there must be the direct and immediate experience of living itself. We must directly see, feel, touch, manipulate, sing, dance, communicate before we can extract from the machine any further sustenance for life. If we are empty to begin with, the machine will only leave us emptier. If we are passive and powerless to begin with, the machine will only leave us more feeble. 5. The growth of functionalism. But modern technics, even apart from the special arts that it fostered, had a cultural contribution to make in its own right. Just as science underlined the respect for fact, so technics emphasized the importance of function. In this domain, as Emerson pointed out, the beautiful rests on the foundations of the necessary. The nature of this contribution can best be shown, perhaps, by describing the way in which the problem of machine design was first faced, then evaded, and finally solved. One of the first products of the machine was the machine itself. As in the organization of the first factories, the narrowly practical considerations were uppermost, and all the other needs of the personality were firmly shoved to one side. The machine was a direct expression of its own functions. The first cannon, the first crossbows, the first steam engines were all nakedly built for action. But once the primary problems of organization and operation had been solved, the human factor, which had been left out of the picture, needed somehow to be reincorporated. The only precedent for this fuller integration of form came naturally from handicraft, hence over the incomplete, only partly realized forms of the early cannon, the early bridges, the early machines, a meretricious touch of decoration was added, a mere relic of the happy, semi-magical fantasies that painting and carving had once added to every handicraft object. Because perhaps the energies of the Technic period were so completely engrossed in the technical problems, it was, from the standpoint of design, amazingly clean and direct. Ornament flourished in the utilities of life, flourished often perversely and extravagantly, but one looks for it in vain among the machines pictured by Agricola or Besson or the Italian engineers. They are as direct and factual as was architecture from the 10th to the 13th century. The worst sinners, that is the most obvious sentimentalists, were the engineers of the Paleotechnic period. In the act of recklessly deflowering the environment at large, they sought to expiate their failures by adding a few sprigs or posies to the new engines they were creating. They embellished their steam engines with Doric columns or partly concealed them behind Gothic tracery. They decorated the frames of their presses and their automatic machines with cast iron arabesque. They punched ornamental holes in the iron framework of their new structures, from the trusses of the old wing of the Metropolitan Museum to the base of the Eiffel Tower in Paris. Everywhere similar habits prevailed, the homage of hypocrisy to art. One notes identical efforts on the original steam radiators, in the floral decorations that once graced typewriters, in the nondescript ornament that still lingers quaintly on shotguns and sewing machines, even if it has at length disappeared from cash registers and Pullman cars as long before. In the first uncertainties of the new technics, the same division had appeared in armor and in crossbows. Schley's second stage in machine design was a compromise. The object was divided into two parts. One of them was to be precisely designed for mechanical efficiency. The other was to be designed for looks. While the utilitarian claimed the working parts of the structure, the aesthete was, so to speak, permitted slightly to modify the surfaces with his unimportant patterns, his plutonic flowers, his aimless filigree, provided he did not seriously weaken the structure or condemn the function to inefficiency. Mechanically utilizing the machine, this type of design shamefully attempted to conceal the origins that were still felt as low and mean. The engineer had the uneasiness of a parvenu, and the same impulse to imitate the most archaic patterns of his betters. Naturally, the next stage was soon reached. The utilitarian and the aesthete withdrew again to their respective fields. The aesthete, insisting with justice that the structure was integral with the decoration and that art was something more fundamental than the icing the pastry cook put on the cake, sought to make the old decoration real by altering the nature of the structure. Taking his place as workman, he began to revive the purely handicraft methods of the weaver, the cabinet maker, the printer, arts that had survived for the most part only in the more backward parts of the world, untouched by the tourist and the commercial traveler. The old workshops and ateliers were languishing and dying out in the 19th century, especially in progressive England and in America, when new ones, like those devoted to glass under William de Morgan in England, and John Lafarge in America, and Lalique in France, or to a miscellany of handicrafts, such as that of William Morris in England, sprang into existence, to prove by their example that the arts of the past could survive. The industrial manufacturer, isolated from this movement yet affected by it, contemptuous but half convinced, made an effort to retrieve his position by attempting to copy mechanically the dead forms of art he found in the museum. So far from gaining from the handicrafts movement by this procedure, he lost what little virtue his untutored designs possessed, issuing as they sometimes did out of an intimate knowledge of the processes and the materials. The weakness of the original handicrafts movement was that it assumed that the only important change in industry had been the intrusion of the soulless machine. Whereas the fact was that everything had changed, and all the shapes and patterns employed by technics were therefore bound to change, too. The world men carried in their heads, their idolum, was entirely different from that which set the medieval mason to carving the history of creation or the lives of the saints above the portals of the cathedral, or a jolly image of some sort above his own doorway. An art based like handicraft upon a certain stratification of the classes and the social differentiation of the arts could not survive in a world where men had seen the French Revolution and had been promised some rough share of equality. Modern handicraft, which sought to rescue the worker from the slavery of shoddy machine production, merely enabled the well-to-do to enjoy new objects that were as completely divorced from the dominant social milieu as the palaces and monasteries that the antiquarian art dealer and collector had begun to loot. The educational aim of the arts and crafts movement was admirable, and, in so far as it gave courage and understanding to the amateur, it was a success. If this movement did not add a sufficient amount of good handicraft, it at least took away a great deal of false art. William Morris's dictum, that one should not possess anything one did not believe to be beautiful or know to be useful, was, in the shallow showy bourgeois world he addressed, a revolutionary dictum. But the social outcome of the arts and crafts movement was not commensurate with the needs of the new situation, as Mr. Frank Lloyd Wright pointed out in his memorable speech at Hull House in 1908, the machine itself was as much an instrument of art, in the hands of an artist, as were the simple tools and utensils. To erect a social barrier between machines and tools was really to accept the false notion of the new industrialist who, bent on exploiting the machine, which they owned, and jealous of the tool, which might still be owned by the independent worker, bestowed on the machine an exclusive sanctity and grace it did not merit. Lacking the courage to use the machine as an instrument of creative purpose, and being unable to attune themselves to new objectives and new standards, the aesthetes were logically compelled to restore a medieval ideology in order to provide a social backing for their anti-machine bias. In a word, the arts and crafts movement did not grasp the fact that the new technics, by expanding the role of the machine, had altered the entire relation of handwork to production, and that the exact processes of the machine were not necessarily hostile to handicraft and fine workmanship. In its modern form, handicraft could no longer serve as in the past when it had worked under the form of an intensive caste specialization. To survive, handicraft would have to adapt itself to the amateur, and it was bound to call into existence, even in pure handwork, those forms of economy and simplicity which the machine was claiming for its %VN, and to which it was adapting mind and hand and eye. In this process of reintegration certain eternal forms would be recovered. There are handicraft forms dating back to a distant past which so completely fulfill their functions that no amount of further calculation or experiment will alter them for the better. These type forms appear and reappear from civilization to civilization, and if they had not been discovered by handicraft, the machine would have had to invent them. The new handicraft was in fact to receive presently a powerful lesson from the machine. For the forms created by the machine, when they no longer sought to imitate old superficial patterns of handwork, were closer to those that could be produced by the amateur than were, for example, the intricacies of special joints, fine inlays, matched woods, beads, and carvings, complicated forms of metallic ornament, the boast of handicraft in the past. While in the factory the machine was often reduced to producing fake handicraft, in the workshop of the amateur the reverse process could take place with a real gain. He was liberated by the very simplicities of good machine forms. Machine technique as a means to achieving a simplified and purified form relieved the amateur from the need of respecting and imitating the perversely complicated patterns of past patterns whose complications were partly the result of conspicuous waste, partly the outcome of technical virtuosity, and partly the result of a different state of feeling. But before handicraft could thus be restored as an admirable form of play and an efficacious relief from a physically untutored life, it was necessary to dispose of the machine itself as a social and aesthetic instrument. So the major contribution to art was made, after all, by the industrialist who remained on the job and saw it through. With the third stage in machine design an alteration takes place. The imagination is not applied to the mechanical object after the practical design has been completed, it is infused into it at every stage in development. The mind works through the medium of the machine directly, respects the conditions imposed upon it, and not content with a crude quantitative approximation seeks out a more positive aesthetic fulfillment. This must not be confused with the dogma, so often current, that any mechanical contraption that works necessarily is aesthetically interesting. The source of this fallacy is plain. In many cases, indeed, our eyes have been trained to recognize beauty in nature, and with certain kinds of animals and birds we have an especial sympathy. When an airplane becomes like a gull it has the advantage of this long association and we properly couple the beauty with the mechanical adequacy, since the poise and swoop of a gull's flight casts in addition a reflective beauty on its animal structure. Having no such association with a milkweed seed, we do not feel the same beauty in the autogyro, which is kept aloft by a similar principle. While genuine beauty in a thing of use must always be joined to mechanical adequacy and therefore involves a certain amount of intellectual recognition and appraisal, the relation is not a simple one, it points to a common source rather than an identity. In the conception of a machine or of a product of the machine there is a point where one may leave off for parsimonious reasons without having reached aesthetic perfection. At this point perhaps every mechanical factor is accounted for, and the sense of incompleteness is due to the failure to recognize the claims of the human agent. Aesthetics carries with it the implication of alternatives between a number of mechanical solutions of equal validity, and unless this awareness is present at every stage of the process, in smaller matters of finish, fineness, trimness, it is not likely to come out with any success in the final stage of design. Form follows function, underlining it, crystallizing it, clarifying it, making it real to the eye. Makeshifts and approximations express themselves in incomplete forms, forms like the absurdly cumbrous and ill-adjusted telephone apparatus of the past, like the old-fashioned airplane, full of struts, wires, extra supports, all testifying to an anxiety to cover innumerable unknown or uncertain factors, forms like the old automobile in which part after part had been added to the effective mechanism without having been absorbed into the body of the design as a whole, forms like our oversized steelwork which were due to our carelessness in using cheap materials and our desire to avoid the extra expense of calculating them finely and expending the necessary labor to work them up. The impulse that creates a complete mechanical object is akin to that which creates an aesthetically finished object, and the fusion of the two at every stage in the process will necessarily be affected by the environment at large. Who can gauge how much the slatternliness and disorder of the Paleotechnic environment undermined good design, or how much the order and beauty of our Neotechnic plants carrot like that of the Van Nelly factory in Rotterdam will eventually aid it? Aesthetic interests cannot suddenly be introduced from without, they must be constantly operative, constantly visible. Expression through the machine implies the recognition of relatively new aesthetic terms, precision, calculation, flawlessness, simplicity, economy. Feeling attaches itself in these new forms to different qualities than those that made handicraft so entertaining. Success here consists in the elimination of non-essential, rather than, as in handicraft decoration, in the willing production of superfluity, contributed by the worker out of his own delight in the work. The elegance of a mathematical equation, the inevitability of a series of physical interrelations, the naked quality of the material itself, the tight logic of the whole carrot, these are the ingredients that go into the design of machines, and they go equally into products that have been properly designed for machine production. In handicraft it is the worker who is represented, in machine design it is the work. In handicraft, the personal touch is emphasized, and the imprint of the worker and his tool are both inevitable. In machine work the impersonal prevails, and if the worker leaves any telltale evidence of his part in the operation, it is a defect or a flaw. Hence the burden of machine design is in the making of the original pattern. It is here that trials are made, that errors are discovered and buried, that the creative process as a whole is concentrated. Once the master pattern is set, the rest is routine. Beyond the designing room and the laboratory there is for goods produced on a serial basis for a mass market no opportunity for choice and personal achievement. Hence apart from those commodities that can be produced automatically, the effort of sound industrial production must be to increase the province of the designing room and the laboratory, reducing the scale of the production, and making possible an easier passage back and forth between the designing and the operative sections of the plant. Who discovered these new canons of machine design? Many an engineer and many a machine worker must have mutely sensed them and reached toward them. Indeed, one sees the beginning of them in very early mechanical instruments. But only after centuries of more or less blind and unformulated effort were these canons finally demonstrated with a certain degree of completeness in the work of the great engineers toward the end of the 19th century, particularly the Roeblings in America and Eiffel in France, and formulated after that by theoreticians like Riedler and Meyer in Germany. The popularization of the new aesthetic awaited, as I have pointed out, the post-impressionist painters. They contributed by breaking away from the values of purely associative art and by abolishing an undue concern for natural objects as the basis of the painter's interest. If on one side this led to completer subjectivism, on the other it tended toward a recognition of the machine as both form and symbol. In the same direction Marcel Duchamp, for example, who was one of the leaders of this movement, made a collection of cheap, ready-made articles, produced by the machine, and called attention to their aesthetic soundness and sufficiency. In many cases, the finest designs had been achieved before any conscious recognition of the aesthetic had taken place. With the coming of a commercialized designer, seeking to add art to a product which was art, IHE design has more often than not been trifled with and spoiled. The studious botching of the Kodak, the bathroom fixture, and the steam radiator under such stylicizing is a current commonplace. The key to this fresh appreciation of the machine as a source of new aesthetic forms has come through a formulation of its chief aesthetic principle, the principle of economy. This principle is of course not unknown in other phases of art, but the point is that in mechanical forms it is at all times a controlling one, and it has for its aid the more exact calculations and measurements that are now possible. The aim of sound design is to remove from the object, be it an automobile or a set of china or a room, every detail, every molding, every variation of the surface, every extra part except that which conduces to its effective functioning. Toward the working out of this principle, our mechanical habits and our unconscious impulses have been tending steadily. In departments where aesthetic choices are not consciously uppermost, our taste has often been excellent and sure. Le Corbusier has been very ingenious in picking out manifold objects, varied from observation by their very ubiquity, in which this mechanical excellence of form has manifested itself without pretense or fumbling. Take the smoking pipe. It is no longer carved to look like a human head, nor does it bear, except among college students, any heraldic emblems. It has become exquisitely anonymous, being nothing more than an apparatus for supplying draughts of smoke to the human mouth from a slow-burning mass of vegetation. Take the ordinary drinking glass in a cheap restaurant. It is no longer cut or cast or engraved with special designs. At most it may have a slight bulge near the top to keep one glass from sticking to another in stacking. It is as clean, as functional, as a high-tension insulator. Or take the present watch and its case and compare it with the forms that handicraft ingenuity and taste and association created in the 16th or 17th centuries. In all the commoner objects of our environment the machine canons are instinctively accepted. Even the most sentimental manufacturer of motor cars has not been tempted to paint his coachwork to resemble a sedan chair in the style of Watteau, although he may live in a house in which the furniture and decoration are treated in that perverse fashion. This stripping down to essentials has gone on in every department of machine work and has touched every aspect of life. It is a first step toward that completer integration of the machine with human needs and desires which is the mark of the neotechnic phase, and will be even more the mark of the biotechnic period, already visible over the edge of the horizon. As in the social transition from the paleotechnic to the neotechnic order, the chief obstacle to the fuller development of the machine lies in the association of taste and fashion with waste and commercial profiteering. For the rational development of genuine technical standards, based on function and performance, can come about only by a wholesale devaluation of the scheme of bourgeois civilization upon which our present system of production is based. Capitalism, which along with war played such a stimulating part in the development of technics, now remains with war the chief obstacle toward its further improvement. The reason should be plain. The machine devaluates rarity. Instead of producing a single unique object, it is capable of producing a million others just as good as the master model from which the rest are made. The machine devaluates age, for age is another token of rarity, and the machine, by placing its emphasis upon fitness and adaptation, prides itself on the brand new rather than on the antique. Instead of feeling comfortably authentic in the midst of rust, dust, cobwebs, shaky parts, it prides itself on the opposite quality: slickness, smoothness, gloss, cleanness. The machine devaluates archaic taste, for taste in the bourgeois sense is merely another name for pecuniary reputability, and against that standard the machine sets up the standards of function and fitness. The newest, the cheapest, the commonest objects may, from the standpoint of pure aesthetics, be immensely superior to the rarest, the most expensive, and the most antique. To say all this is merely to emphasize that the modern technics, by its own essential nature, imposes a great purification of aesthetics, that is, it strips off from the object all the barnacles of association, all the sentimental and pecuniary values which have nothing whatever to do with aesthetic form, and it focuses attention upon the object itself. The social devaluation of caste, enforced by the proper use and appreciation of the machine, is as important as the stripping down of essential forms in the process itself. One of the happiest signs of this during the last decade was the use of cheap and common materials in jewelry, first introduced, I believe, by Lalique, for this implied a recognition of the fact that an aesthetically appropriate form, even in the adornment of the body, has nothing to do with rarity or expense, but is a matter of color, shape, line, texture, fitness, symbol. The use of cheap cottons in dress by Chanel and her imitators, which was another post-war phenomenon, was an equally happy recognition of the essential values in our new economy. It at last put our civilization, if only momentarily, on the level of those primitive cultures which gladly bartered their furs and ivory for the white man's colored glass beads, by the adroit use of which the savage artist often proved to any disinterested observer that they contrary to the white man's fatuous conceit had gotten the better of the bargain. Because of the fact that woman's dress has a peculiarly compensatory role to play in our megalopolitan society, so that it more readily indicates what is absent than calls attention to what is present in it, the victory for genuine aesthetics could only be a temporary one. But these forms of dress and jewelry pointed to the goal of machine production, the goal at which each object would be valued in terms of its direct mechanical and vital and social function, apart from its pecuniary status, the snobberies of caste, or the dead sentiments of historical emulation. This warfare between a sound machine aesthetic and what Veblen has called the requirements of pecuniary reputability has still another side. Our modern technology has, in its inner organization, produced a collective economy, and its typical products are collective products. Whatever the politics of a country may be, the machine is a communist, hence the deep contradictions and conflicts that have kept on developing in machine industry since the end of the 18th century. At every stage in Technics, the work represents a collaboration of innumerable workers, themselves utilizing a large and ramifying technological heritage. The most ingenious inventor, the most brilliant individual scientist, the most skilled designer contributes but a moiety to the final result. And the product itself necessarily bears the same impersonal imprint. It either functions or it does not function on quite impersonal lines. There can be no qualitative difference between a poor man's electric bulb of a given candle power and a rich man's, to indicate their differing pecuniary status in society, although there was an enormous difference between the rush or stinking tallow of the peasant and the wax candles or sperm oil used by the upper classes before the coming of gas and electricity. In so far as pecuniary differences are permitted to count in the machine economy, they can alter only the scale of things, not, in terms of present production, the kind. What applies to electric light bulbs applies to automobiles, what applies there applies equally to every manner of apparatus or utility. The frantic attempts that have been made in America by advertising agencies and designers to stylicize machine-made objects have been, for the most part, attempts to pervert the machine process in the interests of caste and pecuniary distinction. In money-ridden societies, where men play with poker chips instead of with economic and aesthetic realities, every attempt is made to disguise the fact that the machine has achieved potentially a new collective economy, in which the possession of goods is a meaningless distinction, since the machine can produce all our essential goods in unparalleled qualities, falling on the just and the unjust, the foolish and the wise, like the rain itself. The conclusion is obvious: we cannot intelligently accept the practical benefits of the machine without accepting its moral imperatives and its aesthetic forms. Otherwise both ourselves and our society will be the victims of a shattering disunity, and one set of purposes, that which created the order of the machine, will be constantly at war with trivial and inferior personal impulses bent on working out in covert ways our psychological weaknesses. Lacking on the whole this rational acceptance, we have lost a good part of the practical benefits of the machine and have achieved aesthetic expression only in a spotty, indecisive way. The real social distinction of modern technics, however, is that it tends to eliminate social distinctions. Its immediate goal is effective work. Its means are standardization, the emphasis of the generic and the typical, in short, conspicuous economy. Its ultimate aim is leisure, that is, release of other organic capacities. The powerful aesthetic side of this social process has been obscured by speciously pragmatic and pecuniary interests that have inserted themselves into our technology and have imposed themselves upon its legitimate aims. But in spite of this deflection of effort, we have at last begun to realize these new values, these new forms, these new modes of expression. Here is a new environment, man's extension of nature in terms discovered by the close observation and analysis and abstraction of nature. The elements of this environment are hard and crisp and clear: the steel bridge, the concrete road, the turbine and the alternator, the glass wall. Behind the facade are rows and rows of machines, weaving cotton, transporting coal, assembling food, printing books, machines with steel fingers and lean muscular arms, with perfect reflexes, sometimes even with electric eyes. Alongside them are the new utilities: the coke oven, the transformer, the dye vats, chemically cooperating with these mechanical processes, assembling new qualities in chemical compounds and materials. Every effective part in this whole environment represents an effort of the collective mind to widen the province of order and control and provision. And here, finally, the perfected forms begin to hold human interest even apart from their practical performances. They tend to produce that inner composure and equilibrium, that sense of balance between the inner impulse and the outer environment, which is one of the marks of a work of art. The machines, even when they are not works of art, underlie our art, that is, our organized perceptions and feelings in the way that nature underlies them, extending the basis upon which we operate and confirming our own impulse to order. The economic, the objective, the collective, and finally the integration of these principles in a new conception of the organic, these are the marks, already discernible, of our assimilation of the machine, not merely as an instrument of practical action but as a valuable mode of life. 6. The simplification of the environment. As a practical instrument, the machine has enormously complicated the environment. When one compares the shell of an 18th-century house with the tangle of water pipes, gas pipes, electric wires, sewers, aerials, ventilators, heating and cooling systems that compose a modern house, or when one compares the cobblestones of the old-fashioned street, set directly on the earth, with the cave of cables, pipes, and subway systems that run under the asphalt, one has no doubt about the mechanical intricacy of modern existence. But precisely because there are so many physical organs, and because so many parts of our environment compete constantly for our attention, we need to guard ourselves against the fatigue of dealing with too many objects or being stimulated unnecessarily by their presence, as we perform the numerous offices they impose. Hence a simplification of the externals of the mechanical world is almost a prerequisite for dealing with its internal complications. To reduce the constant succession of stimuli, the environment itself must be made as neutral as possible. This, again, is partly in opposition to the principle of many handicraft arts, where the effort is to hold the eye, to give the mind something to play with, to claim a special attention for itself. So that if the canon of economy and the respect for function were not rooted in modern techniques, it would have to be derived from our psychological reaction to the machine. Only by aesthetically observing these principles can the chaos of stimuli be reduced to the point of effective assimilation. Without standardization, without repetition, without the neutralizing effect of habit, our mechanical environment might well, by reason of its tempo and its continuous impact, be too formidable. In departments which have not been sufficiently simplified, it exceeds the limit of toleration. The machine has thus, in its aesthetic manifestations, something of the same effect that a conventional code of manners has in social intercourse. It removes the strain of contact and adjustment. The standardization of manners is a psychological shock absorber. It permits intercourse between persons and groups to take place without the preliminary exploration and understanding that are requisite for an ultimate adjustment. In the province of aesthetics, this simplification has still a further use. It gives small deviations and variations from the prevalent norm the psychological refreshment that would go only with much larger changes under a condition where variation was the expected mode and standardization was the exception. Mr. A. N. Whitehead has pointed out that one of our chief literary sins is in thinking of past and future in terms of 1,000 years forward and backward, when really to experience the organic nature of past and future one should think of time in the order of a second, or a fraction of a second. One can make a similar remark about our aesthetic perceptions. Those who complain about the standardization of the machine are used to thinking of variations in terms of gross changes in pattern and structure, such as those that take place between totally different cultures or generations, whereas one of the signs of a rational enjoyment of the machine and the machine-made environment is to be concerned with much smaller differences and to react sensitively to them. To feel the difference between two elemental types of window, with a slightly different ratio in the division of lights, rather than to feel it only when one of them is in a steel frame and the other is surmounted by a broken pediment, is the mark of a fine aesthetic consciousness in our emerging culture. Good craftsmen have always had some of this finer sense of form, but it was confused by the snobbish taste and arbitrary literary standards of form that came into court life during the Renaissance. As the various parts of our environment become more standardized, the senses must in turn become more acute, more refined. A hair's breadth, a speck of dirt, a faint wave in the surface will distress us as much as the P. Hurt Hans Andersen's princess, and similarly pleasure will derive from delicacies of adaptation to which most of us are now indifferent. Standardization, which economizes our attention when our minds have other work to do, serves as the substratum in those departments where we deliberately seek aesthetic satisfaction. In creating the machine, we have set before ourselves a positively inhuman standard of perfection. No matter what the occasion, the criterion of successful mechanical form is that it should look as if no human hand had touched it. In that effort, in that boast, in that achievement the human hand shows itself, perhaps, in its most cunning manifestation. And yet ultimately it is to the human organism that we must return to achieve the final touch of perfection. The finest reproduction still lacks something that the original picture possessed. The finest porcelain produced with the aid of every mechanical accessory lacks the perfection of the great Chinese potters. The finest mechanical printing lacks that complete union of black and white that hand printing produces with its slower method and its dampened paper. Very frequently, in machine work, the best structure is forfeited to the mere conveniences of production. Given equally high standards of performance, the machine can often no more than hold its own in competition with the hand product. The pinnacles of handicraft art set a standard that the machine must constantly hold before it, but against this one must recognize that in 100 departments examples of supreme skill and refinement have, thanks to the machine, become a commonplace. And at all levels, this aesthetic refinement spreads out into life. It appears in surgery and dentistry as well as in the design of houses and bridges and high-tension power lines. The direct effect of these techniques upon the designers, workers, and manipulators cannot be overestimated. Whatever the tags, archaicisms, verbalisms, emotional and intellectual mischiefs of our regnant system of education, the machine itself as a constant educator cannot be neglected. If during the Paleotechnic period the machine accentuated the brutality of the mind, in the Neotechnic phase it promises, if we use it intelligently, to restore the delicacy and sensitivity of the organism. 7. The objective personality. Granting these new instruments, this new environment, these new perceptions and sensations and standards, this new daily routine, these new aesthetic responses, what sort of man comes out of modern technics? Le Play once asked his auditors what was the most important thing that came out of the mine, and after one had guessed coal and another iron and another gold, He answered, "No, the most important thing that comes out of the mine is the miner." That is true for every occupation. And today every type of work has been affected by the machine. I have already discussed, in terms of their limitations and renunciations, the type of man that influenced modern mechanization, the monk, the soldier, the miner, the financier. But the fuller experience of the machine does not necessarily tend to produce a repetition of these original patterns, although there is plenty of evidence to show that the soldier and the financier occupy a larger position in our world today than at perhaps any other time in the past. In the act of expressing themselves with the aid of the machine, the capacities of these original types have been modified and their character altered. Moreover, what was once the innovation of a daring race of pioneers has now become the settled routine of a vast mass of people who have taken over the habits without having shared any of the original enthusiasm, and many of the latter still perhaps have no special bent toward the machine. It is difficult to analyze out such a pervasive influence as this. No single cause is at work, no single reaction can be attributed solely to the machine. And we who live in this medium, and who have been formed by it, who constantly breathe it and adapt ourselves to it, cannot possibly measure the deflection caused by the medium, still less estimate the drift of the machine, and all it carries with it, from other norms. The only partial corrective is to examine a more primitive environment, as Mr. Stuart Chase attempted to do, but even here one cannot correct for the way in which our very questions and our scale of values have been altered by our traffic with the machine. But between the personality that was most effective in the technically immature environment of the 10th century and the type that is effective today, one may say that the first was subjectively conditioned, and that the second is more directly influenced by objective situations. These, at all events, seem to be the tendencies. In both types of personality there was an external standard of reference, but whereas the medieval man determined reality by the extent to which it agreed with the complicated tissue of beliefs, in the case of modern man the final arbiter of judgment is always a set of facts, recourse to which is equally open and equally satisfactory to all normally constituted organisms. With those that do not accept such a common substratum neither rational argument nor rational cooperation is possible. Moreover, matters that lie outside this verification in terms of fact have for the modern mind a lower order of reality, no matter how great the presumption, how strong the inner certainty, how passionate the interest. An angel and a high-frequency wave are equally invisible to the mass of mankind, but the reports of angels have come from only a limited number of human receptors, whereas by means of suitable apparatus communication between a sending and a receiving station can be inspected and checked up by any competent human being. The technique of creating a neutral world of fact as distinguished from the raw data of immediate experience was the great general contribution of modern analytic science. This contribution was possibly second only to the development of our original language concepts, which built up and identified, with the aid of a common symbol, such as tree or man, the thousand confused and partial aspects of trees and men that occur in direct experience. Behind this technique, however, stands a special collective morality, a rational confidence in the work of other men, a loyalty to the reports of the senses, whether one likes them or not, a willingness to accept a competent and unbiased interpretation of the results. This recourse to a neutral judge and to a constructed body of law was a belated development in thought comparable to that which took place in morality when the blind conflicts between biased men were replaced by the civil processes of justice. The collective process, even allowing for the accumulation of error and for the unconscious bias of the neutral instrument itself, gave a higher degree of certainty than the most forthright and subjectively satisfactory individual judgment. The concept of a neutral world, untouched by man's efforts, indifferent to his activities, obdurate to his wish and supplication, is one of the great triumphs of man's imagination, and in itself it represents a fresh human value. Minds of the scientific order, even before Pythagoras, must have had intuitions of this world, but the habit of thought did not spread over any wide area until the scientific method and the machine technique had become common. Indeed, it does not begin to emerge with any clearness until the 19th century. The recognition of this new order is one of the main elements in the new objectivity. It is embodied in a common phrase which now rises to the lips of everyone when some accident or breakdown occurs in a process which lies outside everyone's immediate control: a leak in a gas tank in an airplane, a delay on a railroad, that's that. Say 5a. So jets. From machines that have broken down, the same impersonal attitude begins to extend itself to the result of human negligence or human perversity, a badly cooked meal or the elopement of one's sweetheart. These events naturally often provoke stormy and uncontrollable emotional responses, but instead of magnifying the explosion and giving it more fuel, we tend to subject the response as well as the event to a common causal interpretation. The relative passiveness of machine-trained populations during periods when the industrial system itself has been disrupted, a passiveness that contrasts at times with the behavior of rural populations, is perhaps the less favorable side of the same objectivity. Now, in any complete analysis of character, the objective personality is as much of an abstraction as the romantic personality. What we tend to call objective are those dispositions and attitudes which accord with the science and techniques, but while one must take care not to confuse the objective or rational personality with the whole personality, it should be plain that the area of the first has increased, if only because it represents an adaptation indispensable to the running of the machine itself. And the adaptation in turn has further effects: a modulation of emphasis, a matter-of-factness, a reasonableness, a quiet assurance of a neutral realm in which the most obdurate differences can be understood, if not composed, is a mark of the emerging personality. The shrill, the violent, the vociferous, purely animal tooth-baring and foot-stamping, paroxysms of uncritical self-love and uncontrolled hate, all these archaic qualities, which once characterized the leaders of men and their imitators, are now outside the style of our epoch. Their recent revival and attempted sanctification is merely a symptom of that relapse into the raw primitive on which I dwelt a little while back. When one beholds these savage qualities today, one has the sense of beholding a backward form of life, like the mastodon, or of witnessing the outburst of a demented personality. Between the fire of such low types and the ice of the machine, one would have to choose the ice. Fortunately, our choice is not such a narrow one. In the development of the human character we have reached a point similar to that which we have attained in technics itself, the point at which we utilize the completest developments in science and techniques to approach once more the organic. But here again, our capacity to go beyond the machine rests upon our power to assimilate the machine. Until we have absorbed the lessons of objectivity, impersonality, neutrality, the lessons of the mechanical realm, we cannot go further in our development toward the more richly organic, the more profoundly human. Chapter 8. Orientation. 1. The dissolution of the machine. What we call, in its final results, the machine was not, we have seen, the passive byproduct of techniques itself, developing through small ingenuities and improvements and finally spreading over the entire field of social effort. On the contrary, the mechanical discipline and many of the primary inventions themselves were the result of deliberate effort to achieve a mechanical way of life. The motive in back of this was not technical efficiency but holiness, or power over other men. In the course of development, machines have extended these aims and provided a physical vehicle for their fulfillment. Now, the mechanical ideology, which directed men's minds toward the production of machines, was itself the result of special circumstances, special choices, and interests and desires. So long as other values were uppermost, European technology had remained relatively stable and balanced over a period of 3,000 or 4,000 years. Men produced machines partly because they were seeking an issue from a baffling complexity and confusion, which characterized both action and thought, partly, too, because their desire for power, frustrated by the loud violence of other men, turned finally toward the neutral world of brute matter. Order had been sought before, again and again in other civilizations, in drill, regimentation, in flexible social regulations, the discipline of caste and custom. After the 17th century it was sought in a series of external instruments and engines. The Western European conceived of the machine because he wanted regularity, order, certainty, because he wished to reduce the movement of his fellows as well as the behavior of THIRD. Environment to a more definite, calculable basis. But, more than an instrument of practical adjustment, the machine was, from 1750 on, a goal of desire. Though nominally designed to further the means of existence, the machine served the industrialist and the inventor and all the cooperating classes as an end. In a world of flux and disorder and precarious adjustment, the machine at least was seized upon as a finality. If anything was unconditionally believed in and worshipped during the last 2 centuries, at least by the leaders and masters of society, it was the machine, for the machine and the universe were identified, linked together as they were by the formulae of the mathematical and physical sciences, and the service of the machine was the principal manifestation of faith and religion, the main motive of human action, and the source of most human goods. Only as a religion can one explain the compulsive nature of the urge toward mechanical development without regard for the actual outcome of the development in human relations themselves, even in departments where the results of mechanization were plainly disastrous. The most reasonable apologists nevertheless held that the machine was here to stay, by which they meant, not that history was irreversible, but that the machine itself was unmodifiable. Today this unquestioned faith in the machine has been severely shaken. The absolute validity of the machine has become a conditioned validity. Even Spengler, who has urged the men of his generation to become engineers and men of fact, regards that career as a sort of honorable suicide and looks forward to the period when the monuments of the machine civilization will be tangled masses of rusting iron and empty concrete shells. While for those of us who are more hopeful both of man's destiny and that of the machine is no longer the paragon of progress and the final expression of our desires, it is merely a series of instruments, which we will use in so far as they are serviceable to life at large, and which we will curtail where they infringe upon it or exist purely to support the adventitious structure of capitalism. The decay of this absolute faith has resulted from a variety of causes. One of them is the fact that the instruments of destruction ingeniously contrived in the machine shop and the chemist's laboratory, have become in the hands of raw and dehumanized personalities a standing threat to the existence of organized society itself. Mechanical instruments of armament and offense, springing out of fear, have widened the grounds for fear among all the peoples of the world, and our insecurity against bestial, power-lusting men is too great a price to pay for relief from the insecurities of the natural environment. What is the use of conquering nature if we fall a prey to nature in the form of unbridled men? What is the use of equipping mankind with mighty powers to move and build and communicate, if the final result of this secure food supply and this excellent organization is to enthrone the morbid impulses of a thwarted humanity? In the development of the neutral valueless world of science, and in the advance of the adaptive, instrumental functions of the machine, we have left to the untutored egoisms of mankind the control of the gigantic powers and engines Technics has conjured into existence. In advancing too swiftly and heedlessly along the line of mechanical improvement, we have failed to assimilate the machine and to coordinate it with human capacities and human needs, and by our social backwardness and our blind confidence that problems occasioned by the machine could be solved purely by mechanical means, we have outreached ourselves. When one subtracts from the manifest blessings of the machine the entire amount of energy and mind and time and resources devoted to the preparation for war, to say nothing of the residual burden of past wars, one realizes the net gain is dismayingly small, and with the advance of still more efficient means of inflicting death is becoming steadily smaller. Our failure here is the critical instance of a common failure all along the line. The decay of the mechanical faith has, however, still another source, namely, the realization that the serviceability of machines has meant in the past serviceability to capitalist enterprise. We are now entering a phase of dissociation between capitalism and technics, and we begin to see with Thorstein Veblen that their respective interests, so far from being identical, are often at war, and that the human gains of technics have been forfeited by perversion in the interests of a pecuniary economy. We see in addition that many of the Special gains in productivity which capitalism took credit for were in reality due to quite different agents: collective thought, cooperative action, and the general habits of order, virtues that have no necessary connection with capitalist enterprise. To perfect and extend the range of machines without perfecting and giving humane direction to the organs of social action and social control is to create dangerous tensions in the structure of society. Thanks to capitalism, the machine has been overworked, over-enlarged, over-exploited because of the possibility of making money out of it. And the problem of integrating the machine in society is not merely a matter, as I have already pointed out, of making social institutions keep in step with the machine. The problem is equally one of altering the nature and the rhythm of the machine to fit the actual needs of the community. Whereas the physical sciences had first claim on the good minds of the past epoch, it is the biological and social sciences, and the political arts of industrial planning and regional planning and community planning that now most urgently need cultivation. Once they begin to flourish, they will awaken new interests and set new problems for the technologist. But the belief that the social dilemmas created by the machine can be solved merely by inventing more machines is today a sign of half-baked thinking which verges close to quackery. These symptoms of social danger and decay, arising out of the very nature of the machine, its peculiar debts to warfare, mining, and finance, have weakened the absolute faith in the machine that characterized its earlier development. At the same time, we have now reached a point in the development of technology itself where the organic has begun to dominate the machine. Instead of simplifying the organic, to make it intelligibly mechanical, as was necessary for the great Technic and Paleotechnic inventions, we have begun to complicate the mechanical, in order to make it more organic, therefore more effective, more harmonious with our living environment. For our skill, perfected on the finger exercises of the machine, would be bored by the mere repetition of the scales and such childlike imbecilities. Supported by the analytic methods and the skills developed in creating the machine, we can now approach the larger tasks of synthesis. In short, the machine is serving independently, in its neotechnic phase, as a point for a fresh integration in thought and social life. Early in the past the machine was retarded by its limited historic heritage, by its inadequate ideology, by its tendency to deny the vital and the organic. It is now transcending these limitations. And indeed, as our machines and our apparatus become more subtle, and the knowledge derived with their aid becomes more delicate and penetrating, the simple mechanical analysis of the universe made by the earlier physicists ceases to represent anything in which the scientist himself is now interested. The mechanical world picture is dissolving. The intellectual medium in which the machine once spawned so rapidly is being altered at the same time that the social medium, the point of application, is undergoing a parallel change. Neither of these changes is yet dominant, neither is automatic or inevitable. But one can now say definitely, as one could not 50 years ago, that there is a fresh gathering of forces on the side of life. The claims of life, once expressed solely by the Romantics and by the more archaic social groups and institutions of society, are now beginning to be represented at the very heart of Technics itself. Let us trace out some of the implications of this fact. 2. Toward an organic ideology. During the first period of mechanical advance, the application of simple mechanical analogies to complex organic phenomena helped the scientist to create a simple framework for experience in general, including manifestations of life. The real from this standpoint was that which could be measured and accurately defined, and the notion that reality might in fact be vague, complex, undefinable, perpetually a little obscure and shifty, did not go with the sure click and movement of machines. Today this whole abstract framework is in process of reconstruction. Provisionally, it is as useful to say in science that a simple element is a limited kind of organism as it once was to say that an organism was a complicated kind of machine. Newtonian physics, as Professor A. N. Whitehead says in Adventures of Ideas, is based upon the independent individuality of every bit of matter. Each stone is conceived as fully describable apart from any reference to any other portion of matter. It might be alone in the universe, the sole occupant of uniform space. Also, the stone could be adequately described without reference to past or future. It is to be conceived fully and adequately as wholly constituted within the present moment. These independent solid objects of Newtonian physics might move, touch each other, collide, or even, by a certain stretch of the imagination, act at a distance, but nothing could penetrate them except in the limited way that light penetrated translucent substances. This world of separate bodies, unaffected by the accidents of history or of geographic location, underwent a profound change with the elaboration of the new concepts of matter and energy that went forward from Faraday and von Meyer through Clerk Maxwell and Willard Gibbs and Ernest Mach to Planck and Einstein. The discovery that solids, liquids, and gases were phases of all forms of matter modified the very conception of substance, while the identification of electricity, light, and heat as aspects of a protean energy, and the final breakup of solid matter into particles of this same ultimate energy lessened the gap, not merely between various aspects of the physical world, but between the mechanical and the organic. Both matter in the raw and the more organized and internally self-sustaining organisms could be described as systems of energy in more or less stable, more or less complex, states of equilibrium. In the 17th century, the world was conceived as a series of independent systems. First, the dead world of physics, the world of matter and motion, subject to accurate mathematical description. Second, and inferior from the standpoint of factual analysis, was the world of living organisms, an ill-defined realm, subject to the intrusion of a mysterious entity, the vital principle. Third, the world of man, a strange being who was a mechanical automaton with reference to the world of physics, but an independent being with a destiny in heaven from the standpoint of the theologian. Today, instead of such a series of parallel systems, the world has conceptually become a single system. If it still cannot be unified in a single formula, it is even less conceivable without positing an underlying order that threads through all its manifestations. Those parts of reality that can be reduced to patent order, law, quantitative statement are no more real or ultimate than those parts which remain obscure and elusive. Indeed, when applied at the wrong moment or in the wrong place or in a false context, the exactness of the description may increase the error of interpretation. All our really primary data are social and vital. One begins with life, and one knows life, not as a fact in the raw, but only as one is conscious of human society and uses the tools and instruments society has developed through history: words, symbols, grammar, logic, in short, the whole technique of communication and funded experience. The most abstract knowledge, the most impersonal method, is a derivative of this world of socially ordered values. And instead of accepting the Victorian myth of a struggle for existence in a blind and meaningless universe, one must, with Professor Lawrence Henderson, replace this with the picture of a partnership in mutual aid, in which the physical structure of matter itself, and the very distribution of elements on the Earth's crust, their quantity, their solubility, their specific gravity, their distribution and chemical combination, are life-furthering and life-sustaining. Even the most rigorous scientific description of the physical basis of life indicates it to be internally teleological. Now, changes in our conceptual apparatus are rarely important or influential unless they are accompanied, more or less independently, by parallel changes in personal habits and social institutions. Mechanical time became important because it was reinforced by the financial accountancy of capitalism. Progress became important as a doctrine because visible improvements were being rapidly made in machines. So the organic approach in thought is important today because we have begun, here and there, to act on these terms even when unaware of the conceptual implications. This development has gone on in architecture from Sullivan and Frank Lloyd Wright to the new architects in Europe, and from Owen and Ebenezer Howard and Patrick Geddes in city design to the community planners in Holland, Germany, and Switzerland who have begun to crystallize in a fresh pattern the whole neotechnic environment. The humane arts of the physician and the psychologist and the architect, the hygienist and the community planner, have begun during the last few decades to displace the mechanical arts from their hitherto central position in our economy and our life. Form, pattern, configuration, organism, historical filiation, ecological relationship are concepts that work up and down the ladder of the sciences. The aesthetic structure and the social relations are as real as the primary physical qualities that the sciences were once content to isolate. This conceptual change, then, is a widespread movement that is going on in every part of society. In part it arises out of the general resurgence of life, the care of children, the culture of sex, the return to wild nature and the renewed worship of the sun, and in turn it gives intellectual reinforcement to these spontaneous movements and activities. The very structure of machines themselves, as I pointed out in describing the neo-technic phase, reflects these more vital interests. We now realize that the machines, at their best, are lame counterfeits of living organisms. Our finest airplanes are crude, uncertain approximations compared with a flying duck. Our best electric lamps cannot compare in efficiency with the light of the firefly. Our most complicated automatic telephone exchange is a childish contraption compared with the nervous system of the human body. This reawakening of the vital and the organic in every department undermines the authority of the purely mechanical. Life, which has always paid the fiddler, now begins to call the tune. Like the walker in Robert Frost's poem, who found a nest of turtle eggs near a railroad track, we are armed for war. The next machine that has the power to pass will get this plasm on its polished brass. But instead of being confined to a resentment that destroys life in the act of hurling defiance, we can now act directly upon the nature of the machine itself, and create another race of these creatures, more effectively adapted to the environment and to the uses of life. At this point, one must go beyond Sombert's so far excellent analysis. Sombert pointed out, in a long list of contrasting productions and inventions, that the clue to modern technology was the displacement of the organic and the living by the artificial and the mechanical. Within technology itself this process, in many departments, is being reversed. We are returning to the organic. At all events, we no longer regard the mechanical as all-embracing and all-sufficient. Once the organic image takes the place of the mechanical one may confidently predict a slowing down of the tempo of research, the tempo of mechanical invention, and the tempo of social change, since a coherent and integrated advance must take place more slowly than a one-sided unrelated advance. Whereas the earlier mechanical world could be represented by the game of checkers, in which a similar series of moves is carried out by identical pieces, qualitatively similar, the new world must be represented by chess, a game in which each order of pieces has a different status, a different value, and a different function, a slower and more exacting game. By the same token, however, the results in technology and in society will be of a more solid nature than those upon which paleotechnic science congratulated itself, for the truth is that every aspect of the earlier order, from the slums in which it housed its workers to the towers of abstraction in which it housed its intellectuals, was jerry-built, hastily clapped together for the sake of immediate profits, immediate practical success, with no regard for the wider consequences and implications. The emphasis in future must be, not upon speed and immediate practical conquest, but upon exhaustiveness, interrelationship, and integration. The coordination of our technical effort, such coordination and adjustment as is pictured for us in the physiology of the living organism, is more important than extravagant advances along special lines, and equally extravagant retardations along other lines, with a disastrous lack of balance and harmony between the various parts. The fact is then that, partly thanks to the machine, we have now an insight into a larger world and a more comprehensive intellectual synthesis than that which was originally outlined in our mechanical ideology. We can now see plainly that power, work, regularity, are adequate principles of action only when they cooperate with a humane scheme of living, that any mechanical order we can project must fit into the larger order of life itself. Beyond the necessary intellectual reconstruction, which is already going on in both science and technics. 14. Modern machine art. 1. Self-aligning ball bearings. High degree of accuracy and refinement in one of the most essential departments of the machine. The beauty of elementary geometrical shapes. Perfection of finish and adjustment, though already present in fine handicraft, became common and essential with machine craft. Courtesy of the Museum of Modern Art. 2. Section of Spring. Although line and mass are purely utilitarian in origin, the result when isolated has an aesthetic interest. The perception of the special qualities of highly finished machine forms was one of the prime discoveries of Brancusi, and the sculptors in glass and metal like Moholy-Nagy and Grabo. Courtesy of the Museum of Modern Art. 3. Glass bottles with caps, typical of modern mass production. Contrast this simple product of the Owens, Illinois Glass Co. with the extremely complicated machine that makes such mass production possible, shown on Plate 11. Courtesy of the Museum of Modern Art. 4. Kitchen ladles, another example of serial production, with all the advantages of uniform design and high refinement of finish. But while the machine cannot successfully achieve decoration, handicraft often produced forms as rational as those of the machine. In functional design the two modes overlap. Even in more primitive Technics machines like the lathe, drill, and loom-conditioned handicraft and in turn Technic handicraft furthered the machine. Courtesy of the Museum of Modern Art. 15. The new environment. 1. Interior of the giant power station at Dnik-Prostroy. The calmness, cleanness, and order of the Neotechnic environment. The same qualities prevail in the power station or the factory as in the kitchen or the bathroom of the individual dwelling. In any one of these places one could eat off the floor. Contrast with the Paleotechnic environment. Photographed by Savfito. 2. Waterfront at Köln. The order and plan of the Neotechnic economy is apparent in what used to be the most chaotic and slatternly parts of the city. The factories and docks form a common unit, which, so far from making the scene hideous, contribute to its aesthetic composure. Compare this with the competitive waste, muddle, blight, and advertisement of the older regime. 3. Example of modern workers' dwellings in Sweden, typical of millions of such dwellings that came into existence in Europe after 1915, thanks to the sudden crystallization of Neotechnic methods in community planning and housing. Here is a return to a handsome and well-integrated human environment, in which the efficiency of Neotechnic production can be registered in a higher standard of living and a wider use of leisure. Courtesy of the Architectural Forum. 4. Modern waterworks in Sweden. What is called the new architecture is in fact a symbol of a fresh mode of thinking and feeling and living in which the Scandinavian countries in particular have often been in the forefront. But similar examples could be culled from almost every Neotechnic region. Courtesy of the Architectural Forum. We must build up more organic centers of faith and action in the arts of society and in the discipline of the personality. This implies a reorientation that will take us far beyond the immediate province of Technics itself. These are matters touching the building of communities, the conduct of groups, the development of the arts of communication and expression, the education and the hygiene of the personality that I purpose to take up in another book. Here I will confine attention to coordinate readjustments which are clearly indicated and already partly formulated and enacted in the realm of technics and industry. 3. The elements of social energetics. Let us examine the implications of Neotechnic developments, within the machine itself, upon our economic objectives, upon the organization of work, upon the direction of industry and the goals of consumption, upon the emerging social purposes of the Neotechnic phase of civilization. First, the economic objectives. In the course of capitalistic enterprise, which accompanied the widespread introduction of machines and machine methods in the 15th and 16th centuries, the focus of industry shifted from the craft guild to the merchant guild or the livery company or the company of merchant adventurers, or to the special organization for exploiting patent monopolies. The means of exchange usurped the function and meaning of the things that were exchanged. Money itself became a commodity and money-getting became a specialized form of activity. Under capitalism, profit reigned as the main economic objective, and profit became the decisive factor in all industrial enterprise. Inventions that promised profits, industries that produced profits, were fostered. The reward of capital, if not the first claim upon productive enterprise, was at all events the dominating one. the service of the consumer and support of the worker were entirely secondary. Even in a period of crisis and breakdown, such as that capitalism is still in the midst of at the moment I write, dividends continue to be paid to rentiers out of past accumulation while the industry itself often operates at a loss, or the mass of workers are turned out to starve. Sometimes profits were obtained by lowering the costs and spreading the product, but if they could be had only by oiling inferior or adulterated goods as in the sale of medical nostrums or the slum housing of the underpaid worker, health and well-being were sacrificed to gain. The community, instead of receiving a full return for its goods and services, permitted a portion of the product to be diverted for the private gratification of the holders of land and capital. These holders of land and capital, backed up by the law and all the instruments of government, determined privately and solely in accordance with the canon of profit what should be produced and how much and where and how and by whom and on what terms. In the economic analysis of the society that grew up on this basis, the three main terms in industrial activity were production, distribution, and consumption. Profits were to be increased by cheaper production, by wider and multifold distribution, and by a steadily rising standard of consumptive expenditure, with sometimes in lieu of that, sometimes accompanying it an enlarging market of consumers. Saving labor, or cheapening labor by a superiority of bargaining power obtained by withholding land from the laborer and monopolizing the new instruments of production were the two chief means, from the capitalist standpoint, of increasing the margin of profits. Saving labor by rationalization was a real improvement which bettered everything but the position of the laborer. The stimulation of the demand for goods was the chief means of increasing the turnover, hence the problem of capitalism was essentially not to satisfy needs but to create demands. And the attempt to represent this process of private aggrandizement and class advantage as a natural and socially beneficent one was perhaps the main labor of political economists during the 19th century. When one examines economic activities from the standpoint of the employment of energy and the service of human life, this whole financial structure of production and consumption turns out to have mainly a superstitious basis. At the bottom of the structure are farmer and peasant, who during the entire course of the Industrial Revolution, which their increase of the food supply has made possible, have scarcely ever received an adequate return for their products, at least on the basis of pecuniary accountancy by which the rest of this society was run. Furthermore, what are called gains in capitalist economics often turn out, from the standpoint of social energetics, to be losses, while the real gains, the gains upon which all the activities of life, civilization, and culture ultimately depend, were either counted as losses, or were ignored, because they remained outside the commercial scheme of accountancy. What are, then, the essentials of the economic processes in relation to energy and to life? The essential processes are conversion, production, consumption, and creation. In the first two steps energy is seized and prepared for the sustenance of life. In the third stage, life is supported and renewed in order that it may wind itself up, so to speak, on the higher levels of thought and culture, instead of being short-circuited at once back into the preparatory functions. Normal human societies exhibit all four stages of the economic processes, but their absolute quantities and their proportions vary with the social milieu. Conversion has to do with the utilization of the environment as a source of energy. The prime fact of all economic activity, from that of the lower organisms up to the most advanced human cultures, is the conversion of the sun's energies. This transformation depends upon the heat-conserving properties of the atmosphere, upon the geological processes of uplift and erosion and soil building, upon the conditions of climate and local topography, and most important of all upon the green leaf reaction in growing plants. This seizure of energy is the original source of all our gains. On a purely energetic interpretation of the process, all that happens after this is a dissipation of energy, a dissipation that may be retarded, that may be dammed up, that may be temporarily diverted by human ingenuity, but in the long run cannot be averted. All the permanent monuments of human culture are attempts, by using more attenuated physical means of preserving and transmitting this energy, to avert the hour of ultimate extinction. The most important conquest of energy was man's original discovery and utilization of fire. After that, the most significant transformation of the environment came through the cultivation of the grain-bearing grasses, the vegetables, and the domestic animals. Indeed, the enormous increase in population which took place at the beginning of the 19th century, before the machine had made any appreciable change in agriculture, was due to the opening of immense areas of free land for grain cultivation and cattle raising and the better provision of winter fodder crops, combined with the addition of 3 new energy crops: sugar cane, sugar beet, and potato to the diet of the industrial population. The mechanical conversion of energy is second in importance to the organic conversion. But in the development of techniques, the invention of the water wheel, the water turbine, the steam engine, and the gas engine multiplied the energies that were available to man through the use of foods grown for himself and his domestic animals. Without the magnification of human energy made possible through the series of prime movers, our apparatus of production and transport could not have reached the gigantic scale it attained in the 19th century. All the further steps in the economic process depend upon the original act of conversion. The level of achievement can never rise higher than the level of the energy originally converted, and just as only an insignificant part of the sun's energy available is utilized in conversion, so only a small part of this, in turn, finally is utilized in consumption and creation. Conversion lifts the energy available to a peak. From that point on, energy runs downhill in gathering and shaping the raw materials, in transporting supplies and products, and in the processes of consumption itself. Not until the economic process reaches the stage of creation, not until it supplies the human animal with more energy than he needs to maintain his physical existence, and not until still other energies are transformed into the more durable media of art and science and philosophy, of books, buildings, and symbols, is there anything that can be called, even within a limited span of time, a gain. At one end of the process is the conversion of the free energy of nature and its transformation into forms usable by agriculture and technology. At the other end of the process is the conversion of the intermediate, preparatory products into human subsistence, and into those cultural forms that are usable by succeeding generations of men. The amount of energy available for the final process depends upon 2 facts: how much energy is converted by agriculture and techniques at the beginning, and how much of that energy is effectively applied and conserved in transmission. Even the crudest society has some surplus. But under the capitalist system, the main use of this surplus is to serve as profits, which are incentives to capital investments, which in turn increase production. Hence 2 massive and recurrent facts in modern capitalism: first, an enormous overexpansion of plant and equipment. Thus the Hoover Committee on the Elimination of Waste in Industry found, for example, that clothing factories in the United States are about 45% larger than necessary, printing establishments are from 50 to 150% over-equipped, and the shoe industry has a capacity twice that of actual production. Second, an excessive diversion of energy and manpower into sales, promotion, and distribution. Whereas only 10% of the working population in the United States was engaged in transporting and distributing the commodities produced in 1870, the proportion had risen to 25% in 1920. Other means of utilizing the surplus, such as the cultural and educational bequests of various philanthropies, relieve some of the burden of inane waste from both the individual and from industrial society, but there is no capitalist theory of non-profit making enterprises and non-consumable goods. These functions exist accidentally, by the grace of the philanthropist, they have no real place in the system. Yet it should be plain that as society becomes technically mature and civilized, the area occupied by the surplus must become progressively wider. It will be greater than it occupied under capitalism or under those more primitive non-capitalist civilizations which, as was pregnantly demonstrated by Radha Kamal Mukherjee, capitalist economics so inadequately describes. The permanent gain that emerges from the whole economic process is in the relatively non-material elements in culture, in the social heritage itself, in the arts and sciences, in the traditions and processes of technology, or directly in life itself, in those real enrichments. that come from the free exploitation of organic energy in thought and action and emotional experience, in play and adventure and drama and personal development gains that last through memory and communication beyond the immediate moment in which they are enjoyed. In short, as John Ruskin put it, there is no wealth but life, and what we call wealth is in fact wealth only when it is a sign of potential or actual vitality. An economic process that did not produce this margin for leisure, enjoyment, absorption, creative activity, communication, and transmission would completely lack human meaning and reference. In the histories of human groups there are of course periods of starvation, periods of flood and earthquake and war, when man fights a losing fight with his environment, and does not even secure bare physical survival, and there are moments when the complete social process is brutally cut short. But even in the most perverse and degraded forms of life, there is an aspect that corresponds, vitally and psychally speaking, to creation, and even in the most inadequate forms of production, such as that which prevailed during the Paleotechnic phase, there remains a surplus not arrogated by industry. Whether this surplus goes to increase the preparatory processes, or whether it is to be spent on creation, is a choice that cannot be automatically decided, and the tendency in capitalist society to put it back quickly into the preparatory processes, and to make possible increased production by applying pressure to consumption, is merely a further indication of its absence of social criteria. The real significance of the machine, socially speaking, does not consist either in the multiplication of goods or the multiplication of wants, real or illusory. Its significance lies in the gains of energy through increased conversion, through efficient production, through balanced consumption, and through socialized creation. The test of economic success does not, therefore, lie in the industrial process alone, and it cannot be measured by the amount of horsepower converted or by the amount commanded by an individual user, for the important factors here are not quantities but ratios of mechanical effort to social and cultural results. A society in which production and consumption completely cancelled out the gains of conversion, in which people work to live and live to work, would remain socially inefficient, even if the entire population were constantly employed, and adequately fed, clothed, and sheltered. The ultimate test of an efficient industry is the ratio between productive means and the achieved ends. Hence a society with a low scale of conversion but with a high amount of creation is humanly speaking superior to a society with an enormous panoply of converters and a small and inadequate army of creators. By the ruthless pillage of the food-producing territories of Asia and Africa, the Roman Empire appropriated far more energy than Greece, with its sparse abstemious dietary and its low standard of living. But Rome produced no poem, no statue, no original architecture, no work of science, no philosophy comparable to the Odyssey, the Parthenon, the works of 6th and 5th century sculptors, and the science of Pythagoras, Euclid, Archimedes, Hero, and so the quantitative grandeur and luxury and power of the Romans, despite their extraordinary capacity as engineers, remained relatively meaningless, even for the continued development of technics. The work of the Greek mathematicians and physicists was more important. This is why no working ideal for machine production can be based solely on the gospel of work, still less can it be based upon an uncritical belief in constantly raising the quantitative standard of consumption. If we are to achieve a purposive and cultivated use of the enormous energies now happily at our disposal, we must examine in detail the processes that lead up to the final state of leisure, free activity, creation. It is because of the lapse and mismanagement of these processes that we have not reached the desirable end, and it is because of our failure to frame a comprehensive scheme of ends that we have not succeeded in achieving even the beginnings of social efficiency in the preparatory work. How is this margin to be achieved and how is it to be applied? Already we are faced with political and moral problems as well as technological ones. Schleyer is nothing in the nature of the machine as such, nothing in the training of the technician as such, that will provide us with a sufficient answer. We shall of course need his help, but in turn he will need help from other quarters of the compass, far beyond Schleyer province of technology. 4. Increase conversion. Modern techniques began in Western civilization with an increased capacity for conversion. Early society faces a fairly imminent shortage of petroleum and perhaps natural gas, and while the known coal beds of the world give no longer promise of life, at the present rates of consumption, than 3,000 years, we face no serious energy problem that we cannot solve even with our present equipment, provided that we utilize to the full our scientific resources. Apart from the doubtful possibility of harnessing interatomic energy, there is the much nearer one of utilizing the sun's energy directly in sun converters, or of utilizing the difference in temperature between the lower depths and the surface of the tropical seas. There is likewise the possibility of applying on a wide scale new types of wind turbine, like the rotor. Indeed, once an efficient storage battery was available, the wind alone would be sufficient, in all probability, to supply any reasonable needs for energy. Along with the renewed use through electricity of wind and water, one must put the destructive distillation of coal, near the pithides, in the new types of coke oven. This not merely saves enormous amounts in energy now spent in transporting the fuel from the place where it is mined to the place where it is used, but it also conserves the precious compounds that now escape into the air in the wasteful individual furnaces. Theoretically, however, such economies of energy only lead to wider consumption and so to more rapid utilization of the very thing we wish to conserve, hence the necessity for making a socialized monopoly of all such raw materials and resources. The private monopoly of coal beds and oil wells is an intolerable anachronism, as intolerable as would be the monopoly of sun, air, running water. Here the objectives of a price economy and a social economy cannot be reconciled, and the common ownership of the means of converting energy, from the wooded mountain regions where the streams have their sources down to the remotest petroleum wells, is the sole safeguard to their effective use and conservation. Only by increasing the amount of energy available, or, when the amount is restricted, by economizing more cunningly in its application, shall we be in a position to eliminate freely the basest forms of drudgery. What is true for mechanical power production is likewise true for organic forms of power production, such as the growing of foods and the extraction of raw materials from the soil. In this department, capitalistic society has confused ownership with security of tenure and continuity of effort, and in the very effort to foster ownership while maintaining the speculative market, it has destroyed security of tenure. It is the latter condition that is necessary for conservative farming, and not until the community itself holds the land will the position of the farmer be a desirable one. The negative side of the socialization of the land, namely, the purchase of marginal land, unfit for any other purpose than forest growth, has already been taken up, for example, by the state of New York. It remains to accomplish a similar end on the positive side by taking over and appropriately planning for maximum cultivation and enjoyment the good agricultural lands. Such ownership and planning by the community do not necessarily mean large-scale farming, for the efficient economic units differ with the type of farming, and the large mechanized units suitable to the cultivation of the wheatlands of the prairies are in fact inappropriate to other types of farming. Neither does such a system of rationalization inevitably mean the extinction of the small family farming group, with the skill and initiative and general intelligence that distinguishes the farmer favorably from the over-specialized factory worker of the old style. But the permanent zoning of certain areas for certain types of agriculture, and the experimental determination of the types of crop appropriate to a particular region or a particular section are matters that cannot be left to guess, chance, or blind individual initiative. They are, on the contrary, complicated technical questions in which objective answers are possible. In long-settled areas, like the various wine-growing sections of France, soil utilization surveys will probably only confirm existing types of effort, but wherever there is a question of choice between types of use, the decision cannot be left to the chance interests of individuals. The first step toward rationalization in agriculture is the common ownership of the land. Such ownership prevailed in Europe under customary forms down to the 19th century in certain regions, and its restoration involves no breach whatever with the essential foundations of rural life. The private appropriation and exploitation of the land, indeed, must be looked upon as a transitory state, peculiar to capitalism, between customized local agriculture based upon the common needs of the small local community and a rationed world agriculture, based upon the cooperative resources of the entire planet, considered as a federation of balanced regions. The fact that, except in times of extreme scarcity, the farmer is pauperized or ruined by the abundance of his crops only emphasizes the point that a more stable basis for agricultural production must be found, a basis that does not rely upon the individual guesses of the farmer, the caprices of nature, and the speculative fluctuations of the world market. Within any given period, price tends to vary inversely with the quantity available. Here as elsewhere, monetary values disappear toward zero as vital values and energies rise. Hence the need for rationing, for stable crops, and for an altogether new system of determining price and marketability. I shall go into this last point presently. It is enough to point out here that with the development of balanced economic regions, agricultural production will be related to a stable local market. The sudden gluts and shortages that arise with transportation to distant centers will disappear, and further to regularize production, a good part of the more delicate crops will be grown in small units, possibly, as in Holland, under glass, near the place of consumption. To increase conversion, then, is no simple matter of merely mining coal or building more dynamos. It involves the social appropriation of natural resources, the replacing of agriculture and the maximum utilization of those regions in which kinetic energy in the form of sun, wind, and running water is abundantly available. The socialization of these sources of energy is a condition of their effective and purposive use. 5. Economize production. The application of power to production and the employment of quick and relatively tireless machines to perform manual movement and the organization of rapid transport and the concentration of work into factories were the chief means adopted during the 19th century to increase the quantity of commodities available. And the goal of this development within the factory was the complete substitution of non-human power for manpower, of mechanical skill for human skill, of automatons for workers, in every department where this was possible. Where the absence of human feelings or intelligence did not manifest itself in an inferiority of the product itself, that goal was a legitimate one. The mechanical elements in production were rationalized much more rapidly than the human elements. In fact, one might almost say that the human elements were irrationalized at the same time, for the stimuli to production, human fellowship, an esprit de corps, the hope of advancement and mastery, the appreciation of the entire process of work itself, were all reduced or wiped out at the very moment that the work itself, through its subdivision, ceased to give any independent gratification. Only the pecuniary interest in production remained, and the majority of mankind, unlike the avaricious and ambitious spirits who march to the head of industry, are apparently so irresponsive to this pecuniary stimulus that the directing classes relied upon the lash of starvation, rather than upon the pleasures of surfeit, to drive them back to the machine. Collective instruments of production were created and used, without the benefit of a collective will and a collective interest. That, to begin with, was a serious handicap upon productive efficiency. The workers grudged the efforts they gave to the machine, applied themselves with half a mind, loitered and loafed when there was an opportunity to escape the eye of the foreman or the taskmaster, sought to give as little as they could in return for as much wages as they could get. So far from attempting to combat these sources of inefficiency, the enterpriser sanctioned it by relieving the worker of such autonomy and responsibility as might naturally adhere to the job, by insisting upon speed for the sake of cheapness without regard for the excellence of workmanship, and by managing industry with an eye solely upon the maximum cash return. There were exceptions in every industry, but they did not establish the main line. Not appreciating the gain to efficiency from collective loyalty and collective interest and a strong common drive, the great industrialists did their best to browbeat any of these incipient responses out of the worker, by lockouts, by ruthless warfare in strikes, by hard bargains in wages and by callous layoffs during periods of slack work. The typical employers of labor did their ignorant best to decrease the efficiency of the workers and throw sand in the works. These tactics greatly increased the labor turnover and therefore lowered the internal efficiency of operation, Even such a moderate improvement in the wage scale as Ford introduced in Detroit had a powerful effect in lessening such losses. But what shall one say to the efficiency of a productive system in Hitch strikes and lockouts in the United States, according to Polakoff, at the beginning of the last decade, averaged 54 million man-days of idleness per year. The loss and inefficiency due to the failure to create a cooperative pattern of human relations which would supplement that of the machine industry itself cannot be estimated, but the success of such occasional mutations within the capitalist system as the Cadbury Cocoa Works at Bourneville, the Godin Steel Works at Guy's, an adaptation of Fourier's scheme for a cooperative phalanstery, and the Denison Paper Manufacturing Works at Framingham, Massachusetts, gives a slight indication of what our total efficiency would have been had social relations themselves been rationalized at the time the machine was introduced. It is evident, at all events, that a good part of our mechanical adroitness has been annulled by social friction, waste, and unnecessary human wear and tear. Testimony to that effect comes from the production engineers themselves. At the end of the 19th century, a new attack upon the problem of efficiency in production was made within the factory. It was no accident perhaps that the distinguished engineer who initiated it was also the co-inventor of a new high-speed tool steel, a characteristic neotechnic advance. Instead of studying the machine as an isolated unit, Taylor studied the worker himself as an element in production. By a close factual study of his movements, Taylor was able to add to the labor output per man without adding to his physical burden. The time and motion studies that Taylor and his followers introduced have now, with the development of serial processes and greater automatism, become somewhat outmoded. Their importance lay in the fact that they directed attention to the industrial process as a whole and treated the worker as an integral element in it. Their weakness lay in the fact that they accepted the aims of capitalist production as fixed, and they were compelled to rely upon a narrow pecuniary incentive with piecework production and bonuses to achieve the mechanical gains that were possible. The next step toward the genuine rationalization of industry lies in widening the interests and increasing the social incentives to production. On one hand, this means the reduction of trivial and degrading forms of work. It likewise means the elimination of products that have no real social use, since there is no form of cruelty for a rational human being worse than making him produce goods that have no human value. Picking oakum is by comparison an edifying task. In addition, the stimulation of invention and initiative within the industrial process, the reliance upon group activity and upon intimate forms of social approval, and the transformation of work into education, and of the social opportunities of factory production into effective forms of political action, all these incentives toward a humanly controlled and effectively directed industrial production await the formulation of non-capitalist modes of enterprise. Taylorism, though it had within its technique the germ of a revolutionary change in industry, was reduced to a minor instrument in almost every country except Russia. But it is precisely in the political and psychological relations of the worker to the industry that the most effective economies have still to be made. This has been excellently illustrated in an experiment in a Westinghouse plant described by Professor Elton Mayo. By paying attention to the conditions of work and, while providing rest periods, the efficiency of a group of workers was steadily raised. After a certain period of experiment, the group was put back in the original condition of work without rest periods. Still the output was greater than it had been originally. What had happened? There was a feeling among the operatives, according to the observer, that better output is in some way related to the distinctively pleasanter, freer, and happier working conditions. This is a long stage beyond Taylor's original mechanical motion study. And it points to a factor of efficiency in socialized industry, in which the worker himself is fully respected, which capitalism at its most enlightened best can scarcely more than touch. Is not this human factor perhaps one of the reasons why small-scale industry, in addition to its lower overhead, can still often compete with large-scale industry, where monopoly does not favor the latter? Meanwhile, modern production has added enormously to the productive output without adding a single horsepower or a single machine or a single workman. What have been the means? On one hand, there have been great gains through mechanical articulation within the factory, and through the closer organization of raw materials, transport, storage, and utilization in the factory itself. By timing, working out economic sequences, creating an orderly pattern of activity, the engineer has added enormously to the collective product. By transferring power from human organisms to machines, he has decreased the number of variable factors and integrated the process as a whole. These are the gains of organization and administration. The other set of gains has come through standardization and serial production. This involves the reduction of a whole group of different articles, in which differences did not correspond to essential qualities, to a limited number of types. Once these types can be established and suitable machines devised to processing and manufacturing them, the process can approach more and more closely to automatism. The dangers here lie in premature standardization, and in making assembled objects like automobiles so completely standardized that they cannot be improved without a wholesale scrapping of the plant. This was the costly mistake that was made in the Ford Model T. But in all the ranges of production where typification is possible, large productive economies can be achieved by that method alone. One returns to the illustration originally used by Babbage. The stone could be moved without skill or organized effort by exerting 753 pounds of effort, or it might be moved, by adapting appropriately every part of the environment, by using only 22 pounds. In its crude state, industry prides itself upon its gross use of power and machinery. In its advanced state it rests upon rational organization, social control, physiological and psychological understanding. In the first case, it relies upon the external exercise of power in its political relations. Indeed, it prides itself upon surmounting the friction which with such superb ineptitude it creates. In the second state, no part of the works can remain immune to criticism and rational criteria. The goal is no longer as much production as is compatible with the canons of private enterprise and private profit and individual money incentives. It is rather efficient production for social uses, no matter how drastically these sacred canons must be revised or extirpated. In a word, to economize production, we cannot begin or end with the physical machines and utilities themselves, nor can efficient production begin and end in the individual factory or industry. The process involves an integration of the worker, the industrial function, and the product, just as it involves a further coordination between the sources of supply and the final consumptive outlets. At hardly any point in our present system of production have we begun to utilize the latent energies that are available through organization and social control. At best, here and there, we have just begun to sample such efficiencies. If we have only begun to utilize the latent energies of the personnel, it is equally true that the geographic distribution of industries, hitherto governed by accidental choices and opportunities, has still to be worked out rationally in terms of the world's resources and the resettlement of the world's population into the areas marked as favorable for human living. Here, through economic regionalism, a new series of economies offers itself. The accidents of original manufacture or of the original location of resources cannot continue as guiding factors in GRO:1, H when new sources of supply and new distribution of markets are recognized. Moreover, the neotechnic distriation of Ver makes for economic regionalism. The concentration of population in the coal towns and the port towns was a mark of a haphazardly organized labor supply and of the high cost of coal transportation. One of the large possibilities for economy here lies in the abolition of cross hauls, the familiar process of carrying coals to Newcastle. Traders and middlemen gain by lengthening the distance in space and time between the producer and the ultimate consumer. Under a rationally planned distribution of industry, this parasitism in transit would be reduced to a minimum. And as the knowledge of modern techniques spreads, the special advantages in skill and organization and science, once enjoyed by a few countries alone, by England during the 19th century above all, tend to become the common property of mankind at large, for ideas are not stopped by customs barriers or freight rates. Our modern world, transporting knowledge and skill, has diminished the need for transporting goods. St. Louis's shoes are as good as New England's, and French textiles are as good as English. In a balanced economy, regional production of commonplace commodities becomes rational production, and interregional exchange becomes the export of the surplus from regions of increment to regions of scarcity, or the exchange of special materials and skills like tungsten, manganese, fine china, lenses not universally found or developed throughout the world. But even here the advantages of a particular place may remain temporary. While American and German Camembert cheese is still vastly inferior to the French variety, the Gruyere cheese produced in Wisconsin compares favorably with that produced in Switzerland. With the growth of economic regionalism, the advantages of modern industry will be spread, not chiefly by transport as in the 19th century but by local development. The prime examples of conscious economic regionalism up to the present have come from countries like Ireland and Denmark, or states like Wisconsin, where the occupations were predominantly agricultural, and where a flourishing economic life depended upon an intelligent exploitation of all the regional resources. But economic regionalism does not aim at complete self-sufficiency. Even under the most primitive conditions, no region has ever been economically self-sufficient in all respects. On the other hand, economic regionalism does aim at combating the evil of over-specialization, since whatever the temporary commercial advantages of such specialization, it tends to impoverish the cultural life of a region and, by placing all its eggs in one basket, to make precarious ultimately its economic existence. Just as every region has a potential balance of animal life and vegetation, so it has a potential social balance between industry and agriculture, between cities and farms, between built-up spaces and open spaces. A region entirely specialized for a single resource, or covered from boundary line to boundary line by a solid area of houses and streets, is a defective environment, no matter how well its trade may temporarily flourish. Economic regionalism is necessary to provide for a varied social life, as well as to provide for a balanced economy. Plainly, a good part of the activity and business and power of the modern world, in which the 19th century took so much pride, was the result of disorganization, ignorance, inefficiency and social ineptitude. But the spread of technical knowledge, standardized methods, and scientifically controlled performances diminishes the need for transportation. In the new economy, the old system of regional overspecialization will become the exception rather than the rule. Even today, England is no longer the workshop of the world, and New England is no longer the workshop of America. And as mechanical industry becomes more highly rationalized and more finely adapted to the environment, a varied and many-sided industrial life tends to develop within each natural human region. To achieve all these possible gains in production takes us far beyond the individual factory or industry, far beyond the current tasks of the administrator or engineer. It requires the services of the geographer and the regional planner, the psychologist, the educator, the sociologist, the skilled political administrator. Perhaps Russia alone at present has the necessary framework for this planning in its fundamental institutions, but to one degree or another, pushed by the necessity for creating order out of the existing chaos and disorganization, other countries are moving in the same direction. The 90 Technics and Civilisation. Zuiderzee reclamation in Holland, for example, is an example of the multifold rationalization of industry and agriculture and the building up of economic regional units here indicated. The older modes of production have exploited only the superficial processes that were capable of being mechanized and externally ordered, whereas a bolder social economy will touch every aspect of the industrial complex. Complete organization of the mechanical elements, with ignorance, accident, and uncriticized custom dominant in society as a whole, was the formula of capitalistic enterprise during its earlier phases. That formula belongs to the past. It achieved only a small part of the potential production that even the crude machine age of the past was capable of, provided that it could have removed the frictions and contradictions and cross-purposes that perpetually impeded the flow of goods from source to mouth. To achieve efficiency in the past was as self-defeating a task as Carlyle's famous dilemma, given a band of thieves to produce an honesty out of their united action. In detail, we will doubtless carry over many admirable practices and rational arrangements derived from capitalism, but it is entirely doubtful, so deep are the dissonances, so inevitable are the frictions, that we shall carry over capitalist society itself. Humanly speaking, it has worn out its welcome. We need a system more safe, more flexible, more adaptable, and finally more life-sustaining than that constructed by our narrow and one-sided financial economy. Its efficiency was a mere shadow of real efficiency, its wasteful power was a poor substitute for order, its feverish productivity and its screaming breakdowns, wastes, and jams were low counterfeits of a functional economy that could really profit by modern techniques. 6. Normalize consumption. Whereas we must maximize conversion, in order to have surplus energies ready to fulfill existing wants, and to be prepared for unexpected needs, it does not follow that we must also maximize production along the existing lines of effort. The aimless expansion of production is in fact the typical disease of capitalism in its application of modern techniques, for since it failed to establish norms, it had no definite measure for its productive achievement and no possible goals, except those erected by custom and accidental desire. The expansion of the machine during the past 2 centuries was accompanied by the dogma of increasing wants. Industry was directed not merely to the multiplication of goods and to an increase in their variety, it was directed toward the multiplication of the desire for goods. We passed from an economy of need to an economy of acquisition. The desire for more material satisfactions of the nature furnished by mechanized production kept up with and partly cancelled out the gains in productivity. Needs became nebulous and indirect. To satisfy them appropriately under the capitalist criterion, one must gratify them with profitable indirectness through the channels of sale. The symbol of price made direct seizure and gratification vulgar, so that finally the farmer who produced enough fruit and meat and vegetables to satisfy his hunger felt a little inferior to the man who, producing these goods for a market, could buy back the inferior products of the packing house and the cannery. Does that exaggerate the reality? On the contrary, it hardly does justice to it. Money became the symbol of reputable consumption in every aspect of living, from art and education to marriage and religion. Max Weber pointed out the extraordinary departure of the new doctrines of industrialism from the habits and customs of the greater part of mankind under the more parsimonious system of production that prevailed in the past. The aim of traditional industry was not to increase the number of wants, but to satisfy the standards of a particular class. Even today, among the poor, the habits of this past linger on along with relics of magic and primitive medicine, for an increase in wages, instead of being used to raise the worker's standard of expenditure, is sometimes used to secure respite from work, or to provide the wherewithal for a spree which leaves the worker in exactly the same physical and social state he was in before beginning it. The notion of employing money to escape one's class, and of spending money conspicuously in order to register the fact that one has escaped, did not come into existence in society at large until a fairly late stage in the development of capitalism, although it manifested itself in high upper ranks at the very beginning of the modern regime. The dogma of increasing wants, like so many other dogmas of industrialism and democracy, first appeared in the counting house and the court, and then filtered down into the rest of society. When abstract counters in gold or paper became the symbols of power and wealth, men began to value a form of commodity that had in fact no natural limits. The absence of normal standards of acquisition first manifested itself among the successful bankers and merchants, yet even here these standards lingered on far into the 19th century in the conception of retiring from business after achieving a competence, that is, the standards of one's class. The absence of a customary norm of consumption was most conspicuous in the extravagant life of the courts. To externalize the desire for power, wealth, and privilege, the princes of the Renaissance lavished upon private luxury and display enormous amounts of money. They themselves, unless they happened to rise from the merchant class, did not earn this money. They were forced therefore to beg, borrow, extort, steal, or pillage it, and truth to tell, they left none of these possibilities unexplored. Once the machine began to increase the money-making capacities of industry, these limits were extended and the level of expenditure was raised for the entire society. This phase of capitalism was accompanied, as I have already pointed out, by a widespread breakdown of social institutions. Hence the private individual often sought to compensate by egocentric getting and spending for the absence of collective institutions and a collective aim. The wealth of nations was devoted to the private gratification of individuals. The marvels of collective enterprise and cooperation that the machine brought into play left the community itself impoverished. Despite the natural egalitarian tendency of mass production, a great gap continued to exist between the various economic classes. This gap was glibly accounted for, in terms of Victorian economics, by a differentiation between necessities, comforts, and luxuries. The bare necessities were the lot of the niche of workers. Middle classes, in addition to having their necessities satisfied on an ampler scale than the workers, were supported by comforts, while the rich possessed in addition, and this made them more fortunate luxuries. Yet there was a contradiction. Under the doctrine of increasing wants, the mass of mankind was supposed to adopt for itself the ultimate goal of a princely standard of expenditure. There existed nothing less than a moral obligation to demand larger quantities and more various kinds of goods, the only limit to this obligation being the persistent unwillingness of the capitalist manufacturer to give the worker a sufficient share of the industrial income to make an effective demand. At the height of the last wave of financial expansion in the United States, the capitalists sought to solve this paradox by loaning money for increased consumption installment purchase without raising wages, lowering prices, or decreasing his own excessive share in the national income, a device which would never have occurred to the more sober Harpagons of the 17th century. The historic mistakes of men are never so plausible and so dangerous as when they are embodied in a formal doctrine, capable of being expressed in a few catchwords. The dogma of increasing wants, and the division of consumption into necessities, comforts, and luxuries, and the description of the economic process as leading to the universalizing of more expensive standards of consumption in terms of machine-made goods, all these beliefs have been largely taken for granted, even by many of those who have opposed the outright injustices and the more flagrant inequalities of the capitalist economic system. The doctrine was put, with a classic fatuousness and finality, by the Hoover Committee's report on recent economic changes in the United States. The survey has proved conclusively, says the report, what has long been held theoretically to be true, that wants are almost insatiable, that one want makes way for another. The conclusion is that economically we have a boundless field before us, that there are new wants which will make way endlessly for newer wants, as fast as they are satisfied. When one abandons class standards of consumption and examines the facts themselves from the standpoint of the vital processes that are to be served, one finds that there is not a single element in these doctrines that can be retained. First of all, vital wants are all necessarily limited. Just as the organism itself does not continue to grow beyond the norm of its species, a norm established within relatively narrow limits, so neither can any particular function of life be satisfied by limitless indulgence. The body does not require more than a limited number of calories of food per day. If it functions adequately on 3 meals a day, it does not become 3 times as strong or effective on 9 meals, on the contrary, it is likely to suffer from indigestion and constipation. If the intensity of amusement is tripled in a circus by the use of 3 rings instead of 1, there are few other circumstances in which this rule holds. The value of various stimuli and interests is not increased by quantitative multiplication, nor yet, beyond a certain point, by endless variety. A variety of products which perform similar functions is like omnivorousness in diet, a useful factor of safety. But this does not alter the essential fact of stability of desire and demand. A harem of 1,000 wives may satisfy the vanity of an oriental monarch, but what monarch is sufficiently well endowed by nature to satisfy the harem? Healthy activity requires restriction, monotony, repetition, as well as change, variety, and expansion. The querulous boredom of a child that possesses too many toys is endlessly repeated in the lives of the rich who, having no pecuniary limit to the expression of their desires, are unable without tremendous force of character to restrict themselves to a single channel long enough to profit by its trenching and deepening and wearing through. While the man of the 20th century has use for instruments, like the radio and the phonograph and the telephone, which have no counterpart in other civilizations, the number of such commodities is in itself limited. No one is better off for having furniture that goes to pieces in a few years or, failing that happy means of creating a fresh demand, goes out of style. No one is better dressed for having clothes so shabbily woven that they are worn out at the end of the season. On the contrary, such rapid consumption is a tax on production, and it tends to wipe out the gains the machine makes in that department. To the extent that people develop personal and aesthetic interests, they are immune to trivial changes in style and they disdain to foster such low demands. Moreover, as Mr. J. A. Hobson has wisely pointed out, if an undue amount of individuality be devoted to the production and consumption of food, clothing, etc., and the conscious, refined cultivation of these tastes, higher forms of individual expression in work and life will be neglected. The second characteristic of vital wants is that they cannot be restricted to the bare elements of food enough to forestall starvation and clothing and shelter enough to satisfy convention and to ward off death by exposure. Life, from the very moment of birth on, requires for its fulfillment goods and services that are usually placed in the department of luxuries. Song, story, music, painting, carving, idle play, drama, all these things lie outside the province of animal necessities, but they are not things which are to be included after the belly is satisfied, they are functions which must be included in human existence even to satisfy the belly, to say nothing of the emotional and intellectual and imaginative needs of man. To put these functions at a distance, to make them the goal of an acquisitive life, or to accept only so much of them as can be canalized into machine goods and sold at a profit, to do this is to misinterpret the nature of life as well as the possibilities of the machine. The fact is that every vital standard has its own necessary luxuries, and the wage that does not include them is not a living wage, nor is the life made possible by bare subsistence a humane life. On the other hand, to set as a goal for universal economic effort, or at least to bait as a temptation, the imbecile standard of expenditure adopted by the rich and the powerful is merely to dangle a wooden carrot before the donkey. He cannot reach the carrot, and if he could, it still would not nourish him. A high scale of expense has no essential relation whatever to a high standard of living, and a plethora of machine-made goods has no essential relation, either, since one of the most essential elements of a good life, a pleasant and stimulating natural environment, both cultivated and primitive, is not a machine-made product. The notion that one implies the other is a figment of the businessman's will to believe. As for what is called comfort, a good part of it, freedom from exertion, the extensive use of mechanical and personal service, leads in fact to an atrophy of function. The ideal is at best a valetudinarian one. The reliance for sensual pleasure upon inanimate objects, sofa pillows, upholstered furniture, sweetmeats, and soft textiles, was one of those devices whereby a bourgeois puritanism, affecting to renounce the flesh and to castigate the body, merely acknowledged them in their most decadent forms, transferring attention from the animate bodies of men and women to objects that simulated them. The Renaissance, which celebrated a vigorous sensual life, scarcely produced a comfortable chair in 200 years, but one has only to look at the women painted by Veronese and Rubens to see how little such inorganic upholstery was needed. As mechanical methods have become more productive, the notion has grown up that consumption should become more voracious. In back of this lies an anxiety lest the productivity of the machine create a glut in the market. The justification of labor-saving devices was not that they actually saved labor but that they increased consumption, whereas, plainly, labor-saving can take place only when the standard of consumption remains relatively stable, so that increases in conversion and in productive facility will be realized in the form of actual increments of leisure. Unfortunately, the capitalistic industrial system thrives by a denial of this condition. It thrives by stimulating wants rather than by limiting them and satisfying them. To acknowledge a goal of consummation would be to place a brake upon production and to lessen the opportunities for profit. Technically speaking, changes in form and style are symptoms of immaturity, they mark a period of transition. The error of capitalism as a creed lies in the attempt to make this period of transition a permanent one. As soon as a contrivance reaches technical perfection, there is no excuse for replacement on the ground of increased efficiency, hence the devices of competitive waste, of shoddy workmanship, and of fashion must be resorted to. Wasteful consumption and shoddy craftsmanship go hand in hand, so that if we value soundness and integrity and efficiency within the machine system, we must create a corresponding stability in consumption. Speaking in the broadest terms, this means that once the major wants of mankind are satisfied by the machine process, our factory system must be organized on a basis of regular annual replacement instead of progressive expansion, not on a basis of premature replacement through debauched workmanship, adulterated materials, and grossly stimulated caprice. The case, as Mr. J. A. Hobson again puts it, is a simple one. A mere increase in the variety of our material consumption relieves the strain imposed upon man by the limits of the material universe, for such variety enables him to utilize a larger proportion of the aggregate of matter. But in proportion as we add to mere variety a higher appreciation of those adaptations of matter which are due to human skill, which we call art, we pass outside the limit of matter and are no longer the slaves of roods and acres and a law of diminishing returns. In other words, a genuine standard, once the vital physical wants are satisfied, tends to change the plane of consumption and therefore to limit, in a considerable degree, the extent of further mechanical enterprise. But mark the vicious paradox of capitalist production. Although the factory system has been based on the doctrine of expanding wants and upon an expanding body of consumers, it has universally fallen short of supplying the normal wants of mankind. Horrified at the utopian notion of limited and normalized wants, and proudly proclaiming on the contrary that wants are insatiable, capitalism has not come within miles of satisfying the most modest standard of normalized consumption. Capitalism, with respect to the working mass of humanity, has been like a beggar that flaunts a hand covered with jewels, one or two of them genuine, whilst it shivers in rags and grabs at a crust of bread. The beggar may have money in the bank, too, but that does not improve his condition. This has been brought out clearly in every factual study that has been made of advanced industrial communities, from Charles Booth's classic survey of London to the thoroughly documented Pittsburgh survey. It has been reinforced once more by Robert Lynn's study of the fairly representative community of Middletown. Oleat does one find? While the poorer inhabitants of Middletown often boast a motor car or a radio set, the lyouses they lived in during their period of putative prosperity often did not have even ordinary sanitary toilet facilities, while the state of the house and the general environment was, factually speaking, that of a slum. When one says that the doctrine of increasing wants must be thrown overboard and the standard of consumption normalized, one does not in fact call for a contraction of our present industrial facilities. In many departments, on the contrary, we are urgently in need of an expansion of them. For the truth is that, despite all boasts of progress and mechanical achievement, despite all fears of surpluses and gluts, the mass of mankind, even in the countries that are technically the most advanced and financially the most prosperous, do not live, and apart from the agricultural population never have had an adequate diet, proper facilities for hygiene, decent dwellings, sufficient means and opportunities for education and recreation. Indeed, in terms of vital norm, a good part of these things have been equally lacking in the spurious standard of expenditure secured by the rich. In most great cities, the urban dwellings of the upper classes, for example, are lacking in sunlight and open spaces, and are almost as inadequate as those of the very poor, so that, under a normalized standard of life, they would in many cases be healthier and happier than they are at present, even though they would lack the illusion of success and power and distinction. To normalize consumption is to erect a standard that no single class, whatever its expenditures, possesses today. But that standard cannot be expressed in terms of any arbitrary sum of money. The $5,000 per individual yearly suggested by Bellamy in the 80s, or the $20,000 suggested by a recent group of technocrats, for the point is that what $5,000 or $20,000 could purchase today for any single individual would not necessarily fulfill the more exacting vital requirements of this standard. And indeed, the higher the vital standard, the less can it be expressed adequately in terms of money, the more must it be expressed in terms of leisure and health and biological activity and aesthetic pleasure, and the more, therefore, will it tend to be expressed in terms of goods and environmental improvements that lie outside of machine production. At the same time, the conception of a normalized consumption acknowledges the end of those princely capitalistic dreams of limitless incomes and privileges and sensuous vulgarities whose possession by the masters of society furnished endless vicarious gratification to their lackeys and imitators. Our goal is not increased consumption but a vital standard, less in the preparatory means, more in the ends, less in the mechanical apparatus, more in the organic fulfillment. When we have such a norm, our success in life will not be judged by the size of the rubbish heaps we have produced, it will be judged by the immaterial and non-consumable goods we have learned to enjoy, and by our biological fulfillment as lovers, mates, parents, and by our personal fulfillment as thinking, feeling men and women. Distinction and individuality will reside in the personality, where it belongs, not in the size of the house we live in the expense of our trappings, or in the amount of labor we can arbitrarily command. Handsome bodies, fine minds, plain living, high thinking, keen perceptions, sensitive emotional responses, and a group life key to make these things possible and to enhance them, these are some of the objectives of a normalized standard. While the animus that led to the expansion of the machine was narrowly utilitarian, the net result of such an economy is to create an antithetical stage, paralleled by the slave civilizations of old, endowed with an abundance of leisure. This leisure, if not vilely misused in the thoughtless production of more mechanical work, either through misplaced ingenuity or a vain consumptive ritual, may eventuate in a non-utilitarian form of society, dedicated more fully to play and thought and social intercourse and all those adventures and pursuits that make life more significant. The maximum of machinery and organization, the maximum of comforts and luxuries, the maximum of consumption, do not necessarily mean a maximum of life efficiency or life expression. The mistake consists in thinking that comfort, safety, absence of physical disease, a plethora of goods are the greatest blessings of civilization, and in believing that as they increase the evils of life will dissolve and disappear. But comfort and safety are not unconditioned goods, they are capable of defeating life just as thoroughly as hardship and uncertainty, and the notion that every other interest, art, friendship, love, parenthood, must be subordinated to the production of increasing amounts of comforts and luxuries is merely one of the superstitions of a money-bent utilitarian society. By accepting this superstition, the utilitarian has turned an elementary condition of existence, the necessity for providing a physical basis for life, into an end. As a result, our machine-dominated society is oriented solely to things, and its members have every kind of possession except self-possession. No wonder that Thoreau observed that its members, even in an early and relatively innocent state of commerce and industry, led lives of quiet desperation. By putting business before every other manifestation of life, our mechanical and financial leaders have neglected the chief business of life, namely, growth, reproduction, development, expression. Paying infinite attention to the invention and perfection of incubators, they have forgotten the egg, and its reason for existence. 7. Basic communism. A normalized mode of consumption is the basis of a rationalized mode of production. If one begins with production as an end in itself, there is nothing within the machine system or the price system to guarantee a sufficient supply of vital goods. The capitalist economy attempted to avoid the necessity for erecting a real standard of life by relying upon the automatic operation of men's private interests, under the spell of the profit motive. All the necessary gains in production, along with the cheapening of the objects sold, were supposed to be an inevitable byproduct of the business of buying cheap and selling where the demand was strongest and the supply scantest. The enlightened self-interest of individual buyers was the guarantee that the right things would be produced, in the right order, at the right time. Lacking any standard for distributing income except on the basis of the gross labor performed and on the bare subsistence necessary to enable the worker to return each day to his job, this system never succeeded in its best days even on its own terms. The history of capitalism is the history of quantity production, overexpansion, greedy private overcapitalization on the basis of an increasing prospective income, the private appropriation of profits and dividends at the expense of the workers, and the vast body of non-capitalist ultimate consumers, all followed, again and again, by a glut of unbought goods, a breakdown, bankruptcy, deflation, and the bitter starvation and depression of the working classes whose original inability to buy back the goods they had produced was always the major factor in this debacle. This system is necessarily unworkable upon its own premises except perhaps under a pre-machine mode of production. For upon capitalist terms, the price of any commodity, roughly speaking, varies inversely as the quantity available at a given moment. This means that as production approaches infinity, the price of a single article must fall correspondingly toward zero. Up to a certain point, the fall in prices expands the market. Beyond that point, the increase in real wealth for the community means a steady decrease in profits per unit for the manufacturer. If the prices are kept up without an expansion of real wages, an overplus occurs. If the price is lowered far enough, the manufacturer cannot, no matter how great his turnover, produce a sufficient margin of profit. Whereas mankind as a whole gains in wealth to the extent that the necessaries of life can, like the air, be had for the asking, the price system crashes into disaster long before this ideal point has been reached. Thus the gains in production under the price system must be diminished or cancelled out, as Veblen mordantly pointed out, by deliberate sabotage on the part of the financier and the businessman. But this strategy has only a temporary effect, for the burden of debt, especially when recapitalized on the basis of a prospective expansion of the population and the market, ultimately outruns the curtailed productive capacities and subjects them to a load they cannot meet. Now, the chief meaning of power conversion and mechanized production lies in the fact that they have created an economy of surplus, which is to say, an economy not adapted to the price system. As more and more work is transferred to automatic machines, the process of displacing workers from industry under the system is the equivalent of disfranchising them as consumers, since, unlike the holders of stock, bonds, and mortgages, they have no claim upon industry under capitalist conventions other than that resulting from their labor. It is useless to talk about temporary absorptions of labor by this or that industry. Part of this absorption by the industries concerned with distribution only increases the overhead and the waste. And apart from this, under the system itself labor has lost both its bargaining power and its capacity to obtain subsistence. The existence of substitute industries sometimes postpones the individual but does not avert the collective day of reckoning. Lacking the power to buy the necessaries of life for themselves, the plight of the displaced workers reacts upon those who remain at work. Presently the whole structure collapses, and even financiers and enterprisers and managers are sucked into the whirlpool their own cupidity, short-sightedness, and folly have created. All this is a commonplace, but it rises, not as a result of some obscure uncontrollable law, like the existence of spots on the sun, but as the outcome of our failure to take advantage by adequate social provision of the new processes of mechanized production. The problem presses for solution, but in one sense it has already been solved. For the better part of 1,000 years, widows, orphans, and prudent sedentary people have been living at ease, buying food, drink, and shelter, without performing any work for the community. Their shares and their insurance payments constitute a first claim upon industry, and as long as there is any production of goods at all, and as long as the present legal conventions are maintained, they are sure of their means of existence. No capitalist talks about this system as one that demoralizes or undermines the self-respect of those who are so supported. Indeed, the small incomes of the rentier classes have been an obvious help in the arts and sciences to their recipients. A Milton, a Shelley, a Darwin, a Ruskin existed by such grace, and one might even show, perhaps, that they had been more beneficial to society at large than the swollen fortunes of the more active capitalists. On the other hand, the small fixed income, though it sets at a distance the worst torments of economic distress, does not completely meet every economic requirement, so, In the case of the young and the ambitious, there is an incentive to productive and professional enterprise, even though the sting of starvation be absent. The extension of this system to the community as a whole is what I mean by basic communism. In recent times, it was first seriously proposed by Edward Bellamy, in a somewhat arbitrary form, in his Utopia, Looking Backward, and it has become plain during the last 50 years that an efficient mechanized system of production can be made serviceable to humanity at large in no other fashion. To make the worker's share in production the sole basis for his claim to a livelihood, as was done even by Marx in the labor theory of value he took over from Adam Smith, is, as power production approaches perfection, to cut the ground from under his feet. In actuality, the claim to a livelihood rests upon the fact that, like the child in a family, one is a member of a community. The energy, the technical knowledge, the social heritage of a community belongs equally to every member of it, since in the large the individual contributions and differences are completely insignificant. The classic name for such a universal system of distributing the essential means of life as described by Plato and more long before Oyvind and Marx is communism, and I have retained it here. But let me emphasize that this communism is necessarily post-Marxian, for the facts and values upon which it is based are no longer the paleo-technic ones upon which Marx founded his policies and programs. Hence communism, as used here, does not imply the particular 19th century ideology, the messianic absolutism, and the narrowly militarist tactics to which the official communist parties usually cling, nor does it imply a slavish imitation of the political methods and social institutions of Soviet Russia, however admirable Soviet courage and discipline may succeed. Differentiation and preference and special incentive should be taken into account in production and consumption only after the security and continuity of life itself is assured. Here and there we have established the beginnings of a basic communism in the provision of water and education and books. There is no rational reason for stopping short any point this side of a normal standard of consumption. Such a basis has no relation to individual capacities and virtues. A family of 6 requires roughly 3 times as much goods as a family of 2, although there may be but 1 wage earner in the first group and 2 in the second. We give at least a minimum of food and shelter and medical attention to criminals who have presumably behaved against the interests of society. Why then should we deny it to the lazy and the stubborn? To assume that the great mass of mankind would belong to the latter category is to forget the positive pleasures of a fuller and richer life. Moreover, under a scientific economy, the amount of grain, fruit, meat, milk, textiles, metals, and raw materials, like the number of houses needed annually for replacement and for the increase of population, can be calculated in the gross in advance of production. It needs only the insurance of consumption to make the tables of production progressively more accurate. Once the standard was established, gains beyond those calculated would be bonuses for the whole community. Such gains, instead of stopping the works, as they do now, would lubricate them, and so far from throwing the mechanism out of gear they would lighten the load for the whole community and increase the margin of time or energy available for the modes of life, rather than for the means. To speak of a planned economy, without such a basic standard of consumption and without the political means of making it prevail, is to mistake the monopolistic sabotage of large-scale capitalist industry for intelligent social control. The foundations of the system of distribution already, I repeat, exist. Schools, libraries, hospitals, universities, museums, baths, lodging houses, gymnasia, are supported in every large center at the expense of the community as a whole. The police and the fire services, similarly, are provided on the basis of need instead of on the ability to pay. Roads, canals, bridges, parks, playgrounds, and even in Amsterdam ferry services are similarly communized. Furthermore, in the most jejune and grudging form, a basic communism is in existence in countries that have unemployment and old age insurance. But the latter measures are treated as means of salvage, rather than as a salutary positive mechanism for rationalizing the production and normalizing the consumptive standards of the whole community. A basic communism, which implies the obligation to share in the work of the community up to the amount required to furnish the basis, does not mean the complete enclosure of every process and the complete satisfaction of every want in the system of planned production. Careful engineers have figured that the entire amount of work of the existing community could be carried on with less than 20 hours work per week for every existing worker, with complete rationalization all along the line, and with the elimination of duplications and parasitisms. Probably less than 20 hours would suffice to produce a far greater quantity of goods than is produced at present. As it is, some 15 million industrial workers supply the needs of 120 million inhabitants of the United States. Limiting rationed production and communized consumption to basic requirements, the amount of compulsory labor would be even less. Under such provisions, technological unemployment would be a boon. Basic communism would apply to the calculable economic needs of the community. It would touch those goods and services which can be standardized, weighed, measured, or about which a statistical computation can be made. Above such a standard, the desire for leisure would compete with the desire for more goods, and here fashion, caprice, irrational choice, invention, special aims, would still perhaps have a part to play, for although all these elements have been grossly overstimulated by capitalism, a residue of them would remain and would have to be provided for in any conceivable economic system. But under a basic communism, these special wants would not operate so as to disorganize production and paralyze distribution. With regard to the basic commodities, there would be complete equality of income, and as consumption became normalized, the basic processes would care, in all probability, for a larger and larger part of the community's needs. On this basis, and so far as I can see on no other basis, can our gains in production and our growing displacement of human labor be realized in benefits for society at large. The alternative to basic communism is the toleration of chaos, either the closing down periodically of the productive plant, and the destruction quaintly called valorization of essential goods, with shifty efforts at imperialist conquest to force open foreign markets, either that or a complete retreat from the machine into a sub-agriculture, subsistence farming, and a sub-industry, subsistence manufacture, which would be far lower in every way than what handicraft industry had provided in the 18th century. If we wish to retain the benefits of the machine, we can no longer afford to deny its chief social implication, namely, basic communism. Not the least advantage of basic communism would be the fact that it would tend to put a brake upon industrial enterprise. But such a brake, instead of being in the form of capitalist sabotage, or in the shocking dislocation of a commercial crisis, would be a gradual lessening of the speed of individual parts and a gearing of the whole organization into a steady routine of productivity. Mr. J. A. Hobson has again put this matter with his usual insight and wisdom. Industrial progress, he says, would undoubtedly be slower under state control, because the very object of such control is to divert a larger proportion of human genius and effort from these occupations' preparatory production to apply them in producing higher forms of wealth. It is not, however, right to assume that progress in the industrial arts would cease under state industry. Such progress would be slower, and would itself partake of a routine character, a slow, continuous adjustment of the mechanism of production and distribution to the slowly changing needs of the community. However forbidding such a prospect looks to the enterpriser of the old order, humanly speaking it would represent a tremendous gain. 8. Socialize creation. During a great part of the history of mankind, from Neolithic times onward, the highest achievements of the race in art and philosophy and literature and technics and science and religion were in the possession of a small caste of people. The technical means of multiplying these achievements were so cumbrous, the hieroglyphics of the Egyptians, the baked slabs of the Babylonian texts, even the handwritten letters on the papyrus or parchment of a later period, that the mastery of the implements of thought and expression was the work of the better part of a lifetime. Those who had manual tasks to perform were automatically excluded from most of the avenues of creation outside their tasks, if they might eventually share in the product created, at second or third hand. The life of the potter or the smith, as Jesus Benseric pointed out with priggish but realistic self-justification, unfit him for the offices of the creative life. This caste monopoly was seriously disrupted during the Middle Ages, partly because Christianity itself was in origin the religion of the lowly and the downtrodden. Not merely was every human creature a worthy subject of salvation, but within the monastery and the church and the university there was a steady recruitment of novices and students from every rank in society, and the powerful Benedictine order, by making manual work itself one of the obligations of a disciplined life, broke down an ancient and crippling prejudice against participation and experiment, as complementary to observation and contemplation, in creative activity. Within the craft guilds the same process took place in reverse direction. Not merely did the journeyman, in qualifying for his craft, get an opportunity to view critically the arts and achievements of other cities, not merely was he encouraged to rise from the menial and mechanical operations of his craft to such aesthetic mastery as it offered, but in the performance of the mysteries and the moralities the worker participated in the aesthetic and religious life of the whole community. Indeed, the writer, like Dante, could have a political status in this society only as the member of a working guild. The humanist movement, by placing an emphasis upon textual scholarship and the dead languages to which this scholarship applied, reinforced the widened separation of classes under capitalism. Unable to obtain the necessary preparatory training, the worker was excluded from the higher cohort of Europe. Even the highest type of technic worker, the artist, and even one of the proudest figures among these artists, Leonardo, felt obliged in his private notes to defend himself against the assumption of the merely literate that his interests in painting and science were somehow inferior. Indifferent to the essential life of men as workers, this culture developed primarily as an instrument of caste power, and only in a feeble and secondary way for the benefit of mankind as a whole. From one end to the other, some of the very best minds of the last 3 centuries, in the midst of their most vigorous creative efforts, have been apologizing for the injustices and perversions of their masters. Thorndike in his History of Science and Medicine in the 15th century notes the degradation that overcame thought when the free cities that Petrarch had known in his youth were enslaved by conquering armies, but the same fact is equally plain in Machiavelli, Hobbes, Leibniz, Hegel, and this tendency of thought reached a certain climax in the misapplication of the Malthus-Darwin theory of the struggle for existence, to justify warfare, the Nordic race, and the dominant position of the bourgeoisie. But while the humanist side of this new culture was fostered on individualistic and caste lines, with a marked bias in favor of the possessing classes, science worked in an opposite direction. The very growth of scientific knowledge made it impossible to confine it, as a secret, to a small group, as astronomy was maintained in earlier civilizations. Not merely this, but science, by systematically utilizing the practical knowledge of artists and physicians in anatomy, of miners and metallurgists in chemistry, kept in touch with the working life of the community. Was it not the predicament of vintners, brewers, and silkworm growers that roused Pasteur to his productive researches in bacteriology? Even when science was remote and by nature esoteric, it was not snobbish. Socialized in method, international in scope, impersonal in animus, performing some of its most hazardous and fruitful feats of thought by reason of its very divorce from immediate responsibility, the sciences have been slowly building up a grand cosmogony in which only one element is still lacking: the inclusion of the spectator and experimenter in the final picture. Unfortunately, the dulling and depressing of the mind that inevitably followed from the division of labor and the bare routine of factory life, have opened an unnatural breach between science and technics and common practice and all the arts that lie outside the machine system. The workers themselves were thrown back upon the rubbish of earlier cultures, lingering in tradition and memory, and they clung to superstitious forms of religion which kept them in a state of emotional tutelage to the very forces that were exploiting them, or else they forfeited altogether the powerful emotional and moral stimulus that a genuine religion contributes to life. This applies likewise to the arts. The peasant and hand worker of the Middle Age was the equal of the artists who carved and painted in his churches and his public halls. The highest art of that time was not too high for the common people, nor was there, apart from the affectations of court poesy, one kind of art for the few and another kind for the many. There were high and low levels in all this art, but the division was not marked by status or pecuniary condition. During the last few centuries, however, popular means vulgar and vulgar means not simply the broadly human, but something inferior and crass and a little dehumanized. In short, instead of socializing the creative activities of society, we have socialized on a great scale only the low counterfeits of those activities, counterfeits that limit and stultify the mind. A Millet, a Van Gogh, a D.A.U. Meyer, a Whitman, a Tolstoy naturally seek the working class for companionship, but they were actually kept alive and rewarded and appreciated chiefly by the very bourgeoisie whose manners they loathed and whose patronage they wished to escape. On the other hand, the experience of New England and New York between 1830 and 1860, when there was still to the westward a great sweep of unappropriated land, shows how fruitful an essentially classless society can be when it is nourished by the very occupations that a caste culture disdains. It is no accident that the Epic of Moby Dick was written by a common sailor, that Walden was written by a pencil maker and surveyor, and that Leaves of Grass was written by a printer and carpenter. Only when it is possible to move freely from one aspect of experience and thought and action to another can the mind follow its complete trajectory. Division of labor and specialization, specialization between occupations, specialization in thought, can be justified only as temporary expedients. Beyond that, as Kropotkin pointed out, lies the necessity of integrating labor and restoring its unity with life. What we need, then, is the realization that the creative life, in all its manifestations, is necessarily a social product. It grows with the aid of traditions and techniques maintained and transmitted by society at large, and neither tradition nor product can remain the sole possession of the scientist or the artist or the philosopher, still less of the privileged groups that, under capitalist conventions, so largely support them. The addition to this heritage made by any individual, or even by any generation, is so small in comparison with the accumulated resources of the past that the great creative artists, like Goethe, are duly humble about their personal importance. To treat such activity as egoistic enjoyment or as property is merely to brand it as trivial, for the fact is that creative activity is finally the only important business of mankind, the chief justification and the most durable fruit of its sojourn on the planet. The essential task of all sound economic activity is to produce a state in which creation will be a common fact in all experience, in which no group will be denied, by reason of toil or deficient education, their share in the cultural life of the community, up to the limits of their personal capacity. Unless we socialize creation, unless we make production subservient to education, a mechanized system of production, however efficient, will only harden into a servile Byzantine formality, enriched by bread and circuses. 9. Work for automaton and amateur. Not work, not production for its own sake or for the sake of ulterior profit, but production for the sake of life and work as the normal expression of a disciplined life, are the marks of a rational economic society. Such a society brings into existence choices and possibilities that scarcely existed so long as work was considered extraneous, and profit or terror of starvation was the chief impetus to labor. The tendency of mechanization, from the 17th century on, has been to standardize the processes of work and to make them capable of machine operation. In power plants with automatic stokers, in advanced textile mills, in stamping factories, in various chemical works, the worker has scarcely any direct part in the process of production. He is, so to say, a machine herd, attending to the welfare of a flock of machines which do the actual work. At best, he feeds them, oils them, mends them when they break down, while the work itself is as remote from his province as is the digestion which fattens the sheep looked after by the shepherd. Such machine tending often calls for alertness, non-repetitious movement, and general intelligence. In discussing Technics, I pointed out that in industries that have advanced to this level the worker has recovered some of the freedom and self-direction that were frustrated in the more incomplete mechanical processes where the worker, instead of being general mechanic and overseer, is merely a substitute for the hand or eye that the machine has not yet developed. But in other processes, such as the straight-line assemblage of the motor factory. For example, the individual worker is part of the process itself, and only a small fraction of him is engaged. Such labor is necessarily servile in character, and no amount of apology or psychological rationalization can make it otherwise, nor can the social necessity for the product mollify the process itself. Our disregard for the quality of work itself, for work as a vital and educational process, is so habitual that it scarcely ever enters into our social demands. Yet it is plain that in the decision as to whether to build a bridge or a tunnel there is a human question that should outweigh the question of cheapness or mechanical feasibility, namely, the number of lives that will be lost in the actual building or the advisability of condemning a certain number of men to spend their entire working days underground supervising tunnel traffic. As soon as our thought ceases to be automatically conditioned by the mind, such questions become important. Similarly, the social choice between silk and rayon is not one that can be made simply on the different costs of production, or the difference in quality between the fibers themselves. There also remains, to be integrated in the decision, the question as to difference in working pleasure between tending silkworms and assisting in rayon production. What the product contributes to the laborer is just as important as what the worker contributes to the product. A well-managed society might alter the process of motor car assemblage, at some loss of speed and cheapness, in order to produce a more interesting routine for the worker. Similarly, it would either go to the expense of equipping dry process cement making plants with dust removers or replace the product itself with a less noxious substitute. Bullion none of these alternatives was avail all, it would drastically reduce the demand itself to the lowest possible level. Now, taken as a whole, including the preparatory processes of scientific investigation and mechanical design, to say nothing of the underlying political organization, industry is potentially a valuable instrument of education. This point, originally stressed by Karl Marx, was well put by Helen Marode when she said, "Industry offers opportunities for creative experience which is social in its processes as well as in its destination." The imaginative end of production does not terminate with the possession of an article, it does not center in the product or in the skill of this or that man, but in the development of commerce and technological processes and the evolution of world acquaintanceship and understanding. Modern machinery, the division of labor, the banking system, methods of communication, make possible real association. But they are real and possible only as the processes are open for the common participation, understanding, and judgment of those engaged in industrial enterprise. They are real and possible as the animus of industry changes from exploitation to a common and associated desire to create. They are real and possible as the individual character of industry gives way before the evolution of social effort. Once the objective of industry is diverted from profit-making, private aggrandizement, crude exploitation, the unavoidable monotonies and restrictions will take a subordinate place, for the reason that the process will be humanized as a whole. This means that compensations for the repressive elements in the industrial routine will take place by adjustments within industry itself, instead of being permitted to heap up there, and to explode disastrously and antisocially in other parts of society. To fancy that such a non-profit system is an impossibility is to forget that for thousands of years the mass of mankind knew no other system. The new economy of needs, replacing the capitalist economy of acquisition, will put the limited corporations and communities of the old economy on a broader and more intelligently socialized basis, but at bottom it will draw upon and canalize similar impulses. Despite all its checkered features and internal contradictions, this is to date perhaps the chief promise held out by Soviet Russia. To the extent that industry must still employ human beings as machines, the hours of work must be reduced. We must determine the number of hours of blank routine per week that is within the limits of human tolerance, beyond which obvious deterioration of mind and spirit sets in. The very fact that purely repetitious work, without choices or variations, seems to agree with morons is enough to warn us of its dangers in relation to human beings of higher grade. But there remain occupations, machine crafts as well as handcrafts, which are interesting and absorbing in their own right, provided that they are not regimented too strictly in the interests of superficial efficiency. In the act of rationalizing and standardizing the methods of production, human engineering will have to weigh the social benefits of increased production with automatic machinery, with a lessened participation and satisfaction upon the part of the worker, against a lower level of production, with a larger opportunity for the worker. It is a shallow technicism to enforce the cheaper product at any price. Where the product is socially valuable and where the worker himself can be completely eliminated, the answer will often, perhaps, favor automatism, but short of this state the decision cannot be lightly made. For no gain in production will justify the elimination of a humane species of work, unless other compensations in the way of work itself are at the same time provided. Money, goods, vacant leisure, cannot possibly make up for the loss of a life of work, although it is plain that money and goods, under our present abstract standards of success, are called upon often to do precisely this. When we begin to rationalize industry organically, that is to say, with reference to the entire social situation, and with reference to the worker himself in all his biological capacities, not merely with reference to the crude labor product and an extraneous ideal of mechanical efficiency, the worker and his education and his environment become quite as important as the commodity he produces. We already acknowledge this principle on the negative side when we prohibit cheap lead glazes in pottery manufacture because the worker's health is undermined by their use, but it has a positive application as well. Not merely should we prohibit work that is bad for the health, we should promote work that is good for the health. It is on these grounds that agriculture and our rural regions may presently get back part of the population that was originally sucked into the ville's tentaculaires by the machine. Labor itself, from spading a garden to mapping the stars, is one of the permanent joys of life. A machine economy that permitted mankind the inane and trivial leisure Mr. H. G. Wells once depicted in The Time Machine, and that most city dwellers are condemned to under capitalist society, particularly during periods of unemployment, would scarcely be worth the effort necessary to lubricate it. Such vacuity, such boredom, such debilitating lack of function do not represent a gain of any kind. The chief benefit the rational use of the machine promises is certainly not the elimination of work. What it promises is something quite different: the elimination of servile work or slavery, those types of work that deform the body, cramp the mind, deaden the spirit. The exploitation of machines is the alternative to the exploitation of degraded men that was practiced throughout antiquity and that was challenged on a large scale, for the first time, in the power economy evolved in the Technic phase. By the completion of our machine organization, we can recover for work the inherent values which it was robbed of by the pecuniary aims and class animosities of capitalist production. The worker, properly extruded from mechanical production as slave, comes back as director, if his instincts of workmanship are still unsatisfied by these managerial tasks. He has, by reason of the power and leisure he now potentially commands, a new status within production as an amateur. The gain in freedom here is a direct compensation for the pressure and duress, for the impersonality, the anonymity, the collective unity of machine production. Beyond the basic needs of production, beyond a normalized and therefore moralized standard of life, beyond the essential communism in consumption I have posited, there lie wants which the individual or the group has no right to demand from society at large, and which, in turn, society has no need to curtail or arbitrarily repress in the individual, so long as the motive of exploitation is removed. These wants may be satisfied by direct effort. To weave or knit clothes by hand, to produce a necessary piece of furniture, to experimentally build an airplane on lines that have not won official approval, these are samples of occupations open to the individual, the household, the small working group, apart from the regular channels of production. Similarly, while the great staples in agriculture, like wheat, hogs, beef, will possibly tend to be the work of large cooperatives, green vegetables and flowers may be raised by individuals on a scale impossible so long as land was privately appropriated and the mass of industrial mankind was packed together in solid areas of house and pavement. As our basic production becomes more impersonal and routinized, our subsidiary production may well become more personal, more experimental, and more individualized. This could not happen under the older regime of handicraft. It was a development not possible before the neotechnic improvements of the machine with electricity as a source of power. For the acquisition of skill necessary for efficient production on a handicraft basis was a tedious process, and the slow tempo of handicraft in the essential occupations did not give a sufficient margin of time for achievement along other lines. Or rather, the margin was achieved by the subordination of the working class and the elevation of a small leisure class. The worker and the amateur represented two different strata. With electric power, a small machine shop may have all the essential devices and machine tools apart from specialized automatic machines that only a large plant could have afforded a century ago, so the worker can regain, even within the machine occupations, most of the pleasure that the machine itself, by its increasing automatism, has been taking away from him. Such workshops connected with schools should be part of the public equipment of every community. The work of the amateur, then, is a necessary corrective to the impersonality, the standardization, the wholesale methods and products of automatic production. But it is likewise an indispensable educational preparation for the machine process itself. All the great advances in machines have been on the basis of the handicraft operations or scientific thought itself, aided and corrected by small-scale manual operations called experiments. As technological tenuousness increases, the diffusion of handicraft knowledge and skill as a mode of education is necessary, both as a safety device and as a means to further insight, discovery, and invention. For the machine cannot know more or do more than the human eye or hand or mind that designs or operates it. Given knowledge of the essential operations, one could reconstruct every machine in the world. But let that knowledge be cut off for so much as a single generation, and all the complicated derivatives would be so much junk. If parts broke and rusted without being immediately replaced, the whole fabric would be in ruins. And there is still a further reason to give an important position to the handcrafts and machine crafts, as subsidiary forms of production, run on a domestic scale. For both safety and flexibility in all forms of industrial production, it is important that we learn to travel light. Our specialized automatic machines, precisely because of their high degree of specialization, lack adaptability to new forms of production. A change in demand, a change in pattern, leads to the wholesale scrapping of very expensive equipment. Wherever demand for products is of an uncertain or variable nature, it is an economy in the long run to use non-specialized machines. This decreases the burden of wasted effort and idle machinery. What is true of the machine is equally true of the worker. Instead of a high degree of specialized skill, an all-round competence is better preparation for breaking through stale routines and for facing emergencies. It is the basic skills, the basic manual operations, the basic discoveries, the basic formulas which must be transmitted from generation to generation. To maintain the superstructure whilst we let the foundations moulder away is to endanger not alone the existence of our complicated civilization but its further development and refinement. For critical changes and adaptations in machines, as in organisms, come not from the differentiated and specialized stock, but from the relatively undifferentiated common ancestor. It was the foot treadle that served what's need for transmitting power in a steam engine. Automatic machines may conquer an ever larger province in basic production, but it must be balanced by the handcrafts and the machine crafts for education, recreation, and experiment. Without the second, automatism would ultimately be a blight on society, and its further existence would be imperiled. 10. Political control. Plan and order are latent in all modern industrial processes, in the working drawing, in the preliminary calculations, in the organization chart, in the time schedule, in the graphs that keep track of production day by day, and even hour by hour, as in a power plant. This graphic and ordered procedure, originating in the separate techniques of the civil engineer, the architect, the mechanical engineer, the forester, and other types of technician, is particularly evident in the neotechnic industries. See, for example, the elaborate economic and social surveys of the Bell Telephone Company, in preparation for establishing or extending services. What is still lacking is the transference of these techniques from industry to the social order at large. The order so far established is too local to be socially effective on a great scale, and apart from Soviet Russia the social apparatus is either antiquated, as in the democratic countries, or renovated in archaic forms, as in the even more backward fascist countries. In short, our political organization is either paleotechnic or pre-technic. Hence the hiatus between the mechanical achievements and the social results. We have now to work out the details of a new political and social order, radically different by reason of the knowledge that is already at our command from any that now exists. And to the extent that this order is the product of scientific thought and humanistic imagination, it will leave a place for irrational and instinctive and traditional elements in society which were flouted, to their own ultimate peril, by the narrow forms of rationalism that prevailed during the past century. The transformation of the worker's status in industry can come about only through a threefold system of control: the functional political organization of industry from within, the organization of the consumers as active and self-regulating groups, giving rational expression to collective demands, and the organization of industries as units within the political framework of cooperating states. The internal organization implies the transformation of the trade union from a bargaining organization, seeking special privileges apart from the industry or the working class as a whole, into a producing organization, concerned with establishing a standard of production, a humane system of management, and a collective discipline which will include every member, from such unskilled workers who may enter as apprentices up to the administrators and engineers. In the 19th century the mass of workers, cowed, uneducated, unskilled in cooperation, were only too willing to permit the capitalists to retain the responsibilities for financial management and production. Their unions sought for the most part merely to obtain for the worker a greater share of the income, and somewhat more favorable conditions of labor. The enterpriser, in turn, looked upon the management of his industry as a God-given right of ownership. To hire and fire, to stop and start, to build and destroy were special rights which neither the worker nor the government could encroach upon. The development of laws restricting the hours of labor and establishing minimum sanitary conditions, the development of public control of important public utilities, the growth of cartels and semi-monopolistic trade organizations under government supervision, have broken down the self-sufficiency of the manufacturer. But these measures, though struggled for by the worker, have done little to increase his dynamic participation in the management of industry itself. While here and there moves have been made toward a more positive integration of labor, as in the Baltimore and Ohio Railroad machine shops and in certain sections of the garment industry in America, for the most part the worker has no responsibility beyond his detailed job. Until the worker emerges from a state of spiritless dependence there can be no large gain either in collective efficiency or in social direction. By its nature autonomy is something that cannot be handed from above. For the functional organization of industry there must be collective discipline, collective efficiency, above all collective responsibility. Along with this must go a deliberate effort to produce engineering and scientific and managerial talent from within the ranks of the workers themselves, in addition to enlisting the services of more socialized members of this group, who are already spiritually developed beyond the lures and opportunities of the financial system to which they are attached. Without growth within the factory of effective units for work, the position of the worker, no matter what the ostensible nature of the political system, must remain a precarious and servile one, for the increase of mechanization vitiates his bargaining power, the increasing ranks of the unemployed tend automatically to beat down his wages, and the periodical disorganization of industry cancels out any small gains he may momentarily make. Plainly, such control, such autonomy, will not be achieved without a internal struggle for training and knowledge, and an external struggle against the weapons and the instruments handed down from the past. In the long run this struggle involves a fight not only against a sessile administrative bureaucracy Whitley and the trade unions themselves, more importantly, it involves an outright battle with the guardians of capitalism. Fortunately, the moral bankruptcy of the capitalist system is an opportunity as well as an obstacle, a decayed institution, though more dangerous to live with than a sound one, is easier to remove. The victory over the possessing classes is not the goal of this struggle, that is but a necessary incident in the effort to achieve a solidly integrated and socialized basis for industry. The struggle for power is a futile one, no matter who is victorious, unless it is directed by the will to function. Fascism has effaced the workers' attempts to overwhelm the capitalist system in Italy and Germany because ultimately the workers had no plan for carrying the fight beyond the stage of fighting. The point to remember, however, is that the power needed to operate and to transform our modern techniques is something other than physical force. The whole organization of modern industry is a complicated one, dependent upon a host of professionalized skills that link into each other, dependent likewise upon the faith and goodwill of those interchanging services, data, and calculations. Unless there is an inner coherence here, no amount of supervision will ensure against knavery and non-cooperation. This society cannot be run by brute force or by servile truculent skill backed by brute force. In the long run such habits of action are self-defeating. The principle of functional autonomy and functional responsibility must be observed at every stage of the process, and the contrary principle of class domination, based upon a privileged status whether that class be aristocratic or proletarian, is technically and socially inefficient. Moreover, techniques and science demand autonomy and self-control, that is, freedom, in the realm of thought. The attempt to limit this functional autonomy by the erection of special dogmas, as the Christians limited it in the early days of Christianity, will cause a fall into cruder methods of thinking, inimical to the essential basis of both techniques and modern civilization. As industry advances in mechanization, a greater weight of political power must develop outside it than was necessary in the past. To counterbalance the remote control and the tendency to continue along the established grooves of industrial effort, there must arise a collective organization of consumers for the sake of controlling the kind and quantity and distribution of the product itself. In addition to the negative check to which all industry is subject, the struggle for existence between competing commodities, there must be a positive mode of regulation which will ensure the production of desirable types of commodities. Without such organization, even our semi-competitive commercial regime is slow in adapting itself to demand. At the very moment that it changes, from month to month and year to year, the superficial styles of its products, it resists the introduction of fresh ideas, as the American furniture industry for long and stubbornly resisted the introduction of non-period furniture. Under a more stable non-competitive organization of industry, consumers' groups for formulating and imposing demands will be even more important for rational production. Without such groups, any central agency for determining lines of production and quotas must necessarily be arbitrary and inefficient. Meanwhile, the erection of scientific scales of performance and material quality so that goods will be sold on the basis of actual value and service, rather than on the basis of clever packaging and astute advertising, is a natural corollary on the consumer's side to the rationalization of industry. The failure to use the existing laboratories for determining such standards, like the National Bureau of Standards in the United States, for the benefit of the entire body of consumers, is one of the most impudent miscarriages of knowledge under the capitalist system. The third necessary element of political control lies in the possession of land, capital, credit, and machines. In America, which has reached an advanced stage of both mechanical improvement and financial organization, almost 50% of the capital invested in industry, and something over 40% of the income of the nation, is concentrated in 200 corporations. These corporations are so huge and have their capital in so many shares, that in no one of them does any particular person control by ownership more than 5% of the capital invested. In other words, administration and ownership, which had a natural affiliation in small-scale enterprise, are now almost completely divorced in the major industries. This condition was astutely used during the last 2 decades, by the bankers and administrators of American industry, for example, to appropriate for their private advantage a lion's share of the income, by a process of systematic pillage through recapitalization and bonuses. Since the present shareholders of industry have already been dispossessed by the machinations of capitalism itself, there would be no serious jar if the system were put on a rational basis, by placing the banking functions directly under the state, and collecting capital directly out of the earnings of industry instead of permitting it to be rooted in a roundabout fashion through acquisitive individuals, whose knowledge of the community's needs is empirical and unscientific and whose public interest is vitiated by private concerns if not by outright antisocial animus. Such a change in the financial structure of our major instruments of production is a necessary prelude to humanizing the machine. Naturally, this means a revolution, whether it shall be humane or bloody, whether it shall be intelligent or brutal, whether it shall be accomplished smoothly, or with a series of violent shocks and jerks and catastrophes, depends to a large extent upon the quality of mind and the state of morals that exists among the present directors of industry and their opponents. Now, the necessary impulses towards such a change are already apparent within the bankrupt structure of capitalist society. During its seizures of paralysis, it openly begs for the state to come in and rescue it and put it once more on its feet. Once the wolf is driven away, capitalism becomes brave again, but at scarcely any point during the last century has it been able to live without the help of state subsidies, state privileges, state tariffs, to say nothing of the aid of the state in subduing and regimenting the workers when the two groups have broken out into open warfare. Laissez-faire is in fact advocated and preached by capitalism only during those rare moments when it is doing well without the help of the state, but in its imperialist phase, laissez-faire is the last thing that capitalism desires. What it means by that slogan is not hands-off industry but hands-off profits. In concluding his monumental survey of capitalism, Mumford looks upon 1914 as a turning point for capitalism itself. The signs of the change are the impregnation of capitalistic modes of existence with normative ideas, the displacement of the struggle for profit as the sole condition of orientation in industrial relations, the undermining of private competition through the principle of understandings, and the constitutional organization of industrial enterprise. These processes, which have actually begun under capitalism, have only to be pushed to their logical conclusions to carry us beyond the capitalist order. Rationalization, standardization, and above all, rationed production and consumption, on the scale necessary to bring up to a vital norm the consumptive level of the whole community. These things are impossible on a sufficient scale without a socialized political control of the entire process. If such a control cannot be instituted with the cooperation and intelligent aid of the existing administrators of industry, it must be achieved by overthrowing them and displacing them. The application of new norms of consumption, as in the housing of workers, has during the last 30 years won the passive support, sometimes subsidies drawn from taxation, of the existing governments of Europe, from conservative London to communistically bent Moscow. But such communities, while they have challenged and supplemented capitalist enterprise, are merely indications of the way in which the wind is blowing. Before we can replan and reorder our entire environment on a scale commensurate with our human needs, the moral and legal and political basis of our productive system will have to be sharply revised. Unless such a revision takes place, capitalism itself will be eliminated by internal rot. Lethal struggles will take place between states seeking to save themselves by imperialist conquest, as they will take place between classes within the state, jockeying for a power which will take the form of brute force just to the extent that society's grip on the productive mechanism itself is weakened. 11. The diminution of the machine. Most of the current fantasies of the future, which have been suggested by the triumph of the machine, are based upon the notion that our mechanical environment will become more pervasive and oppressive. Within the past generation, this belief seemed justified. Mr. H. G. Wells's earlier tales of the War of the Worlds and When the Sleeper Wakes predicted horrors, great and little, from gigantic aerial combats to the blatant advertisement of salvation by go-getting Protestant churches, horrors that were realized almost before the words had left his mouth. The belief in the greater dominance of mechanism has been reinforced by a vulgar error in statistical interpretation, the belief that curves generated by a past historic complex will continue without modification into the future. Not merely do the people who hold these views imply that society is immune to qualitative changes, they imply that it exhibits uniform direction, uniform motion, and even uniform acceleration, a fact which holds only for simple events in society and for very minor spans of time. The fact is that social predictions that are based upon past experience are always retrospective, they do not touch the real future. That such predictions have a way of justifying themselves from time to time is due to another fact, namely that in what Professor John Dewey calls judgments of practice, the hypothesis itself becomes one of the determining elements in the working out of events. To the extent that it is seized and acted upon, it weights events in its favor. The doctrine of mechanical progress doubtless had such a role in the 19th century. Only at reason is there to believe that the machine will continue to multiply indefinitely at the rate that characterized the past, and that it will take over even more territory than it has already conquered. While the inertia of society is great, the facts of the matter lend themselves to a different interpretation. The rate of growth in all the older branches of machine production has in fact been going down steadily. Mr. Bassett Jones even holds that this is generally true of all industry since 1910. In those departments of mechanical industry that were well established by 1870, like the railroad and the textile mill, this slowing down applies likewise to the critical inventions. Have not the conditions that forced and speeded the earlier growth, namely, the territorial expansion of Western civilization and the tremendous increase in population, been diminishing since that point? Certain machines, moreover, have already reached the limit of their development, certain areas of scientific investigation are already completed. The printing press, for example, reached a high pitch of perfection within a century after its invention. A whole succession of later inventions, from the rotary press to the linotype and monotype machines, while they have increased the pace of production, have not improved the original product. The finest page that can be produced today is no finer than the work of the 16th century printers. The W-8 turbine is now 90% efficient. We cannot, on any count, add more than 10% to its efficiency. Telephone transmission is practically perfect, even over long distances. The best the engineers can now do is to multiply the capacity of the wires and to extend the interlinkages. Distant speech and vision cannot be transmitted faster than they are transmitted today by electricity. What gains W-E can make are in cheapness and ubiquity. In short, there are bounds to mechanical progress within the nature of the physical world itself. It is only by ignoring these limiting conditions that a belief in the automatic and inevitable and limitless expansion of the machine can be retained. And apart from any wavering of interest in the machine, a general increase in verified knowledge in other departments than the physical sciences already threatens a large curtailment of mechanical practices and instruments. It is not a mystic withdrawal from the practical concepts of the world that challenges the machine so much as a more comprehensive knowledge of phenomena to which our mechanic contrivances were only partial and ineffective responses. Just as, within the domain of engineering itself, there has been a growing tendency toward refinement and efficiency through a nicer interrelation of parts, so in the environment at large the province of the machine has begun to shrink. Only we think and act in terms of an organic whole, rather than in terms of abstractions, when we are concerned with life in its full manifestation, rather than with the fragment of it that seeks physical domination and that projects itself in purely mechanical systems. We will no longer require from the machine alone what we should demand through a many-sided adjustment of every other aspect of life. A finer knowledge of physiology reduces the number of drugs and nostrums in which the physician places confidence. It also decreases the number and scope of surgical operations, those exquisite triumphs of machine technics, so that although refinements in technique have increased the number of potential operations that can be resorted to, competent physicians are tempted to exhaust the resources of nature before utilizing a mechanical shortcut. In general, the classic methods of Hippocrates have begun to displace, with a new certitude of conviction, both the silly potions prescribed in Moliere's Imaginary Invalid and the barbarous intervention of Mr. Surgeon Cuticle. Similarly, a sounder notion of the human body has relegated to the scrap heap most of the weight-lifting apparatus of late Victorian gymnastics. The habit of doing without hats and petticoats and corsets has, in the past decade, thrown whole industries into limbo. A similar fate, through the more decent attitude toward the naked human body, threatens the bathing suit industry. Finally, with a great part of the utilities, like railroads, power lines, docks, port facilities, automobiles, concrete roads which we constructed so busily during the last 100 years, we are now on a basis where repair and replacement are all that is required. As our production becomes more rationalized, and as population shifts and regroups in better relationship to industry and recreation, new communities designed to the human scale are being constructed. This movement, which has been taking place in Europe during the last generation, is a result of pioneering work done over a century from Robert Owen to Ebenezer Howard. As these new communities are built up, the need for the extravagant mechanical devices like subways, which were built in response to the disorganization and speculative chaos of the megalopolis, will disappear. In a word, as social life becomes mature, the social unemployment of machines will become as marked as the present technological unemployment of men. Just as ingenious and complicated mechanisms for inflicting death used by armies and navies are marks of international anarchy and painful collective psychoses, so are many of our present machines the reflexes of poverty, ignorance, disorder. The machine, so far from being a sign in our present civilization of human power and order, is often an indication of ineptitude and social paralysis. Any appreciable improvement in education and culture will reduce the amount of machinery devoted to multiplying the spurious mechanical substitutes for knowledge and experience now provided through the channels of the motion picture, the tabloid newspaper, the radio, and the printed book. So, too, any appreciable improvement in the physical apparatus of life, through better nutrition, more healthful housing, sounder forms of recreation, greater opportunities for the natural enjoyments of life, will decrease the part played by mechanical apparatus in salvaging wrecked bodies and broken minds. Any appreciable gain in personal harmony and balance will be recorded in a decreased demand for compensatory goods and services. The passive dependence upon the machine that has characterized such large sections of the Western world in the past was in reality an abdication of life. Once we cultivate the arts of life directly, the proportion occupied by mechanical routine and by mechanical instruments will again diminish. Our mechanical civilization, contrary to the assumption of those who worship its external power the better to conceal their own feeling of impotence, is not an absolute. All its mechanisms are dependent upon human aims and desires, many of them flourish in direct proportion to our failure to achieve rational social cooperation and integrated personalities. Hence we do not have to renounce the machine completely and go back to handicraft in order to abolish a good deal of useless machinery and burdensome routine. We merely have to use imagination and intelligence and social discipline in our traffic with the machine itself. In the last century or two of social disruption, we were tempted by an excess of faith in the machine to do everything by means of it. We were like a child left alone with a paintbrush who applies it impartially to unpainted wood, to varnished furniture, to the tablecloth, to his toys, and to his own face. When, with increased knowledge and judgment, we discover that some of these uses are inappropriate, that others are redundant, that others are inefficient substitutes for a more vital adjustment, we will contract the machine to those areas in which it serves directly as an instrument of human purpose. The last, it is plain, is a large area, but it is probably smaller than that now occupied by the machine. One of the uses of this period of indiscriminate mechanical experiment was to disclose unsuspected points of weakness in society itself. Like an old-fashioned menial, the arrogance of the machine grew in proportion to its master's feebleness and folly. With a change in ideals from material conquest, wealth, and power to life, culture, and expression, the machine, like the menial with a new and more confident master, will fall back into its proper place, our servant, not our tyrant. Quantitatively, then, we shall probably be less concerned with production in future than we were forced to be during the period of rapid expansion that lies behind us. So, too, we shall probably use fewer mechanical instruments than we do at present, although we shall have a far greater range to select from, and shall have more skillfully designed, more finely calibrated, more economical and reliable contrivances than we now possess. The machines of the future, if our present techniques continues, will surpass those in use at present as the Parthenon surpassed a Neolithic wood hut. The transformation will be both toward durability and to refinement of forms. The dissociation of production from the acquisitive life will favor technical conservatism on a high level rather than a flashy experimentalism on a low level. But this change will be accompanied by a qualitative change in interest, too, in general a change from mechanical interest to vital and cycle and social interests. This potential change in interest is generally ignored in predictions about the future of the machine. Yet once its importance is grasped, it plainly alters every purely quantitative prediction that is based upon the assumption that the interests which for 3 centuries have operated chiefly within a mechanical framework will continue to remain forever within that framework. On the contrary, proceeding under the surface in the work of poets and painters and biological scientists, in a Goethe, a Whitman, a von Müller, a Darwin, a Bernard, there has been a steady shift in attention from the mechanical to the vital and the social. More and more, adventure and exhilarating effort will lie here, rather than within the already partly exhausted field of the machine. Such a shift will change the incidence of the machine and profoundly alter its relative position in the whole complex of human thought and activity. Shaw, in his Back to Methuselah, put such a change in a remote future, and risky though prophecy of this nature be, it seems to me that it is probably already insidiously at work. That such a movement could not take place, certainly not in science and its technical applications, without a long preparation in the inorganic realm is now fairly obvious. It was the relative simplicity of the original mechanical abstractions that enabled us to develop the technique and the confidence to approach more complicated phenomena. But while this movement toward the organic owes a heavy debt to the machine, it will not leave its parent in undisputed possession of the field. In the very act of enlarging its dominion over human thought and practice, the machine has proved to a great degree self-eliminating. Its perfection involves in some degree its disappearance as a communal water system. Once built, involves less daily attention and less expense on annual replacements than would 100,000 domestic wells and pumps. This fact is fortunate for the race. It will do away with the necessity, which Samuel Butler satirically pictured in Eruhan, for forcefully extirpating the dangerous troglodytes of the earlier mechanical age. The old machines will in part die out, as the great saurians died out, to be replaced by smaller, faster, brainer, and more adaptable organisms, adapted not to the mine, the battlefield, and the factory, but to the positive environment of life. 12. Toward a dynamic equilibrium. The chief justification of the gigantic changes that took place during the 19th century was the fact of change itself. No matter what happened to human lives and social relations, people looked upon each new invention as a happy step forward toward further inventions, and society went on blindly like a caterpillar tractor, laying down its new road in the very act of lifting up the old one. The machine was supposed to abolish the limits of movement and of growth. Machines were to become bigger, engines were to become more powerful, speeds were to become faster, mass production was to multiply more vastly, the population itself was to keep on increasing indefinitely until it finally outran the food supply or exhausted the soil of nitrogen. So went the 19th century myth. Today, the notion of progress in a single line without goal or limit seems perhaps the most parochial notion of a very parochial century. Limits in thought and action, norms of growth and development, are now as present in our consciousness as they were absent to the contemporaries of Herbert Spencer. In our techniques, countless improvements of course remain to be made, and there are doubtless numerous fresh fields still to be opened, but even in the realm of pure mechanical achievement we are already within sight of natural limits, not imposed by human timidity or lack of resources or immature techniques, but by the very nature of the elements with which we work. The period of exploration and unsystematic, sporadic advance, which seemed to the 19th century to embody the essential characteristics of the new economy, is rapidly coming to an end. We are now faced with the period of consolidation and systematic assimilation. Western civilization as a whole, in other words, is in the condition that new pioneering countries like the United States found themselves in, once all their free lands had been taken up and their main lines of transportation and communication laid out. It must now begin to settle down and make the most of what it has. Our machine system is beginning to approach a state of internal equilibrium. Dynamic equilibrium, not indefinite progress, is the mark of the opening age. Balance, not rapid one-sided advance. Conservation, not reckless pillage. The parallel between Neolithic and Neotechnic times holds even here, for the main advances which were consolidated in Neolithic times remain stable, with minor variations within the pattern, for between 2500 and 3500 years. Once we have generally reached a new technical plateau, we may remain on that level with very minor ups and downs for thousands of years. What are the implications of this approaching equilibrium? First, equilibrium in the environment. This means first the restoration of the balance between man and nature. The conservation and restoration of soils, the regrowth wherever this is expedient and possible, of the forest cover to provide shelter for wildlife and to maintain man's primitive background as a source of recreation, whose importance increases in proportion to the refinement of his cultural heritage. The use of tree crops where possible as substitutes for annuals, and the reliance upon kinetic energy, sun, falling water, wind instead of upon limited capital supplies. The conservation of minerals and metals, the larger use of scrap metals. The conservation of the environment itself as a resource, and the fitting of human needs into the pattern formed by the region as a whole, hence the progressive restoration out of such unbalanced regions as the over-urbanized metropolitan areas of London and New York. Is it necessary to point out that all this marks the approaching end of the miner's economy? Not mine and move, but stay and cultivate are the watchwords of the new order. Is it also necessary to emphasize that with respect to our use of metals, the conservative use of the existing supply will lower the importance of the mine in relation to other parts of the natural environment? Second, equilibrium in industry and agriculture. This has rapidly been taking place during the last 2 generations in the migration of modern techniques from England to America and to the rest of Europe, and from all these countries in turn to Africa and Asia. No one center is any longer the home of modern industry or its sole focal point. The finest work in rapid motion picture photography has been done in Japan, and the most astounding instrument of cheap mass production is the Bata shoe factories of Czechoslovakia. The more or less uniform distribution of mechanical industry over every portion of the planet tends to produce a balanced industrial life in every region, ultimately a state of balance over the earth itself. A similar advance remains to be worked out more largely for agriculture. With the decentralization of population into new centers, encouraged by motor and aerial transportation and by giant power, and with the application of scientific methods to the culture of soils and the processes of agriculture, as so admirably practiced today in Belgium and Holland, there is a tendency to equalize advantage between agricultural regions. With economic regionalism, the area of market gardening and mixed farming already favored by the scientific transformation of our diet will widen again, and specialized farming for world export will tend to diminish except where, as in industry, some region produces specialties that cannot easily be duplicated. Once the regional balance between industry and agriculture is worked out in detail, production in both departments will be on a more stable basis. This stability is the technical side of the normalization of consumption with which I have already dealt. Since at bottom the profit motive arose out of and was furthered by uncertainty and speculation, whatever stability specialized capitalism had in the past rested on its capacity for promoting change, and taking advantage of it. Its safety rested upon its progressive tendency to revolutionize the means of production, promote new shifts in population, and take advantage of the speculative disorder. The equilibrium of capitalism, in other words, was the equilibrium of chaos. Per contra, the forces that work toward a normalization of consumption, toward a planned and rationed production, toward a conservation of resources, toward a planned distribution of population are in sharp opposition by reason of their essential techniques to the methods of the past, hence an inherent conflict between this technology and the dominant capitalist methods of exploitation. As we approach an industrial and agricultural equilibrium, part of the raison d'etre of capitalism itself will vanish. Third, equilibrium in population. There are parts of the Western world in which there is a practical balance between the number of births and deaths. Most of these countries, France, Great Britain, the United States, the Scandinavian countries, are in a relatively high state of technical and cultural development. The blind animal pressure of births, responsible for so many of the worst features of 19th century development, is now characteristic in the main of backward countries, countries in a state of political or technical inferiority. If equilibrium takes place here during the next century, one may look forward to a rational resettlement of the entire planet into the regions most favorable to human habitation. An era of deliberate recolonization will take the place of those obstreperous and feudal conquests which began with the explorations of the Spaniards and the Portuguese in the 16th century, and which have continued without any essential change down to the most recent raids of the Japanese. Such an internal resettlement is already taking place in many countries: the movement of industries into southern England, the development of the French Alps, the settlement of new farmers in Palestine and Siberia, are first steps toward achieving a state of equilibrium. The balancing off of the birth rate and death rate, and the balancing off of rural and urban environments with the wholesale wiping out of the blighted industrial areas inherited from the past, are all part of a single integration. This state of balance and equilibrium, regional, industrial, agricultural, communal, will work a further change within the domain of the machine itself, a change of tempo. The temporary fact of increasing acceleration, which seemed so notable to Henry Adams when he surveyed the progress from 12th century unity to 20th century multiplicity, the fact which was later accompanied by a belief in change and speed for their own sake, will no longer characterize our society. It is not the absolute speed assumed by any part of the machine system that indicates efficiency. What is important is the relative speed of the various parts with a view to the ends to be accomplished, namely, the maintenance and development of human life. Efficiency, even on the technical level alone, means a gearing together of the various parts so that they may deliver the correct and the predictable amounts of power, goods, services, utilities. To achieve this efficiency, it may be necessary to lower the tempo rather than to increase it in this or that department, and as larger portions of our days go to leisure and smaller portions to work, as our thinking becomes synthetic and related, instead of abstract and pragmatic, as we turn to the cultivation of the whole personality instead of centering upon the power elements alone, as all these things come about, we may look forward to a slowing of the tempo throughout our lives, even as we may look forward to a lessening of the number of unnecessary external stimuli. Mr. H. G. Wells has characterized the approaching period as the era of rebuilding. No part of our life, our thought, or our environment can escape that necessity and that obligation. The problem of tempo, the problem of equilibrium, the problem of organic balance, in back of them all the problem of human satisfaction and cultural achievement, these have now become critical and all-important problems of modern civilization. To face these problems, to evolve appropriate social goals and to invent appropriate social and political instruments for an active attack upon them, and finally to carry them into action, here are new outlets for social intelligence, social energy, social goodwill. 13. Summary and prospect. We have studied the origins, the advances, the triumphs, the lapses, and the further promises of modern technics. We have observed the limitations the Western European imposed upon himself in order to create the machine and project it as a body outside his personal will. We have noted the limitations that the machine has imposed upon men through the historic accidents that accompanied its development. We have seen the machine arise out of the denial of the organic and the living, and we have in turn marked the reaction of the organic and the living upon the machine. This reaction has two forms. One of them, the use of mechanical means to return to the primitive, means a throwback to lower levels of thought and emotion, which will ultimately lead to the destruction of the machine itself and the higher types of life that have gone into its conception. The other involves the rebuilding of the individual personality and the collective group, and the reorientation of all forms of thought and social activity toward life. This second reaction promises to transform the nature and function of our mechanical environment and to lay wider and firmer and safer foundations for human society at large. The issue is not decided, the results are not certain, and where in the present chapter I have used the prophetic form, I have not been blind to the fact that while all the tendencies and movements I have pointed to are real, they are still far from being supreme, so when I have said it will, I have meant we must. In discussing the modem techniques, we have advanced as far as seems possible in considering mechanical civilization as an isolated system. The next step toward reorienting our techniques consists in bringing it more completely into harmony with the new cultural and regional and societal and personal patterns we have coordinately begun to develop. It would be a gross mistake to seek wholly within the field of techniques for an answer to all the problems that have been raised by techniques. For the instrument only in part determines the character of the symphony or the response of the audience. The composer and the musicians and the audience have also to be considered. What shall we say of the music that has so far been produced? Looking backward on the history of modern techniques, one notes that from the 10th century onward the instruments have been scraping and tuning. One by one, before the lights were up, new members had joined the orchestra, and were straining to read the score. By the 17th century the fiddles and the woodwind had assembled, and they played in their shrill high notes the prelude to the great opera of mechanical science and invention. In the 18th century die-brasses joined the orchestra, and the opening chorus, with the metals predominating over the wood, rang through every hall and gallery of the Western world. Finally, in the 19th century, the human voice itself, hitherto subdued and silent, was timidly sounded through the systematic dissonances of the score, at the very moment that imposing instruments of percussion were being introduced. Have we heard the complete work? Far from it. All that has happened up to now has been little more than a rehearsal, and at last, having recognized the importance of the singers and the chorus, we will have to score the music differently, subduing the insistent brasses and the kettle drums and giving more prominence to the violins and the voices. But if this turns out to be so, our task is even more difficult, for we will have to rewrite the music in the act of playing it, and change the leader and regroup the orchestra at the very moment that we are recasting the most important passages. Impossible. No, for however far modern science and techniques have fallen short of their inherent possibilities, they have taught mankind at least one lesson: nothing is impossible. Inventions. 1. Introduction. This list of inventions makes no pretense to being exhaustive. It is meant merely to provide an historical framework of technical facts for the social interpretations of the preceding pages. While I have attempted to choose the more important inventions and processes, I have doubtless left out many that have equal claim to appear. The most comprehensive guide to this subject are the compilations by Darmstaedter and by Feldhaus, but I have drawn from a variety of sources. The dates and attributions of many inventions, as every technician knows, must remain somewhat arbitrary. Unlike a human baby, one often cannot say at what date an invention is born. Frequently, indeed, what was apparently a stillbirth may be resuscitated a few years after its first unhappy appearance. And again, with inventions the family lineage often is hard to establish, for, as W. F. Ogburn and Dorothy S. Thomas have demonstrated, inventions are often practically simultaneous, the result of a common heritage and a common need. While I have endeavored to be both accurate and impartial in giving the date of the invention and the name of the putative inventor, the reader should keep in mind that these data are offered only for his convenience in looking further. Instead of a single date, one finds usually a series of dates which mark progress from the state of pure fantasy to concrete realization in the form that has been most acceptable to the capitalist mores, that of a commercial success. As a result of these mores, far too much stress has usually been laid upon the individual who put the title of private ownership upon this social process by taking out patent rights on his invention. But observe, inventions are often patented long before they can be practicably used, and, on the other hand, they are often ready for use long before industrial enterprisers are willing to take advantage of them. Since modern science and technology are part of the common stock of Western civilization, I have refused to attribute inventions to one country or another, and I have done my best to avoid an unconscious bias in weighting the list in behalf of my own country, trusting by my good example to shame the scholars who permit their most childish impulses to flaunt themselves in this field. If any bias or misinformation still exists, I will welcome corrections. Technics and Civilization. 2. List of inventions. Summary of the existing techniques before the 10th century. Fire, its application in furnaces, ovens, kilns. The simple machines, inclined plane, screw, etc. Thread, cord, rope. Spinning and weaving. Advanced agriculture, including irrigation, terrace cultivation, and soil regeneration, lapsed in Northern Europe. Cattle breeding and the use of the horse for transport. Glass making, pottery making, basket making. Mining, metallurgy, and smithing, including the working of iron. Power machines, water mills, boats with sails, probably windmills. Machine tools, bow drills and lathes. Handicraft tools with tempered metal cutting edges. Paper. Water clocks. Astronomy, mathematics, physics, and the tradition of science. In Northern Europe, a scattered and somewhat decayed technological tradition based on Rome, but south and east, from Spain to China, an advanced and still active asterisk technology, whose ideas were filtering into the west and north through traders, scholars, and soldiers. 10th century. Use of water clocks and water mills. The iron horseshoe and an effective harness for horses. Multiple yoke for oxen. Possible invention of the mechanical clock. 999, painted glass windows in England. 11th century. 1041 to 49, movable type, Pai Sheng, 1050, first real lenses, Alhazen, 1065, Oliver of Malmesbury attempts. Flight 1080, decimal system, Azachel. 12th century. Military use of gunpowder in China. The magnetic compass, known to the Chinese 1160 BC, comes into Europe, via the Arabs. 1105, first recorded windmill in Europe, France, 1100, Bologna University 1118, cannon used by Moors 1144, paper, Spain, 1147, use of woodcuts for capital letters. Benedictine Monastery at Engelberg, 1180, fixed steering rudder 1188, bridge at Avignon. 18 stone arches 3,000 feet long. 1190, paper mill, at Hérault, France, 1195, magnetic compass in Europe, English citation. 13th century. Mechanical clocks invented. 1232, hot air balloons, in China. 1247, cannon used in defense of Seville. 1269, pivoted magnetic compass, Petrus Peregrinus. 1270, treatise on lenses, Vitellio. Compound lenses, Roger Bacon. 1272, silk reeling machine, Bologna. 1280, Opus Ruralium Commodorum Compendium of Agricultural Practice, Petrus de Crescentis. 1285 to 1299, spectacles. 1289, block printing, Ravenna. 1290, paper mill, Ravensburg. 1298, spinning wheel. 14th century. Mechanical clock becomes common. Water power used to create draft for blast furnace, makes cast iron possible. Treadle loom, inventor unknown. Invention of rudder and beginning of canalization. Improved glass making. 1300, wooden type, Turkestan. Inventions. 439. 1315. 1320. 1322, 1324. 1330, 1345. 1338, 1350. 1370. 1382, 1390, 1390. Beginnings of scientific anatomy. Through dissection of human body, Raimondo de Luzzi of Bologna, water-driven iron works, near Dobry Lug sawmill at Augsburg. Cannon gunpowder, 846 AD. Magnus Gricus, crane at Leinenberg, division of hours and minutes. Into 60s guns wire pulling machine, Rudolf of Nuremberg, perfected mechanical clock, von Wick, giant cannon 4.86 meters long, metal types, Korea, paper mill. 1470. 15th century. Use of eye windmill for land drainage. Invention of turret eye windmill. Ivy-rojection of knitting. Iron drill for boring cannon. Trip hammer. 2-masted and 3-masted ship. 1402, oil painting, Brothers, Van Eyck. 1405, diving suit, Conrad Kaiser von Eichstadt. 1405, infernal machine, Conrad Kaiser von Eichstadt. 1409, first book in movable type, Korea. 1410, paddle wheel boat designed. 1418, authentic wood engraving. 1420, observatory at Samarkand. 1420, sawmill at Madeira. 1420, velocipede, Fontana. 1420, war wagon, Fontana. 1423, first European woodcut. 1430, turret windmill. 1436, scientific cartography, Banco. 1438, wind turbine, Mariano. 1440, laws of perspective, Alberti. 1446, copperplate engraving. 1440 to 1460, modern printing, Gutenberg. Ansko e pound fur. 1457, rediscovery of wagon on springs referred to by Homer. 1471 1472. Foundations of trigonometry, Jama Iller Regiomontanus. Iron cannon balls. Observatory at Nuremberg by Bernard Walther. 1472 to 1519, Leonardo da Vinci made the following inventions. Centrifugal pump. Dredge for canal building. Polygonal fortress without works. Breech loading cannon. Rifled firearms. Anti-friction roller bearing. Universal joint. Conical screw. Rope and belt drive. Link chains. Submarine boat. Bevel gears. Spiral gears. Proportional and paraboloid. Compasses. Silk doubling and winding apparatus. Spindle and flyer. Parachute. Lamp chimney. Ship's log. Standardized mass production house. 1481, canal lock, Dionisio and Petro. Domenico. 1483, copper etching, Wenceslas von Allnitz. 1492, first globe, Martin Beheim. 16th century. Tinning for preservation of iron. Windmills of 10 HP become common. Much technical progress and mechanization in mining industries, spread of blast furnaces and iron molding. Introduction of domestic clock. 1500, first portable watch with iron mainspring, Peter Henlein. 1500, mechanical farming drill, CAV. Alana, 1500 to 1650, intricate cathedral clocks. Reach height of development 1508, multicolored woodcut. Technics and Civilization. 440. 1511, pneumatic beds, vegetables. 1518, fire engine, planer. 1524, fodder cutting machine. 1528, reinvention of taximeter for coaches. 1530, foot-driven spinning wheel, Georgens. 1534, paddle wheel boat, Blasco de Garay. 1535, diving bell, Francesco del Marchi. 1539, first astronomical map, Alessandro Piccolomini. 1544, Cosmographia Universalis, Sebastian Münster. 1544, elaboration of algebraic symbols, Stiefel. 1545, modern surgery, Ambroise Paré. 1546, railway in German mines. 1548, water supply by pumping works, Augsburg. 1550, first known suspension bridge in Europe, Palladio. 1552, iron rolling machine, Bruyère. 1558, military tank. 1558, camera with lens and stop for diaphragm, Danielo Barbaro. 1560. Academia Secretorum Naturae at Naples, First Scientific Society. 1565, lead pencil, Gessner. 1569, Industrial Exhibition at Rathaus, Nuremberg. 1575, Heroes Opera, translation. 1578, Screw lathe, Jacques Besson. 1579, Automatic ribbon loom at Danzig. 1582, Gregorian calendar revision. 1582, tide mill pump for London, M. O. Rice. 1585, decimal system, Siemens Devine. 1589, knitting frame, William Lee. 1589, man-propelled wagon, Gilles de Baume. 1590, compound microscope, Janssen. 1594, use of clock to determine longitude. 1595, design for metal bridges, arch and chain, Veranzio. 1595, wind turbine, Veranzio. 1597, revolving theater stage. 17th century. Water IV heels of 20 HP introduced, transmission by means of reciprocating rods over distance of 1/4 mile. Glass hothouse comes into use. Foundations of modern scientific method. Rapid developments in physics. 1600, dibbling of wheat to increase yield, Platt. 1600, treatise on terrestrial magnetism and electricity, Gilbert. 1600, pendulum, Galileo. 1603, Academia dei Lincei at Rome. 1608, telescope, Lippersheim. 1609, first law of motion, Galileo. 1610, discovery of gases, Van Helle. Mont. 1613, gunpowder in mine blasting. 1614, discovery of logarithms by John Napier. 1615, use of triangulation system in surveying by Willebrord Snell van Rooyen, 1581 to 1626. 1617, first logarithm table, Henry Briggs. 1618, machine for plowing, manuring, and sowing, Ramsey and Wilgoose, 1619, use of coke instead of charcoal. In blast furnace, Dudley, 1619, tile making machine 1620, adding machine, Napier, 1624, submarine, Cornelius Drebbel. Went 2 miles in test between Westminster and Greenwich 1624, first patent law protecting inventions, England, 1628, steam engine, described 1663. By Worcester, 1630, patent for steam engine, David. Ramsey, 1635, discovery of minute organisms. Leeuwenhoek, 1636, infinitesimal calculus, Fermat, 1636, fountain pen, Schwenter, 1636, threshing machine, Van Berg. Inventions. 441. 1637, periscope, Hevel, Danzig. 1643, barometer, Torricelli. 1647, calculation of focuses of all forms of lens. 1650, calculating machine, Pascal. 1650, magic lantern, Kircher. 1652, air pump, Vigueric. 1654, law of probability, Pascal. 1657, pendulum clock, Huygens. 1658, balance spring for clocks. Hooke. 1658, red corpuscles in blood. Schwammerdam. 1660, probability law applied to insurance, Jan de Witt. 1665, steam automobile model, Ver. Beest, S.J. 1666, mirror telescope, Newton. 1667, cellular structure of plants. Hooke. 1667, Paris Observatory. 1669, seed drill, Whirlage. 1671, speaking tube, Moreland. 1673. New type fortification, Va. Ban. 1675, first determination of speed of light, Romer. 1675, Greenwich Observatory founded. 1677, foundation of Ashmolean Museum. 1678, power loom, Dijon. 1679 to 1681, first modern tunnel for transport, 515 feet long, in Languedoc Canal. 1680, first power dredge, Cornelius Meyer. 1680, differential calculus, Leibniz. 1680, gas engine using gunpowder. Huygens. 1682, law of gravitation, Newton. 1682, 100 HP pumping works at Marly, Rannigan. 1683, industrial exhibition at Paris. 1684, fodder chopper run by water power, Delabate. 1685, foundation of scientific obstetrics, Van Deventer. 1687, Newton's Principia. 1688, distillation of gas from coal, Clayton. 1695, atmospheric steam engine, Popin. 18th century. Rapid improvements in mining and textile machinery. Foundation of modern chemistry. 1700, water power for mass production, Palm. 1705, atmospheric steam engine, New Common. 1707, physician's pulse watch with second hand, John Flogger. 1708, wet sand iron casting, Derby. 1709, coke used in blast furnace, Derby. 1710, first stereotype, Vandermeer and Muller. 1711, sewing machine, de Camus. 1714, mercury thermometer, Fahrenheit. 1714, typewriter, Henry Mill. 1716, wooden railways covered with iron. 1719, three-color printing from copper plate, L.E. Blonde. 1727, first exact measurement of blood pressure, Stephen Hales. 1727, invention of stereotype, Ged. 1727, light images with silver nitrate, Schultz, c. 1839. 1730, stereotyping process, Goldsmith. 1733, flying shuttle, K. 1733, roller spinning, Wyatt and Paul. 1736, accurate chronometer, Harrison. 1736, commercial manufacture of sulfuric acid, Ward. 1738, cast iron rail tramway, at Whitehaven, England. 1740, cast steel, Huntsman. 1745, first technical school divided from army engineering at Braunschweig. 1749, scientific calculation of water resistance to ship, Euler. 1755, iron wheels for coal cars. Technics and Civilization. 1756, cement manufacture, Smeaton. 1763, modern type chronometer, L.E. Roy. 1761, air cylinders, piston worked by water wheel. More than tripled production of blast furnace, Smeaton. 1763, first exhibition of the industrial arts. Paris. 1763, slide rest, French Encyclopedia. 1765 to 1769, improved steam pumping engine with separate condenser, Watt. 1767, cast iron rails at Coalbrookdale. 1767, spinning jenny, Hargreaves. 1769, steam carriage, Cugnot. 1770, caterpillar tread, R. L. Edgeworth, c. 1902, 1772, description of ball bearing. Narlow. 1774, boring machine, Wilkinson. 1775, reciprocative engine with wheel. 1776, reverberatory furnace, Brothers. Cranig. 1778, modern water closet, Brahma. 1778, talking automaton, Von Kem. Pelen. 1779, bridge cast iron sections, Darby. And Wilkinson, 1781 to 1786, steam engine as prime mover, Watt. 1781, steamboat, Geoffroy. 1781, drill plow, Proud, also used by Babylonians, 1700 to 1200 BC. 1782, balloon, J.M. and J.E. Montgolfier. Original invention Chinese. 1784, puddling process, reverberatory furnace, Court. 1784, spinning mule, Crompton. 1785, interchangeable parts for muskets, L.E. Blanc. 1785, first steam spinning mill at Papelwick 1785, power loom, Cartwright, 1785, chlorine as bleaching agent. Burt-Hollett, 1785, screw propeller, Brahma, 1787, iron boat, Wilkinson. 1787, screw propeller steamboat. Fitch, 1788, threshing machine, Meikle, 1790, manufacture of soda from NaCl. L. E. Blanc, 1790, sewing machine first patented. M. St. England, 1791, gas engine, Barker, 1792, gas for domestic lighting, Moore. Dock, 1793, cotton gin, Whitney, 1793, signal telegraph, Claude. Chap, 1794, École Polytechnique founded 1795 to 1809, food canning, Appert, 1796, lithography, Seinefelder, 1796, natural cement, J. Parker, 1796, toy helicopter, Cayley, 1796, hydraulic press, Brahma, 1797, screw cutting lathe, Maudslay. Improved slide rest metal lathe. Maudslay, 1799, Humphrey Davy demonstrates anesthetic properties of nitrous oxide. 1799, Conservatoire National des Arts. E. T. Métiers, Paris, 1799, manufactured bleaching powder. Tennant. 19th century. Enormous gains in Poivre conversion. Mass production of textiles, iron, steel, machinery. Railway building era. Foundations of modern biology and sociology. 1800, galvanic cell, Volta, 1801, public railroad with horsepower Wandsworth to Croydon, England. 1801, steamboat Charlotte Dundas. Symington, 1801 to 1802, steam carriage, Trevithick, 1802, machine dresser for cotton warps, necessary for power weaving, 1802, planing machine, Brahma, 1803, side paddle steamboat, Fulton, 1804, jacquard loom for figured fabrics. Inventions. 443. 1804, Oliver Evans amphibian steam carriage. 1805, twin screw propeller, Stevens, 1807, first patent for gas-driven automobile, Isaac de Rivaz, 1807, chymograph moving cylinder for recording continuous movement, Young, power loom, Horrocks, grass tedder, Salmon, steam printing press, Koenig, push cycle, Drays, milling machine, Whitney, stethoscope, Lanuck, Bentwood, Sargent, incandescent lamp, De La Rue, modern planes, George Rennie, iron steamboat, A. Manby, first scientific congress at Leipzig, steel alloys, Faraday, principle of motor, Faraday, 1843. Calculating machines, Babb. Beige, Portland cement, Aspton, electromagnet, William Sturgeon, Stockton and Darlington Railway. 1843, Thames Tunnel, Mark I. Brunei, reaping machine, Bell. First used in Rome and described by Pliny, steam automobile, Hancock, high-pressure steam boiler. 1,400 pounds. Jacob Perkins, chromolithography, Zahn, hot blast in iron production, J. B. Nielsen, machine-made steel pen, Gillett, blind print, Braille, filtration plant for water, Chelsea Water Works, London, Liverpool and Manchester Railway, sewing machine, thermometer, paper matrix stereotype, GE. New, compressed air for sinking shafts and tunnels underwater, Thomas Cochrane. Elevators, used in factories. Reaping machine, McCormick. Dynamo, Faraday. Chloroform. Water turbine, Fornaren. Magnetic telegraph, Gauss and Weber, laws of electrolysis, Faraday, electric battery in power boat. M.H. Jacobi, aniline dye in coal tar, Runge, workable liquid refrigerating machine, Jacob Perkins, application of statistical method to social phenomena, Quit. Let, commutator for dynamo electric telegraph electric automobile, Davenport, first application of electric telegraph to railroads, Robert Stevenson, electric motor, Davenport, needle telegraph, Wheatstone, electromagnetic telegraph. Morse, single wire circuit with ground. Steinheil, steam drop hammer, Nasmith, two-cycle double-acting gas engine, Barnett, propeller steamship, Ericsson. C1805, boat driven by electric motor. Jacobi, manganese steel, Heath, electrotype, Jacobi, calotype, Talbot, daguerreotype, Niepce and de Guerre, hot vulcanization of rubber. Goodyear, Grove's incandescent lamp corrugated iron roof east. Counties Railroad Station microphotography, Dunn, first steel cable suspension. Bridge, Pittsburgh, Roebling, paper positives in photography. Talbot. 1841, conservation of energy, Vaughan 1853. Meyer. 1842. Electric engine, Davidson, 1853, 1842, conservation of energy, J.R. von Meyer, 1854, 1843, aerostat, Henson. 1843, typewriter, Thurber, 1855, 1843, spectrum analysis, Miller. 1843, gutta percha, Montgomery, 1855. 1844, carbon arc lamp, Paucalt, 1855. 1844, nitrous oxide application, Dr. 1855. Horace Wells C. 1799 1855. 1844, practical wood pulp paper, Kell 1856. Ler, 1856. 1844, cork and rubber linoleum, Gell 1856. Lowe, 1858, 1845, electric arc patented, Wright, 1845, modern high-speed sewing machine, Elias Howe, 1859, 1845, pneumatic tire, Thomson, 1845, mechanical boiler Stoker 1859 1846, rotating cylinder press, Ho, 1860 1846, Ether, Warren and Morton, 1860 1846, nitroglycerin, Sobrero, I-860-1846, gun cotton, C.F. Sean Bain, 1861 1847, chloroform anesthetics, J.Y. 1861. Simpson, 1862. 1847, electric locomotive, M.G. Farr 1863. Mayer, 1863. 1847, Iron Building, Bogardus, 1864 1848, Modern Safety Match, RC. Botker, 1864. 1848, Rotary Fan, Lloyd, 1864 1849. Electric Locomotive, Page. 1850, Rotary Ventilator, Fabry, 1865 1850, Ophthalmoscope. 1851, Crystal Palace. First Interna 1866. Chanel Exhibition of Machines 1867. And the Industrial Arts, Joss 1867. F. Paxton, 1867. 1851, Electric Motor Car, Page, 1867. 1851, Electromagnetic Clock, Shep 1867. Herd, 1868. 1851, Reaper, McCormick, 1869 1853, Science Museum, London. 1853, Great Eastern Steamship 680 1870. Feet long watertight com 1870. Apartments 1870 1853, Mechanical Ship's Log, William. Siemens, 1870. Mass Production Watches, Denny. Sun, Howard and Curtis, Multiple Telegraph on Single Wire. Gintel, Automatic Telegraph Message Recorder, Hughes, Commercial Production of Aluminum, DeVille, 800 HP Water Turbine at Paris Television, K-Cell, Iron-Plated Gunboat Safety Lock, Yale, Open Hearth Furnace, Siemens, Bessemer Converter, Bessemer, Color Photography, Zenker, Phonautograph. Voice vibrations recorded on revolving cylinder, Scott, oil mining by digging and drilling, Drake, storage cell, plant, ammonia refrigeration, Care, asphalt paving 1863, London Underground 1864, dynamo motor, Passanotti, machine gun, Gatling, monitor, Ericsson, gas engine, Lenore, ammonia soda process, Solvay, theory of light and electricity. Clerk Maxwell, motion picture, Ducos, and 1875, gasoline engine motor. Carr, S. Marcus, pasteurization of wine, L. Pasteur, practical dynamo, Siemens, dynamite, Nobel, reinforced concrete, Monnier, typewriter, Scholes, gas engine, Otto and Langen, two-wheeled bicycle, Michaud, tungsten steel, Mouchet, periodic table, Mendelejev and Lothar Meyer, electric steel furnace, Siemens, celluloid, JWNIS Hyatt, application of hypnotism in psi. Show pathology, Charcot, artificial matter dye, Perkin. 1871, aniline dye for bacteria staining. Weigert, 1872, model airplane, A. Penod, 1872. Automatic air brake, Westinghouse, 1873, ammonia compression refrigerator Carl Linde, München, 1874, streamlined locomotive 1875, electric car, Siemens, 1875, standard time, American Railroads, 1876, Bone March at Paris, Boileau. And G. Eiffel, 1876, discovery of toxins 1876, four-cycle gas engine, Otto, 1876, electric telephone, Bell, 1877, microphone, Edison, 1877, bactericidal properties of light established, Downs and Blunt, 1877, compressed air refrigerator, J. Coleman, 1877, phonograph, Edison, 1877, model flying machine, Kress, 1878, centrifugal cream separator, de Laval, 1879, carbon glow lamp, Edison, 1879, electric railroad 1880, cup and cone ball bearing in. Bicycle 1880, electric elevator, Siemens, 1882, first central power station, Edison, 1882, motion picture camera, Marley, 1882, steam turbine, de Laval, 1883, dirigible balloon, Brothers Tis. Sandier, 1883, high-speed gasoline engine. Daimler, 1884, steel frame skyscraper, Chicago, 1884, cocaine, Singer, 1884. Linotype, Mergenthaler, 1884, turbine for high falls, Pelton, 1884, smokeless powder, Duttenhofer, 1884, steam turbine, Parsons, 1885, International Standard Time 1886, aluminum by electrolytic process. Hall, 1886, hand camera, Eastman, 1886, aseptic surgery, Bergman, 1886, glass blowing machine 1887, polyphase alternator, Tesla. 1887, automatic telephone. 1887, electromagnetic waves, Hertz. 1887, monotype, Levi-Stone. 1888, recording adding machine, Burroughs. 1889, artificial silk of cotton refuse, Chardonnay. 1889, hard rubber phonograph records. 1889, Eiffel Tower. 1889, modern motion picture camera, Edison. 1890, detector, Branly. 1890, pneumatic tires on bicycles. 1892, calcium carbide, Wilson and Wausau. 1893 to 1898, diesel motor. 1892, artificial silk of wood pulp, Cross, Bevan, and Beetle. 1893, moving picture, Edison. 1893, byproduct coke oven, Hoffman. 1894, Jenkins Phantoscope, first moving picture of modern type. 1895, motion picture projector, Edison. 1895, X-ray, Röntgen. 1896, steam-driven aerodrome flight 1/2 mile without passenger, Langley. 1896, radio telegraph, Marconi. 1896, radioactivity, Becquerel. 1898, osmium lamp, Welsbach. 1898, radium, Curie. 1898, Garden City, Howard. 1899, loading coil for long-distance telegraphy and telephony, Pupin. 20th century. General introduction of scientific and technical research laboratories. 1900, high-speed tool steel, Taylor and White, 1900, Nernst lamp 1900, quantum theory, Planck, 1901, National Bureau of Standards. United States 1902, Caterpillar tread improved. C. 1770 1902, radial type airplane engine. Charles Manley. Technics and Civilization. 1903, first man-lifting airplane, or 1907. Ville and Wilbur Wright, 1907. 1903, electric fixation of nitrogen 1907. 1903, arc process nitrogen fixation 1908. Bjerke-Eland Enid. 1903, radio telephone 1909. 1903, Deutsches Museum, München, 1910. 1903, oil burning steamer 1910, 1903, tantalum lamp, von Bolton. 1904, Fleury tube 1912. 1904, Moore tube light 1913, 1905, rotary mercury pump, Gied. 1905, cyanamide process for nitrogen 1920. Fixation, Roth, 1922. 1906, synthetic resins, Bjerke-Eland, 1927. 1906, Audion, De Forest, 1933. Automatic bottle machine, Owen. Tungsten lamp. Television photograph, Korn. Technisches Museum für Industrie und Gewerbe, Wien. Duraluminium, Wilm. Gyrocompass, Sperry. Synthetic ammonia process for nitrogen fixation, Haber. Vitamins, Hopkins. Tungsten filament light, Coolidge. Radio broadcasting. Perfected color organ, Wilfrid. Radio television. Aerodynamic motor car, Fourier.